Welcome to this full 10-hour journey into machine learning and deep learning, which is designed to take you from beginner to project ready. Whether you are aiming to start a career in AI or preparing for data science interviews or understanding how real-world intelligence systems work, then this course gives you everything you need. Before we begin, make sure to subscribe to the channel and hit the button so that you never miss any upcoming AI and tech tutorials. Feel free to share this video with friends who wants to learn machine learning or deep learning. And also guys, drop your questions or suggestions in the comment section. Across the next several hours, you will learn the core machine learning algorithms. You're going to build neural networks from scratch, work hands-on with Python, and explore modern deep learning architectures used in the industry. So let's dive in.
I just want you to definitely have a look at it. And that's a very simple code where just take a moment and try to understand if you are able to understand. So you have absolute no idea about deep learning. Now, here, when you look at a code like this, you will be like, oh my God, what is this? Then when you look at a code like this, just have a look at the code. So at least, maybe some of you may say that, yes, Darshan sir, we understand we are trying to import something from here. Agreed. Chalo, you are smart. Here you say that, okay, fine, there is something which is getting loaded, sir, but I don't understand what is this X train and what is this underscore. And here is something is converting the data type, but what is this expanding? We never studied. Are you having the similar kind of questions which I'm trying to say right now? I'm just in the convincing mode for you. Yes. Right. Then now this is the place where I am creating a neural network. Do you understand exactly what is happening from the mathematical perspective in this blue box? Anything? Anything? You need to understand how to create a neural network over here. Then after that, we do something. So precisely what I want to say is this is absolutely clueless. And if we have to understand it very properly, then we need to be very smart while doing the things. Let's get started. So I was saying over here, this is AI, which comprises of machine learning, which comprises of deep learning, which comprises of generative AI, which comprises of LLMs. Then AI, machine learning, deep learning, generative AI, and LLM, right? So today, let us discuss about the ML stuff. So machine learning is all about predictive analytics. Machine learning is, and see, we are not learning machine learning in deep. I'm only giving you that much idea which is required for executing any project, right? So that, when I step into deep learning, all of these things look relevant to you. So we said we have total 14 classes, right? So I say first is ML regression. Second is ML classification. Third is deep learning, neural network creation. Fourth is convolutional neural network. These are the names of the classes which I'm planning. Recurrent neural network, LSTM, and GRU. Then sixth is, now we are good to get started into the generative AI stuff. So one thing that we can get started over here in the generative AI is going to be the GAN, which is the topic. Then seventh one is going to be the variational autoencoder. All of these are advanced topics. Then eighth one is going to be the Hugging Face. Ninth one is going to be the OpenAI API. The 10th one will be your LangChain. We need to do the sixth one would be this is there in our course, attention mechanism and transformer architecture. Then we talk about the seventh one, which is text generation using attention mechanism. Then the eighth one would be GAN. Ninth one would be VAE. 10th one would be this. 11th one would be this. 12th one would be this. Fine tuning that can be done using OpenAI Playground and API. But before that, 13th will be the concept of RAG. Yeah. Yes, I hope it's sorted now, right? Yeah. So I'll just make a note, okay. Deployment if possible. It depends on how much time. I'll show you, don't worry. I'll that I'll say. Right. I think this is what we can finalize, right? So let's see how the things go ahead. And this is something which is important for us. This is like the pathway for us getting started. But there is a small drawback of the way we are proceeding because we have our course end projects as well, right? So the course end projects will talk about all of these things, GANs and VAs. So we will have to little bit work from that perspective as well. Let's see how we can do it the best. Yeah, so going ahead with this, I was saying machine learning is all about predictive analytics. So if you want to predict the prices of a stock, you want to predict how or when a machine is likely to stop functioning even before it actually stops functioning. So machine learning is really useful in such scenarios. So I'll get this thing in a very, very simple way for you. So have you heard the story of the lion and fox? Everyone must know this. No worries. I'm going to tell it to you right now. So here, friends, so I was saying the lion in this case is going to be nothing but the manager. So I was saying, so we have lion and he is the manager. And he hired a fox, and this fox is you, a data scientist. So the lion hired the data scientist, and the aim was to help him catch a prey. Remember this. The lion hired a data scientist to help him catch a prey. So it's not easy for a lion to catch a prey. Have you ever heard, if you have ever been on a jungle safari, when a lion is moving across a jungle, birds start to chirp, monkeys starts to scream, and it's a way of signaling other animals like deer, zebras, etc., that the lion has entered this area and vacated this area. So if a lion has to ever hunt, he actually has to hide through the trees so that no one notices him, and then he is able to catch the prey. So that is the irony of jungle. When a lion takes around 20 to 25 attempts, probably one time he is able to catch the prey successfully. So now this is just like the story of the Sher Khan, where the lion hired a data scientist to help him catch a prey. Now, what did the fox do? The fox is the data scientist. He started doing the survey of the jungle. What did I say? The fox did survey, and this survey took him almost 1 month, and he did a detailed survey of the jungle. And you know what the fox came up with? The fox came up with to the lion saying that, my dear boss, in your jungle, there are 5 giraffes. There are 105 deers. There are 15 elephants. And there are 50 buffaloes. And there are also 3 hunters. Now, my question to you all is, the lion hired this guy to help him catch the prey. After 1 month, he has come up with this information. Do you think, is this information helpful for the lion to catch the prey? I mean, just say, I mean, I'm not looking from the data science perspective. Just let me know that if you are the lion and if the fox comes to you, do you think this information is helpful for the lion to help him catch a prey? So if I am very hungry, I will not go behind the giraffes or the elephants because they are available in limited number, but deers are available in ample number. So the chances or the probability of hunting and killing a deer is very high as compared to all other animals. This is exactly what you are trying to say in your chats. Am I correct? Yes. So friends, what is done by the fox is called as descriptive analytics. So you know what does descriptive analytics basically consist of? It consists of various functions like count or sum, min, max, mean, median, mode, standard deviation, variance, kurtosis, skewness. If you don't know some of these terms, that's completely okay for now. But all of this comes under the descriptive statistics, and it will help the lion in helping him spot his future hunting ground. Now, this fox continued with his work, and now he took another 2 months. So the fox now came up to the lion with this. He says that, my dear boss, this is where you live. Huh, that's your home. In your jungle, there is a pond, and animals usually come to drink water over here every day between 1:30 p.m. to 2 p.m. Now you tell me, is this information further useful for the lion? Rather than hunting throughout the day and getting tired, he knows that now I can maybe target for deer in the time duration 1:30 p.m. to 2:30 p.m. because everyone is likely to be found here. That is awesome. That is something which is really awesome. Yes, this is information, right? Now, what if the next information that he says that, my dear boss, there are two ways you can go from your home to the jungle. That's the first way. And on this way, now there are a lot of pits, valleys, forests, mountains. So it's not really easy to go this way. But yeah, I mean, this is another way. Now the question is, when you have some algorithm in machine learning, imagine this to be machine learning algorithm 1 and machine learning algorithm 2. Which algorithm will you choose in real life? Or let's say there is further one more machine learning algorithm 3. Among these three, which one will you choose? Well, tell me, among these two ways, which one will you as a lion choose to go to the pond? One or two? With this, obviously, a simple understanding is among one and two, this way one is shorter. So you will choose the way one. Okay, simple understanding is this. But the surprise is here, friends. We never discuss about these three people. The fox further says that, boss, wait. Before you take a decision, let me tell you that I once discussed that there are three hunters also in the jungle. So these hunters usually do the hunting on this, in this area. Now, my dear foxes, which path will the lion choose if you give this information to the lion? So essentially, what am I trying to tell you is, it is not always in machine learning that choosing the fastest algorithm. No, it is not always in machine learning that you have to choose the fastest algorithm. You have to choose the algorithm which is optimized. Well, that purely depends on the business use case. Like, for example, I was saying that, see, if uh if we have, I might have discussed this example, I'm discussing it once again. If I look at the ADAS system of the car where right? So the duty of the ADAS system of the car is when the car is there on autopilot, then if any person comes all of a sudden, the car must apply brakes. The car must apply brakes. Okay. Now, what is more important in this case? If a person comes, brakes must be applied, right? And if a person doesn't come, brake must not be applied. What if I say that if there is a person but the brakes are not applied, that's hazardous, right? If there is a person and imagine the brakes are not applied, then accident, very much possible. It is, listen to me, it is okay even if the car thinks that there is a person in front when there is no person and it brakes. But it is not okay under any circumstance when there is actually a person and it does not brake. I repeat, listen to me one last time. It is okay if my car thinks that there is a person standing in front when ideally no one is there, but it still brakes a little bit. But it is not okay when there is actually a person and it does not brake. You agree to this? We want safety. So over here, what is important to us is safety, and we want a fast model. We want a fast model with relatively lesser accuracy is tolerable. Of course, I will try for the best accuracy, but if I'm getting relatively lesser accuracy, but it is fast, I am okay. False positive is okay. Yes. But if you talk about ACP Pradyuman, right? Everyone knows na, who is ACP Pradyuman? Yes. Everyone knows na, who is ACP Pradyuman? Yes or no? Yes, I'm basically referring to the CID, Crime Investigation Department. Okay, you don't watch TV? Such a famous serial. हाँ दया कुछ तो गड़बड़ है. And then some of them who are not aware of Hindi, they might not know it. But anyways, no problem. So ACP Pradyuman is just a very famous character from CID. So ACP Pradyuman, right? So yeah, this is the famous CID character, right? So Crime Investigation Department. I just took his name for fun. So here, let's say we have found a criminal, so he is a, rather than saying suspect, rather than saying he is a suspect. And now ACP Pradyuman wants to check whether has this person committed any crime before by going through the database. By going through the database. So his face would be matched with all the faces in the CID records. Now, what is more important over here? I am okay if my model is slow, but I need a really high accuracy. It is okay if my model is taking 1 minute to match this face with all the faces, but it must come back to me with the correct output. If this person has earlier committed some rape or murder or anything, his face must match. His face under any circumstance should not be missed while matching. So here what is important is accuracy. Over there, what was important is speed. I am talking about how you choose a machine learning model purely depends on the business use case. So what was done by the fox here in helping that, okay, this is where most of the animals come, choose this road. Well, this is what you call as predictive analytics. This is exactly what you call as predictive analytics. And what you see over here is about optimization of machine learning algorithm. So now with this background, we are good to get started with the introduction to machine learning. So let's get started with ML now. So machine learning is broadly divided into two types. Supervised, unsupervised. Both of them are important, but our course is on generative AI, so we will not be discussing both. We are just going to discuss supervised. There is third type as well, which is semi-supervised, fourth type as well, which is reinforcement. We are only discussing this. So I was saying machine learning is of two types, supervised and unsupervised machine learning. Now, what is supervised machine learning? Well, supervised machine learning is the case where you have label data, and unsupervised machine learning is the place where you have unlabeled data. What does that mean? Well, before you understand this, it's important to get into little more fundamentals. Yes, we had discussed this. Yes, that's very correct, Malik. So, friends, what I am saying is initially, this is what is already discussed. I'm just giving you a glimpse of traditional programming paradigm. Earlier, what used to happen is you used to have a computer and any program that has to be developed. Let's say you want to write a very basic program for performing, let's say, even addition of two numbers. Then on the computer, who will be writing the program? A software developer. So this program was written by a software developer on the computer. Then to check whether the program is working fine or not, the next thing that we had is we were giving inputs. So let's say if this is a program for addition, we can give inputs like 2 and 3, and we expect the output to be 5. If I give input as 1.1 and 2.2, we expect the output to be 3.3. So this output was always deterministic in nature, where 2 and 3 addition will be 5 only. It will not be 5.01. 1.1 and 2.2 when added will be 3.3 only, not 3.301. So that was how the earlier softwares are developed. But now, how is the machine learning programming paradigm? So in machine learning programming paradigm, I'm actually copying the same figure. Computer is there. We have this inputs. And we have this outputs. But the thing is, now your inputs are here only. But the output, which was there on the right-hand side, has shifted to the left-hand side. And the program, which is there on the left-hand side, is shifted to the right-hand side. So essentially, the program is now written by a computer. The program is written by a computer. So how does that happen? Well, this happens exactly in the same way, where a question bank and answer bank of 100 questions. First thing what we do is we divide it into two parts. We already know about it. And usually it is 80% and 20%, but not mandatory. But usually people start with this, where the first part is called as train. Next is called as test, where this is exactly what I was calling as inputs and outputs. So here you have 80 questions, and here you have 80 answers, which are going as input. And the machine understands the pattern in between the 80 questions and the 80 answers over here. The machine understands the relationship between this and then creates a program, or this program in technical words is also called as the machine learning model. Now, how to check? Because see, who has created this program? Did you create it? No. This program is created by a machine. So whether to trust or not this particular model is a big question. So what we do? Well, technically we call this question bank as X and answer bank as Y. So this is X train. This is Y train. Similarly, this is X test. Then here, X train, Y train, X test, Y test. This is what we have. And then what is given as input when I say 80 questions is your X train and Y train. The model understands the relationship between them, uh, and it is creating a model. Now, how to check whether the model is good or not? Well, I can do one thing. I can give over here X train, and I'll be getting in return prediction. So if I'm giving this 80 questions, of course, I'll be getting 80 responses. I prefer to call this as Y pred on the train. And I can also try giving over here X test, which is something which it has never seen. So my prediction would be these 20 answers. I prefer to call this as Y prediction on the test. So the next thing that we do is I try to compare this, and I found the accuracy. This is after comparing, I am going to print the train accuracy. Similarly, this and this I can compare because I have the actual answer and I have to predicted answer. So I'm going to compare and print the test accuracy. So basically, I understand that my model, what I did, I asked the model to understand the relationship in between X train and Y train. So that intelligence is now saved here. So now whether he has actually studied it nicely or not, what I do is I give X train. X train is I give this part 80 questions over here. So I'll be getting the predictions, which is this. Now, once I have these predictions, now these are my predictions and these are my actuals. I can compare this 80 responses, 80 predictions, and I get the accuracy on the training data set. How good are the predictions on the training data? Similarly, I gave over here X test, which is this. So when I give X test, it gives predictions, which are this. Then what will I do? I'll compare this actual with this predicted. I'll be getting again the test accuracy. And then depending on this, I conclude. So the question is, what is a good model? And this applies for machine learning, deep learning, computer vision, NLP, generative AI, everything. What is a good model? A good model is the one wherein both of the below conditions are satisfied. Number one, test accuracy must be greater than equal to 80%. Number two, train accuracy minus test accuracy, the difference must be less than equal to 5%. That's important. The difference in between the two must be less than equal to 5%. That is what is important. Okay. Now, so I am planning to buy a mobile phone. So we all know that the price of a phone depends on the brand of the phone. Yes, I mean, Apple phones are costlier. Samsung is relatively cheaper. And then Oppo, Vivo are more cheaper, etc. It also depends on the RAM of the phone, ROM of the phone, processor of the phone, screen size of the phone, screen type of the phone, and many other factors. I did not say that the price of the phone is dependent on its features. I didn't say that. I wrote down the features one by one. I didn't say that the price of the phone is based on features. Greater the number of features, greater is the price. I did list it down over here very appropriately. I say, if I'm trying to look at the price of a house. So friends, price of the house depends on what? Let's say I'm looking for a house in a tower on 10th floor. So the price will depend on what all factors? Oh, yes, that's perfect. So the first one is the area of the house in square feet. That's correct. Location matters, as you said. Dimension is fine. And then floor number is important. Then builder is correct. Builder is correct. But you cannot say amenities. So whose society is better? You're getting the point. You cannot say amenities. Then you are giving incomplete information to predict the price. Right? So you have to say, right? Yes. So you have to actually say that, hey, whether the swimming pool is there or not, whether the garden area is there or not, then yes, location as we wrote, that's correct. Window facing or not, yes. Then we can also look at features like uh, whether uh, it is near to the subsidy market or not, whether how much is the distance to the hospitals nearby, where will the kids go, are there schools and colleges nearby? These are also important, now. You are getting everything cheap, but the school is 50 kilometers away. Connectivity, yes, that's important, right? So connectivity is again a very generic term, Sanjeev. You can say that, distance to railway station, distance to bus stop, age of the house, and end of this topic. Okay, now next. Now tell me, in one hand I have apple, in another hand I have orange. How do you figure out that this is an apple and this is an orange? Yes, color, shape, taste, okay. Texture, very good point. Why didn't anyone think of smell? Yes, fragrance. Now I got that point. And if I get into technicalities, you can look at the vitamin content, mineral content, etc., etc. If you look at these three flowers, iris data set. So this is a data set where you have three different flowers of the same species iris. And the way we are differentiating it, is by finding out sepal length, sepal width, petal length, petal width. So this is found out for total 150 flowers, 50 of setosa, only two are shown, 50 of versicolor and 50 of virginica. So the last example is iris dataset, which says based on petal length, petal width, sepal length, and sepal width, the classification of the flower is done. And this iris data set, setosa versus versicolor versus virginica. Now here, friends, we understand that the price of the phone is dependent on these all factors. The price of the house is dependent on these all factors. Whether it is an apple or orange is dependent on these all factors. Whether it is setosa or versicolor or virginica is dependent on these factors. So because these all things are dependent on them, I call this in machine learning as dependent variable. And because they are not dependent on them, we call it as independent variables. In machine learning, independent variables are usually given by capital X and dependent variables are given by capital Y. Now, so I can say over here that this is Y, X1, X2, X3, X4, X5, X6. Right? This is how it is happening. Then, so now if you look carefully, example number 1 and 2 and example number 3 and 4, there is a difference. So in example number 1 and example number 2, the dependent variable is continuous in nature because price of the phone can be anything. Price of the house can be anything. But if you look into example number 3 and example number 4, over here, Y is categorical in nature because you will either predict it as apple or orange. It will not be a combination of two. Here also, you'll either predict the flower as setosa or versicolor or virginica. It won't be a combination of the two. So this is what gives me an idea about my topic when I say that machine learning is divided into, let's say, three types, where the first one I said is supervised machine learning. So here I said we have labeled data. Labeled data means independent and dependent variable both are available. Whereas when you talk about the unsupervised machine learning, you have unlabeled data where only X is given and you need to find Y. And the third one is reinforcement learning, which is nothing but learning from our own past experiences. Learning from our own past experiences. So basically, the best example over here is what you can consider is the Tesla's autonomous car. It is already taught with lot of intelligence and it is also learning by itself in real time. So that is an example of reinforcement learning, learning from your own observations. But let's talk about the supervised learning first. Supervised learning is where labeled and unlabeled data both are available. The first part over here is regression, and the next is classification. So regression algorithms are the ones where the target variable is continuous in nature, just like example 1 and 2 above. And classification is the one where it is categorical in nature, just like apple orange example and iris dataset example. So this is how it happens. Unsupervised learning, I can give you an example as clustering. For example, just giving you a brief idea. We are not going to cover about it, but I don't want to leave the stone unturned. So the question is, we are having 28 in the class, including me. If I collect all of our mobile phones, could you all please, everyone is going to look at each other's output. What are they typing in the chat now? I want you to tell me which brand phone are you using. Do not showcase which phone are you using. Only brand. Only brand. Which brand phone do you use? I'm not looking for the phone model. Okay. If I do the same thing in some other cohort, this number may change. We all understand it. What am I trying to say is, if I, as a teacher, is collecting all of your phones and keeping it on a table. So I have 30 phones kept on a table. And I am thinking of clustering it or grouping it on the basis of similarity. And I decided to group it on the basis of brand. I got 3 brands in our class. But if I decide to group it on the basis of RAM here, if I'm doing it on the basis of RAM, how many? So now tell me, looking at our responses, how many unique brands are seen? 3 only. Okay. Then, do you agree that these 3 groups are going to be completely different? A Apple phone can get mixed with a OnePlus phone with respect to RAM, because you're not classifying it on the basis of brand. So now the question is, I can also do it on the basis of processor. I can also do it on the basis of ROM and many other factors, right? Because in unsupervised learning, we do not know why. We are only being given X, and the aim is to find Y. That's the first example of unsupervised learning. And there are few more other things. Like you have one more thing over here that we can consider. So the first one can be clustering. Second one can be feature selection. The third one is dimensionality reduction. And the fourth one is association rule mining. Yes, this is what it is. Okay, so we are getting started with our case study. So we are talking about regression algorithms in machine learning. So let me tell you what is the project that we are doing over here. So our data set basically consists of advertising budget spent on TV, radio, newspaper for determining the sales of a product. So your role as a data scientist is to determine the best regression algorithm for predicting the sales of the product based on advertisement list. Now, what is this? Let us first try to see the data set, then it will become clear. So I say first is let's do the necessary imports. What all things do we require? I require NumPy. Importing NumPy as NP, it is mainly used for numerical computations. I require Pandas for data manipulation and analysis. I require Matplotlib for data visualization, and I'm also taking Seaborn for data visualization. And I'm also loading the warnings library because I want to ignore any kind of warnings. So I am importing the warnings library, and I'm saying that I want to ignore the warnings by using the filter warning function. That's always a good practice to have at the start of every machine learning project. Now the data set is this. I will download it as well. Save as. And here I say df is equal to pd.readcsv advertising data set, and let us look at the number of rows and columns. So this data set consists of 200 rows and 5 columns. Let us look at the head, which is the first 5 rows of the data set. So as I told you, what is the problem now? So the problem is this. This data set consists of advertising budget spent on TV, radio, newspaper. So a company when spends $230,100 for advertisement on TV, $37,800 for advertising on radio, and $69,200 for advertising on newspaper. The sales that it is able to get is $22,100. Similarly, you have 199 more records. So here, friends, these are the three independent variables, and this is the dependent variable. I repeat, that's the independent variable, and that's the dependent variable, and this is the main problem statement. So now, the first thing is the column. This is unnecessary column. I don't want it. So the first thing is, let's drop the unnamed column 0 because it is not useful. So I say, I'll be doing that using the drop function. So I say df.drop, the column name to be dropped, access equal to 1 because it's a column, and in place equal to true. So do it over here only. And that's perfect. Now have a look at this. If I say df.describe, what I understand, pay attention, this is important. This is important, important, important. When I say describe, I see that the average investment on TV is around $150,000. The next highest average investment is on newspaper, and on radio, it is 23. Do you understand that people prefer TV for investment? The second option is newspaper, and the third option is radio because the average of TV is much higher than newspaper, and then radio is the least. This is an insight that everyone needs to observe in any machine learning project. Yes. In the same way, even if you look at the minimum values, it is the highest for TV, then newspaper, then radio, and the maximum values as well. Okay. Also, because there are 200 rows and everywhere I see 200, that means there are no missing values. Okay. Now, let us go ahead and get started with the implementation. Now, the first thing what we need to do is we need to check for the missing values in the data set. So df.isNull.sum, and I always prefer to sort it as I told you earlier as well. So I'm sorting it in the descending order by specifying ascending is equal to false. df.isNull.sum. We have already seen this code. I'm not going to explain again unless and until anyone asks me. Sorting that in the descending order. So all values are 0, therefore there is no sorting. But in case if there was missing value, you know how it is going to look like. So there are no missing values. That's good. Inside from the above output. So we see that there are no missing values in the data set. So let's proceed to the next step. And now I want to visualize the relationship between the features and the target variable. So what am I going to do is I am going to go for df.core, and core will be getting me the correlation. Now pay attention. Okay, let me see. Correct. See, I'll show you what it means. Isnull will see when I say df.isnull, it will give a output something like this. So if it is a false, that means this particular value is not null. This is not null. This is not null. This is not null. But if you see anywhere true, let's say for reason you see true, that means the radio column's fourth value is missing. So what I did is I applied the sum function on that. So it will count how many times it is true in this column, how many times it's true in this column, and so on. Is this value null or not? This is what is null is checking. Is this value null or not? It says no by saying false. Like if you look into the code, the first value, is this null or not? False. That means it is not null. Is this null or not? It says false. That means it is not null. Imagine this value is missing. If it is missing, it is basically written as NaN. NaN stands for not a number. And if it was not a number instead of 60.2, then this would be having true. That means, yes, this value is null. This is what it means. Now we are getting into the correlation. So as you can see, a correlation, right? So this is how correlation ideally is. Like if you see perfect positive correlation, highest value is 1. Perfect negative correlation, lowest value is -1. This is high positive. This is high negative. This is low positive. This is low negative. And this is as good as no correlation. Right. Now, we always need between independent variable and dependent variable. We want this correlation to be high. So if this correlation is high, that means independent variable is responsible for predicting the dependent variable. We always want this value to be high. So here, let's see. So TV versus sales, high correlation, very close to 1. Radio versus sales, decent. And newspaper versus sales. You know what is it saying? This is saying that newspaper is probably not the correct independent variable for predicting the sales. This is not the correct independent variable for predicting the sales. Are you able to understand it? Newspaper is not the correct independent variable for predicting the sales because the correlation has to be either on a +1 side or on the -1 side. This is very close to 0. So it is saying that newspaper is less important for predicting sales. TV is most important and radio is next most important because those values are higher. Higher the value or the close it is to 1, we say it is more relevant. Is that clear to everyone? Right, I'll write down the notes. The correlation between TV and sales is 0.28, which is a strong positive correlation. Between radio and sales is moderate positive. And between newspaper and sales is weak positive. So this means that TV is most important feature for predicting the sales of the product. Then radio is second most important and newspaper is the least most important for predicting the sales. Now, I say, let us separate the features. Features means what? Independent variables and the target, which is the dependent variable. So I will separate out features. So features is TV, radio, and newspaper. These are the features. So I want to have my X. So X is going to be DF of features. So all the features are going to come, and Y will be only the sales. Let us check it out. Oops, newspaper N is small, no? N is small. That's why it gave an error. Radio also R is small. Yeah. So now if I say, see, so this was how the data set is. Yeah, so this is how the data set is. What I said is features are this. So X is DF of features. So DF of features means DF of this. This is X. And Y is DF of sales. This is Y. X and Y. Then similarly, I can also show you Y. Let's say X and Y separated. Now, after separating X and Y, then we do train test split. So there are 200 rows in our data set. So right now, this is the scenario. X1, X2, X3, Y. I am planning to divide it into 80-20. I'll show you other variations also, but for now, I am planning to divide it into 80-20. So I say, let's split the data into training and testing. We use the train test split method. So I say from sklearn dot model selection, import train test split. All right. This will split the data. How? It gives me 4 parts: X train, X test, Y train, Y test. So I'm saying that, hey, I want this X and Y to be further divided into 2 parts. So X will become X train, X test, Y train, Y test. Right? So X and Y will become X train, X test, Y train, Y test. Test size is 80-20. You can play around with this. Right now, I'm keeping it same. And random state is used for the same reproducibility. So 200 rows were there. I'm doing 80-20. So I think there should be 160 rows over here and 40 rows over here. So I say, let's print the shape of this. So 160 and 40, 160, 3, 40, 3, 160, 3, 40, 3, 160, 40, 160, 40, okay. Yeah, it was newspaper. I had written it down also. It was newspaper. If you see, we had written it down here. Newspaper is the least important because the value of newspaper was somewhere around, yes, 0.22. That's correct, Prabhu. But now, here, the least investment is not on newspaper. The least average value is of radio. So we don't want that. So what am I going to do is, see, I am a teacher and I am teaching. Nagdeep, leave that for now. Okay. Let's say, for example, let's say for example, I am teaching Python programming to a group of 50 students in a class. So I see 45 students attend my classes regularly and 5 don't attend this. The names of these 5 are, let's say, Ajay, Vijay, Sanjay, Jay, and Mahesh. As a teacher, I am very concerned about the students. In fact, rather, I am also angry with them. So, I have decided to take out my grudge on them by giving them less marks in the oral exam, even if they perform well. This is what I decided. Now, as a teacher, am I doing the right thing? Tell me. As a teacher, am I doing the right thing? That, okay, let's say Mahesh is coming and Mahesh is answering everything very nicely. I don't know from where he studied, but he is knowledgeable. But still, because he didn't come to my class, I am like, I am going to make him screw. Is that a good characteristic of a teacher? As per ethics, no, right? Yes. As a teacher, where can I give Mahesh actually less marks? Where can I give Mahesh less marks? In the attendance. There are certain columns for attendance. Usually 5 marks or 10 marks are there for attendance. I can give 0 over there. If the university norms allow that, okay, he is not allowed to sit for exam, I can do that. But taking out grudge by giving him less marks is not a right idea. Now, our case, we have TV, radio, and newspaper as the features. The mean values of TV, radio, newspaper are 150, 23, and 30 respectively, right? 150, 23, and 30 respectively. So now let's correlate this example with the student example above. So here, TV has the highest mean value, that is highest attendance in the class. Radio has the second highest attendance and newspaper has the lowest attendance. So, is it fair that the machine learning model gives more importance to TV and less importance to newspaper? Answer is no. See, when a machine learning model is being created, it should give equal importance. Because what am I asking model? To understand the relationship. While understanding the relationship, one should not go ahead with this opinion. One should understand the relationship as it is. And then based on that relationship, if you find that is less relevant, that is good. But while studying only, you are going with the notion. Let's say, for example, you have a subject called as supply chain logistics, and someone told you that it's a very theoretical subject. You attend the class or you don't attend the class, it does not matter. So what happens is, when you go to the subject, even if as a teacher I'm teaching it really very nice, you will be less interested because someone told you that this subject is not important, you pass anyhow, etc., etc. But what about the knowledge? You don't have it. So you should not go ahead with any such kind of assumptions. And that is exactly what I'm saying, that Once you study the subject, then you yourself decide whether it was really worth it or not. In the same way, here as well, I want you to follow the same strategy. So here, so the question is how to make the machine learning model fair to all the features. Well, the answer is feature scaling. So feature scaling is the way you're scaling all the features into a fixed range. And there are various types of feature scaling. So I say there are two common ways of doing the scaling. One is min-max and one is standardization, which is also called as Z-score normalization. What does min-max do? It will scale all the values in the range 0 to 1. I'll explain you, don't worry about that. And this is what standard deviation do. I'll explain you, just observe now what I say. So I am opening Excel. Let's say I have a column like profit. So $100 is the profit. $321 is the profit. $864 is the profit. $9 is the profit. $21 is the profit. $87 is the profit. $34 is the profit. Okay, in this way, I have some values. I want to apply min-max scalar on this. Min-max scalar means all these values will be shrunk in the range 0 to 1 proportionately. So the highest number is 100, this will become 1. The lowest number is 9, this will become 0. And rest all values will be somehow adjusted in the range 0 to 1. You know, this is very similar to the, you all might have seen this cartoon, Aladdin. Yes. So what is the specialty of this genie? Where does this genie live? This genie lives inside the bottle. But how does the genie go inside the bottle? Inside the lamp, right? How does he go inside the lamp or the bottle or the lantern? By, oh, gas. Okay. And after becoming into gas, he comes inside and he becomes small. So this genie, when he enters his home, well, he becomes so small. What is he doing, right? Right from his pony till his tail, every part of his body is shrunk into a very, very small, uh, and everything is shrunk into a smaller region, right? So he's proportionately squeezing his entire body in this range. Min-max scalar is same. It will take the entire data and squash it in the range 0 to 1. Let me show you the formula for that. That's the simple formula. Let's see what it says. It says that you find out the minimum and maximum of the column. Let me find it out. What is the minimum over here? So equal to minimum of this and equal to maximum of this. That's correct? Yes. Then how do I apply the formula? Equal to x, which is 100 minus minimum of x, which is 9, bracket close, divided by maximum minus minimum, 864 minus 9. And yes, I get this value. I will, because I don't want it, as and when I drag it down, see, when I'm dragging it down, I'm getting an error, because what happens is, as I drag it down, this 100 becomes 321, then 864, and so on. But this 9 will shift down to this, then again down and again down, but there are no values. So it's better I lock the cells. How do I lock it? Using the dollar signs. See, the highest value is 1, lowest is 0, rest all values are proportionately adjusted. Okay, if I change this value, let's say the profit is minus $78. So this will become the lowest and everything will become shortened. Let's see. You see that? Minus 78 becomes 0. Okay. If this value I'm making it as the profit is 7866. See, this is the highest value, it became 1, rest all are adjusted. So now imagine if profit column is converted proportionately in the range 0 to 1, then just like profit, if you have any number of columns, like in my case, I have TV column, I have radio column, I have newspaper column, all of this will get converted in the range 0 to 1. So every column will be treated the same by the machine learning model. That is what I am doing. Also, there is one more technique. Also, there is one more technique which is called as standard scaler. So the standard scaler says, I need mean and standard deviation. So I'll find out the mean as well. Mean is nothing but the average and standard deviation. So mean is the average formula of these all values, bracket close. And standard deviation is standard deviation of the population. This formula has to be used, but that's okay. I mean, that's not important. So standard scalar, how does it work? Equal to x minus mu, bracket close, divided by standard deviation. So I'll be locking this. Right. Now, standard deviation does it in such a way that now if you actually look at the mean of these values, average of these all values, it's 0. Now I'll explain you what I did. See, what I did in standard deviation is, how is this number computed? This is 100 minus mu is this 1513 divided by sigma, which is 2695. I got the minus 0.52. In this way, all others are computed. Now, what does standard deviation do? It will ensure that when you look at all these values, the average of this will be 0. Now, you'll be like, but Darshan, here it's not exactly 0. But it's very close to 0, but it's not 0 because you have hardly 6 values. You take 600 values, 6 lakh values, it will exactly be 0. Okay. So, both of these are good techniques for scaling. The first choice by data scientist is standard scaler. The second choice is min-max scaler. But right now, I am going ahead with the min-max scaling. How do I do it? Well, it's so simple. You just have to Google for min-max scaler, Sklearn. All the things related to machine learning are available in Sklearn. I say. Let's scale using min-max scaling. That's the one. Where is it available? From sklearn.preprocessing, import min-max scaler. I say from sklearn.preprocessing, import min-max scaler. So what are we doing over here? We are importing the class min-max scalar. Then after that, you have studied object-oriented programming. You create an object of this class. So I am creating the object by the name MMS. So I'm creating an object of the class min-max scalar. Then what will I say? Min-max scalar, I want you to fit and transform over extrain of features. If you forgot what are features, let me just make you recollect. Features are this TV, radio, newspaper. So I'm saying min-max scalar, I want you to fit and transform. Now, fit means study the data and transform means apply the formula. So fit means study that column. So it will study TV column, radio column, newspaper column, and transform is actually going to make those values in the range 0 to 1. And once this transformation is done, where to save the result? I say save it back into the features. So now what happens over here is MMS object learns the formula from the training set and applies that formula on the training set. So now the learning is done. Okay, a student is there. I said that, okay, come prepared. I gave him question bank. He studied it. So learning is done. Now on the unseen data set, which is the X test. So here on X test, I am not fitting again because the formula is already learned from the training. Because the learning is done, I only say transform this data because I want to see how much it is able to apply the knowledge. So this is something that you do in min-max scaling. So now if I just look at extend.describe, you see the minimum value of TV, radio, newspaper is 0. The maximum value is 1. What was earlier? Before scaling, the minimum was 4, 0, and 0.9, 350 and 100. But now it is 0 and 1. So it is just like the example of Genie that we were able to shrink the values. The shrinking is important. We understand why is this shrinking important. Now, what are we going to do is, let's go ahead and build a linear regression model. So what are the steps to build a machine learning model? The first step is to import the model. This model is usually likely to be in the Scikit Learn library. Then next we create the object of the model or the object of the class, right? So we import the class, that could be better from Scikit Learn. Then we create the object of a class, and then after that we train the model, and this train is also, we ask the model to study, right? So train is nothing but we ask the model to study the training data set. Technically, you call it as fit. Similarly, you test the model, that is, you ask it to predict. Yes. So we predict it, and then we evaluate the model. And when it comes to evaluation, we look at the R2 score method. We'll see what it is. So let's go and build the very first one, which is the linear regression model. So step 1 is what? Import the class. I say from sklearn.linear model, import linear regression. What am I Googling for? I am looking for linear regression model. I am going to Google and I am typing linear regression sklearn. I type every algorithm you want. This is what you will type. And this is the documentation. So you see over here, sklearn has a subclass which is called as linear model, from which I'm going to get this class. So sklearn has a sub package called as linear model, from which I'll get the linear regression. Okay. Yeah. So I say here. Then the next is step number 2, where we create the object of a class. So I say LR is equal to linear regression. That object name can be anything. Step 3 is train or study, and that is done using the fit method. So I'll say, hey LR, you go and fit on X train, Y train, which is the training data. And after that, what has happened is we had this data, we divided it over here, then we further divided it. So we all know that this is the training data and that's the training data. That's the testing data. So I asked my linear regression model to go and fit on the training data. So it will go and understand the relationship between X train, Y train, which is what we call as study. After this study is over, the next thing what we are doing is now I'm asking my model to go and predict on this part. So when it predicts on this part, I'll be getting set of answers. How do I call it? I say step 4, I am asking the model to go and predict on the training data. So Y prediction on the train is LR.predict on X train. So that is Y pred train. Okay, this Y predicted train is this. Similarly, I am asking the model that you also predict on unseen data. That is, you go and predict on this part. So that will be the prediction. So I say Y pred test is equal to this. Then once that is over, we have to evaluate the model. How do you evaluate the model? Using R2 score. Where is this R2 score? Go to Google and you say R2 score sklearn. That's the documentation. What does it ask for? It says I am inside sklearn.metrics. Okay, so this link is copied. So it says I am inside sklearn.metrics. You give me y true, which is y actual, which is this, and y predicted, which is this. So what am I doing? I am saying from sklearn.metrics import R2 score. Then I am giving the y true, which is this part, and this is the y prediction. So I say the R2 on the training data is I am passing the Y train, which is this part, and Y pred train, which is this part. Then similarly, I'm also saying that what is the R2 on Y test versus Y pred test. So this is Y test and this is Y pred test. And now I'm printing the R2 on training data is this and R2 on testing data is this. So you see over here, we got something really nice. The R2 on the training data is 90% and R2 on the testing data is 86%. Just to recall for all of you, what is a good ML model? So a good ML model is the one which satisfies the following two conditions. The first one is the test accuracy should be greater than equal to 80%. And the difference between the train and test accuracy must be less than 5%. So now tell me, looking at our results, are we getting such a model? Are we getting such a model where the accuracy on the training testing is at least 85% and on the training minus testing, the difference is less than 5%? Yes. So can I call this as a good model? Can I call this as a good model? Yes. But can I call this as a best model? No, because we have not tried out multiple other models. I cannot call this as the best model because we have not tried out multiple other models. Based on the above results, the score of the training set is 0.90. The score of the testing set is this. The difference is this much, and the test accuracy is greater than equal to this. Therefore, the linear regression model is good. Now, let's try other ML models to see if we can get a better model. Okay, so what is the next model which I'm trying out? The next model which I want to try out is decision tree regressor. So now I am planning decision tree regressor, and look at the steps, you will be surprised. So decision tree regressor, sklearn. This is available not inside sklearn.linear model, but this is available inside sklearn.tree. Okay. So the first thing is, I don't want to write the steps. I say from sklearn.tree, import the decision tree regressor. Then I am creating an object, same steps. Earlier I called it as LR, now I'm calling it as TT. I am asking it to fit on training and testing data. Then I'll ask it to predict on XTrain and save the result into Y predicted train. I ask it to predict on XTest and save the result inside Y predicted test. And then I'm calculating the R2 score on train and test, same code copy pasted. Then I print it. Ooh. Did you see this? Did you see this? Our accuracy, if you would have been happy with your linear regression model, there was something much, much better. Okay. Then decision tree regressor is over. Now let's go ahead with the random forest regressor. Where is this available? So, random forest regressor. That's here. That's sklearn. It's available in sklearn.ensemble. Copying it here. I say from sklearn.ensemble, import the random forest regressor. Create an object of random forest regressor. Fit on XTrain, YTrain. See, third time we are doing the code and the steps are the same. then prediction on the train data and the test data, and then we are getting the R2 on train, R2 on test, R2 on train and R2 on test, and I will be predicting it. Now, according to me, this is an even better model as compared to the decision tree because the difference in between them is relatively lesser and the testing accuracy is also higher. Are you understanding this? Random forest regressor is a even better feature because a better algorithm because the difference is less and the accuracy is greater. Now the thing is, uh, I remember among the three, do you remember which was the least important independent variable? So I can say so yeah, we can see, right? 0.78, 0.57. Yes, it was newspaper. So newspaper has the least correlation from the sales. So let's drop the newspaper column from the data set and build a random forest regressor model because this is the best so far, right? So I say my features are only TV and radio. Then X is going to be the DF of features. Y is going to be sales. So X and Y divided. After that, we do train test split. So I am doing train test split. Then after doing that, the next is scaling. So I say min-max scaler, could you please study and transform the values in the TV radio column? And min-max scaler, could you please transform the values in the test column? Done. Then we create an object of random forest regressor. We create an object of the random forest regressor. And then we say go and fit on the training data. This time while fitting, there are only two independent variables. Did you see that the code is the same, which is repeating again and again? I'm not doing anything. Same code is repeating again and again. Y predicted train, Y predicted test, and we get the R2 score on both, and then I'll print it. Let's see. So I have this earlier data and I have this latest data. So this is 99.74. This is 99.67. Oh, R2 decreased. So this is better. Better R2 score because R2 higher the R2, better it is. 97.15 and this is 97.13. So it did not increase the accuracy by a vast, but definitely it helped. Yes. And if it has helped us, if it has really helped us, so now this is after dropping and this is without dropping. If dropping is even helping me by this much amount, I will prefer to drop it. Why to unnecessary carry burden? Right? So dropping the variable was a good choice. Although it was by a very small amount, but still it increased my accuracy. So I will consider dropping it. Yes. Older results with newspaper column. Newer results without the newspaper column. So I say from the above results, the R2 on training set, the R2 after dropping newspaper column is better than the R2 before dropping the newspaper column. And that too on both the training and testing data set. Therefore, random forest regressor is a good choice for predicting the sales, and that is going to be based on TV and radio. Based on TV and radio. So we did that. Now what am I going to do is I copied this entire code because this is good. I am happy with it. And what am I doing is I am trying to change the random state. Do you all recollect what is random state responsible for? Random state is responsible for every time you are dividing the train and test. Before that, you shuffle the data. We discussed this during our NLP project. Every time we divide the data into train and test, before that we shuffle the data so that even if the data is in group, shuffling is going to take care of that. Now, I'm trying to change the random state. Changing the random state will change the shuffle. So maybe earlier there was one shuffle. I'll try out changing the shuffle. So I have got the results like this. I just want to see that with this new shuffle of random state equal to 1, am I getting something better? 99.74, 75 and 90. Oh my God. Uh, do you see that this was the best result so far, which I copied from above? Just by changing the random state, my shuffle got changed. And because my shuffle got changed, my training and testing accuracy, both of them increased. So random state equal to 1 is an even better choice. So if this is a good one, no problem. I'm happy with it. So I am copying this. And right now, this is the best result. I'll just keep it with me. Instead of 80-20, I'll make it as 75-25. 99.71. This is 99. This was older one was 75. This is 71. And this is 99. So now you tell me the training accuracy is more or less the same, right? This is 99.75. This is 99.71. But the testing accuracy increased by almost 0.5. So is the train test split of 75-25 even better? Is it even a better combination? Yes. Yes, it is. It is. Even a little increase is helpful for me. Yes, it is purely trial and error. Exactly the way I'm doing. If there was something which was directly available, then why would I have been trying out so much? Nothing like this is available. So, okay, let me, this is better. If I just instead of this is the better ad result so far. 30. No, see, 70-30 I tried, but the testing accuracy decreased. Not a good choice. If I try out 33. No. If I try out 35, you can go right up to 60-40, not more than that. 98.51, no. If I say 60-40, so I understand that 25 was a good one. Okay, 25 was a good one. This is what we understand. Now, what am I trying to do? is I want to try changing the scaling technique. What is another scaling technique name that you recollect? Standard scaler. So I say, let me try to do that. So how do I implement standard scaler? Is from sklearn.preprocessing. Earlier we had min-max scaler. Now I'm saying standard scaler. Then I create an object of standard scaler by the name MMS. So now I am, let me change the name to SS standard scaler. I am asking standard scaler to go and fit transform over the features, and I'm asking standard scaler to transform. Rest entire code remains the same. That is the beauty of it. That is the beauty of it. So let me try and see if I'm getting better. This is the best result so far. Is my result better? 99.7, 99.70. This is 71. Earlier is better. 99.011 and 99.98.9. And the same. It's almost the same. Let me try out different combination, 80-20 split with standard scaler. No. Let me try out random state 0 with standard scaler. No. Random state 2 with standard scaler. No. Random state 100 with standard scaler. No. Then 70-30 split with random scaler. No. This is okay, but the earlier one was better. So changing the scaling is not the correct way. So now let's get started. Now, today we are going to get started with the classification algorithm in machine learning. So see, the aim is what? Classification algorithms in machine learning. Getting started. So we have to get started with the classification problem in machine learning. So ideally, today, we're expected to get started with neural network, but we are lacking little bit behind. Getting started. So I'm getting started with the importing. Okay. So, and then I'll tell you what is the problem statement and all. We'll see that. So I'll tell you what is the goal. The goal is to predict the survival of the passengers on the Titanic based on the features provided in the data set. Now, let us import the necessary libraries. So I will import NumPy, Pandas, Matplotlib, Seaborn. And I don't want to come across any warnings. So I want to import the warnings module, and after importing the module, I am asking it. So I say, I want to load the data set. df is equal to pd.read csv. The name of the file is Titanic only, as you can see. So I am saying this. This is not the 100% original data set, because originally in Titanic, 2,225 passengers something were traveling. This data set consists of a part of it. The real data set is not available anywhere. This consists of 891 records. Let us look at the head of it. Now, I want to look at the description of the columns of the data set. The first column is the passenger ID, which is the unique ID of the passenger. Then you have survive, where 1 means, yes, the passenger survived after the Titanic crash. 0 means he did not. This is the passenger class, first, second, third. This is the name of the passenger traveling. And then the next is the gender of the passenger. Then you have the age of the passenger. Then SIVSP stands for the number of sibling and spouse of the passenger. Let's say, for example, if I am talking with respect to my family, in my family, I have one brother. Who is he? He is my sibling. And I have one wife. She is my spouse. So my sibling spouse count is 2. Did you understand how the sibling spouse count of every passenger is calculated? I just told with respect to my family. In the same way, it applies for everyone. Great. Very nice. PAR stands for the number of parent and children count. Again, to make this clear, if I talk with respect to my family, I have one father who is my parent. I have one mother who is also my parent, and I have 2 children. So my parent children count is 4. The next thing that we have is the ticket number of the passenger. Then we have the fare paid by the passenger. Then we have the cabin number of the passenger. So the Titanic was manufactured somewhere here at Belfast. Most of the people entered the ship at Southampton, 10th April 1912. Then the ship went from here to Cherbourg on the same day. Then the ship moved to Queenstown. Few more people entered the ship on the next day. And then all through the North Atlantic Ocean, the ship was going towards its death location. And here, we all know what happened. Almost after completing 2/3 of its journey, Titanic sank deep into the North Atlantic Ocean. And the rest is the history. It was destined to go to New York. So, that is the last column of the data set, which is embarked. As you can see, it has 3 values, C, Q, S, standing for this. So these are all the columns of the data set. And now let us straight away go ahead into the analysis. So now I say, if I say df dot survived dot value counts, we understand over here. What am I doing? I am doing exploratory data analysis. So what is exploratory data analysis? Well, exploratory data analysis is the process of performing initial investigations on the data set, and the aim is to discover patterns in the data. Are there any anomalies? Are there any hidden insights, trends in the data which can give us some information? Like, for example, if you look over here, what is the insight? 342 people survived, 549 people died. So can I say most of the passengers traveling in the Titanic did not survive? That's exactly what I was telling you, Sudhanu. We will have to analyze it this way to try to get maximum insights from the data. Are you clear? So this is what we have to clarify to ourselves only. So I'm also going to assume it that way only, that even I don't know the data set, even you don't know the data set. Both of us are looking at this data for the very first time. And even if I look at the percentage count, we see that I can also multiply it by 100. 38% of the passengers survived and 61% of the passengers died. That's sad. Then if I look at df.info, we see that there are total 891 rows. But here, everywhere, I don't see 891 value, which makes me understand that there are missing values in the age column. There are a lot of missing values in the Kevin column, and there are missing values in the embark column. Let me confirm that. So I say, let's find out the missing values in the data set in each column. So I can say df dot is null dot sum. So what will that give me? That will give me the sum of missing values in each column. So it's saying that, hey, each column has 177 missing values. Kevin has this, embarked has this. I usually prefer to apply the sort values function after this. Advantage. Now I know that because from here, the first 0 has come, and because the results are in descending order, which means obviously below that will be all zeros, and I have to look only here. So when there are many columns, like here, there are only few columns, so you can easily find out. But when there are many columns, let's say you have 100 columns, then this list becomes really difficult to go through. So sorting in the descending order is a good way to find out which columns have missing values. Survived is a categorical column. Passenger class is a categorical column. Sex is the categorical column. Sibling, spouse, parent, children, embarked are the categorical columns. So I say for column in the categorical column, let us go for the count plot of each of this. Look at this. For column in categorical column, I am going for the count plot of each of this. Let's see. Now looking at this, what do we understand? Most of the passengers died as compared to survived. Then we clearly see over here, majority of the people traveling in Titanic were from the third class, and the least were not from the first class. The least were from the second class. Quite surprising. Look at this. More number of males were traveling on the Titanic ship as compared to the females. Most of the passengers looks like they were traveling solo because their sibling spouse count was 0. And very few people were traveling in large sibling spouse count. Same goes for parent children. See, solo count is very high. Look at this. Majority of the passengers embarked from Southampton as compared to Cherbourg and Queenstown. You know, Southampton was one of the very popular port at that time, and it is very near to London as well. So that is the reason people preferred to embark from Southampton. I am going to copy this and I say value counts. This is even better. Star, sorry, equal to shall be printed 70 times. Same code, but instead of count plot, I wrote in the form of numbers. Most of the passengers died as compared to survived. Majority of the passengers were from the third class and minimum from the second. Majority of the passengers were male as compared to female. Many were traveling solo. Similarly, parent children count 0. And most of the passengers embarked from Southampton. So this is the same thing. It's just that I plotted it numerically as well. Okay. Now, before I treat it, I want to show you that now I'm installing, I never used this library, but I'm installing a library which is called as Sweetviz. So what is Sweetviz? Well, let us write down Sweetviz library. Well, it is an open source Python library that generates beautiful high density visuals to kickstart with the EDA. So it's very nice and automated, and you can do that in just 2 lines of code. You need to install it, you need to import it, and then you just have to say dot analyze, and it will save the output in the form of HTML. Let us do that. So right now here, I am just commenting out this, and then first I install it. We will import Sweetviz, and then we use the sv.analyze function, and that thing, that thing will be saved into a report. Let me run it. It's generating the report, and it automatically moved on. It automatically moved from my VS Code over here. Right. If you want to see that it is here, right? So that report is here. I can show you in my drive as well. So if you see, this is where our D3 is. This report is created. If I double click, it will open it in my drive. So you can see how awesome is this. In the data frame, it is telling me that there are 891 rows. It is taking this much memory in the RAM. 12 columns are there, 6 categorical, 3 numerical, 3 text. If I click on associations, it is showing me the association part as well, which is nothing but a heat map. Then passenger ID column. This is the distribution, but let us look at survived. 891 values are there, 2 unique values, 2 distinct values. We can see majority of them died as compared to survived. You just click on it and you get a bar graph of this visible. Details are here, right? How many people survived, how many died. Same applies for passenger class. As you can see, 55% passengers were traveling in third class and 21% in second class. Similarly, you have the age column. Now, if you look at age, it is showing me the describe, like here. Let's look at this. Most of the passengers were of the age group 20 and 30. You can also see below, I have the most frequent, smallest, and the largest values. So it's a sweet way of visualizing the things. It's really very powerful and very nice. Beautiful. So you get everything done very quickly with a very standard code. Whatever is your name of the data frame, just write that name here and you are all done. Will this work in Colab as well? Whatever code I am running in VS Code, I have given you an assurance that it will run in Colab. So going forward, no one should be concerned about this. Of course, it will work. Of course. So now, Sweetviz is done. Now I say df.isNA.sum dot sort values. Now here, if you look at the shape of the data, now you tell me logically, there are 891 rows in the data set. Now you tell me out of 891, 687 values are missing. You know what does that mean? 687 out of 891 multiplied by 100, which means the column has 77% missing values. So this column does not have any meaningful information. Therefore, we will prefer to drop this column because it cannot be useful for predicting whether a passenger survived or not. So, I say, since the missing values in the cabin is 77% of the total data, we can drop this column. Cabin column is not useful for our analysis because it has a lot of missing values. So, see, usually if the number of missing values is greater than 40%, right? The rule of thumb is if the number of missing values are more than 40% of the data, it is better to drop the column or consider imputing the values. In this case, it is 77%. So df dot drop, and the cabin to be dropped is the column axis equal to 1. Drop the name of the column because it's the column, you specify axis is equal to 1. In place equal to true means do it here itself. So now if I say what is the number of missing values, so you can see cabin column is not there at all because we dropped that column. Now let's talk about embarked. So if I say df.embark.value counts, what do we see? Most of the passengers embark from Southampton. So I say, since most of the passengers embarked from Southampton, we can impute the missing values in the embark column. Two values are missing. So I have two options. I can drop those two rows where embarked is missing, but I'll lose other columns as well. So I will think of filling the missing values by the mode of that data. So df.embark.fill NA, fill it with S in place equal to true. So what I did, df.embark. So embark column NA values needs to be filled with S in place equal to true. And then I see, so now you see embark column is there, but the number of missing values are 0. Now, H column. Now we say H column is numerical in nature. If a numerical column has missing values, then we can either fill the missing values with the mean or median of that column. So, if the column is normally distributed, we fill it by the mean. If the column is skewed, you fill it by the median. So we all have seen what is a normal distribution. So I'm going to plot the H column. If it is distributed like this, I will fill the missing values by mean. But if it is like this, or if it is like this, then I'll fill the missing values by median. Okay. Now, I say SNS dot this plot of the H column. This will be plotting the distribution of the H column. Now, looking at this, what do we see? When you look at this particular column, does it look normally distributed? Does it look skewed? I'm little confused. I said mean and median, right? So it's little confusing. So what will I do? What is the normal distribution where mean and median are at the same point? So I am using the axis vertical line function and I'm plotting the mean and median. Have a look at it, then I am explaining. So I say I want to plot axis vertical line wherever the mean of the age column is. So wherever the mean average age is, I want to draw a vertical line. And this vertical line must be red in color and the line style must be dashed. Similarly, I want to draw a vertical line where median is there in green color. Line style is solid, which is this. And I plotted it. And this is where I'm again further confused. So if you just want to get rid of this, I would say df dot age dot skew. Directly use the skew function. It gives us some answer. Now, how to interpret this? I go to Google. And I go to the skewness range. This gives us a good idea about it. We say if the value is between minus 0.5 to plus 0.5, it is almost symmetrical. If it is between minus 1 to minus 0.5 or between 0.5 to 1, it is positively skewed and so on. Now, based on this, could you tell me, is the age column, it belongs to which category? Meanwhile, I'll read Karthik's question. Symmetrical, right? And as per the rule of thumb, if it is symmetrical, then I will fill the missing values by the mean. That's what we understood here. So let's go for feature engineering. So what is feature engineering? Well, feature engineering is the process of using domain knowledge to extract new and more meaningful features from the existing features in the dataset. For your kind information, in very simple words, feature means a column and engineering means creating. So feature engineering is column creating. Creating a new column, but that new column must be more meaningful than the existing one. Like, for example, if I have a column called as date of birth, I can extract year, month, day, quarter, etc. I say, if I have a column called as address, I can extract from that and I can easily find out your city, state, country, etc. If I have your full name, I can extract your title. If I have your date of joining, I can extract your year of joining, month of joining. I can also calculate your years of experience in this company. If I have a column height and weight, then I can create a new column called as body mass index, because BMI is nothing but weight upon height square. Similarly, I say, if I know your basic salary, house rent allowance, dearness allowance, traveling allowance. I can create a new column called as gross salary. Very good. So now I am going to engineer a feature. So I say, now I am planning to engineer a feature called as family size. So then pass fail. Here also I'm going to create a new column where I say df of family size is equal to df of sibling spouse plus parent children plus 1. I use both the syntaxes so that you are comfortable with both. And now I say df dot head. So my family size feature is invented. I want to engineer a feature called as is alone, whose value will be 1 if the family size is 1, else it will be 0. And I'm using the lambda function which we learned. What am I doing? The family size column, on the family size column, I'm applying this lambda function. If you recollect, lambda function has the following syntax: argument, expression. So the family size column value will be sent into X, and I say that if X is equal to 1, then save 1, else save 0. So I say df of head, and now I say df dot is alone dot value counts. And the insight is most of the passengers were not traveling alone. Okay, then let us try to find out how many passengers were traveling free of cost. So if I do df of fare of value counts, I get all of the fares and how many passengers paid how much fare. But this is in the descending order of fare. I don't see anyone having paid a fare of 0. But rather than this, let me just apply the describe on it. But I see, right, the minimum value is 0. So there are some passengers who happen to pay 0 fare. So how can I figure it out? In the data frame, tell me all of the passengers who paid 0 fare. These are the passengers in the data frame who paid 0 fare. So this is the filtering part which we learned inside Pandas. df dot fare equal to 0 will give me true and false. That true and false is what I'm searching in the overall data frame. Could be the crew members. And one way of confirming that is looking at the is alone column. If you remember, I don't recollect, but did I take you across the crisp DM pipeline, crisp DM framework? Did I show you that figure? No. I had said that if a machine learning project goes on for 100 days, this is business understanding, this is the data set understanding, and this is the EDA. This takes around 70 to 75 days. Modeling and evaluation takes around 10 to 15 days, and deployment also takes around 10 to 15 days. So if you don't understand the data well and you directly say that, hey, I'm going to skip this, I'll not do feature engineering, I'll not do this, I'll not do that, quickly, I'll finish this off and I'll go to modeling, you will get very bad results, very bad results. So the moral of the story is EDA is very important, very important. This is what is there. Now, the next thing which I can do over here is, if you look over here, if I say I want to split this, my aim over here is to extract the title of this person. Kyle, I want to extract the title of this person, Mr. Similarly, for this, I want to extract Mrs. Similarly, for this, I want to extract Miss. So I will prefer to split this on comma using the string function. So split this on comma. And after splitting on comma, I get two things. I am interested in this part. So this is the list. Brond is at index 0 and Mr. Owen Harris is at index 1. So I want the output at index 1. I will further split this on dot. So when I split this on dot, it will separate Mr. and Owen Harris, Mr. and Owen Harris. So I say dot split on dot. And now I only want Mr. So Mr. is at index 0. Now this Mr. has one additional space before M. I will prefer to strip, which removes the additional spaces. So with this logic, I think any name I have, if I apply this logic, I'm able to extract the title. As you can see, Mrs. is out. Or if I say this, we can see I get this. So I say, let's extract the title column from the name column, where I say on the name column, I want you to apply the lambda function, and the lambda function is applied in this way. All the values of the names are given 1 by 1 into x, and I am splitting x on comma, index 1, splitting on dot, index 0 dot strip, which is exactly the same thing. And now look at the interesting part. We have got the title column. Now I say df dot title dot value counts. Look at the type of people who were traveling on Titanic. Mr. were there, Miss was there, Mr., Master, Doctor, Reverend, MLLE, Major, Colonel. And who is this? Countess? And today in 2025, we don't have such designations which are very common. Captain is fine, Miss is fine, Sir is fine, Lady is fine, MME. Don? You can see Don and John Kheer. Yes. So what I want to do now is, these are too many values. So I want to combine the common titles. Okay, so I don't know each of the titles. Let's say I'm very new to this domain. I don't know each of these titles. So I say, I'm going to ChatGPT only quickly. And I say, that's the output. Okay. And I come over here. My code is this. Oh, stop. My code is this. And I say my output is this. And I ask, am not too much aware of the various titles which are mentioned in the output. Could you please tell me a way where I can combine these titles into the dominant category so that there are very few unique titles? Let's see. So what it is saying, let's read. It says that the common titles usually are Mr., Miss, Mrs., Master, and these are very rare titles. So it suggested me What is it suggesting? That, doctor, reverend, major, column, captain, sir, John Keir, etc. You can combine it into rare male. And the lady, countess, MLLE, MLE, miss, you can combine it into rare female. And good, it generated a code for me also. It created a dictionary mapping. And it says that you apply this and you now check. No problem. Now you can just have a look at it. It created a dictionary where it is mapping, right? So, but you know what? I don't want to increase it. I am still, this is how it is going to return me, right? I don't like the nomenclature. Rare male. I don't like it, to be very honest. And rare female. Will it be advisable if I combine it with the available titles only? So rare male, rare female. If it is male, put it to male only. And now it is doing that. So it says that since the above titles generally refer to male, we are merging into Mr. Makes sense. This is exactly what I was thinking. And most of this honorifics for women and miss are generally for unmarried women. So it has done into Mrs. or Miss. And Emily and this countess are closer to Mrs. who are married, and Emily and Miss are this. And that's perfect. I love it. So I go and yes. Now you can see I have this as the thing, and I have this. So we have a lot of feature engineering done. In fact, I'm going to now do a little bit of further EDA over here. And I say, if I say df dot survive dot value counts, now I say, I want to find the survival rate based on the passenger class. So I will group by passenger class and I look at the average survival rate. So I say group by the passenger class and look at the average survival rate. So we understand over here that 62% of the first class passengers survived, 47% of the second class, and only 24%. See, this is not, the total of this will not be 100%. No. Out of the 100% passengers traveling, 62 out of 100% of first class, 62% of them survived. Out of 100% of second class, 47% survived. Out of 24%, out of 100%, only 24% survived from the third class. So this gives me a quick insight that passengers traveling in the first class had a higher survival rate as compared to second and third. In the same way, if I look with respect to sex, females had higher survival rate as compared to males. Okay. But if that's the case, let me look at it on the basis of title. Title is also there. Ooh, you can see over here, if you look at the title, 57% masters, 70% miss, 16% mister. Oh, that's again showing that females had higher chances of survival. Then, on the basis of the port of embarkment, embarked is also one column, Southampton, Cherbourg, Queenstown. Did you see over here, friends? Cherbourg people were given more priority when it came to survival as compared to Southampton. Okay. df dot head. Now here, so I say I want to do, okay, now I say I want to engineer a new column called as gender class. So the idea is if the age has a value less than 15, then this column will be saving child. Save the sex, which can be male or female. I'll explain you what I mean by that. So I say I want to create a feature. First, let's look at the output. Then I'll explain you what I mean. First of all, if you see, after doing this code and introspecting the gender class, it tells me that 538 males were traveling, 275 females, and 78 children were traveling on the Titanic ship. Let's try to analyze further what I exactly did because of which I got the output. So I said that I said that I said that if the age is less than 15, then the gender class would be child. Look into the age column. Is anywhere age less than 15? Here, assuming that this is less than 15. 15, 3 is less than 15, yes. So it will come and save over here child. And if the age is not less than 15, then whatever is in the sex column, you will save it. So for all the cases where age is not less than 15, like here, here, age is not less than 15. So this value has to be copied here. In all these cases also age is not less than 15. So whatever is in the sex column will be copied. Only and only where age is less than 15, I want child to be saved. And how did that happen is like this. On the data frame, I want to apply. I'm passing the entire data frame. So this entire data frame gets copied into DFF. And here I say, is the age less than 15? So what will happen over here is when this entire data frame is copied into DFF, this data frame is temporarily now called as DFF inside this lambda function. So I say DFF of age. DFF of age is the age value, which is 22 right now, less than 15. If the answer is yes, it will save child. If the answer is no, it will save DFF of sex. So what is in DFF of sex? This value will be saved here. Axis equal to 1 because you have to look at the column wise operation. If you had to do row wise operation, then that would be 0. But here I am going to give axis as 1. Have a close look at it, why I did it like this. If I say df dot age dot describe, you can see 25% of the passengers were in the age group 35 to 80. Or if I say SNS dot distribution plot of the age column and PLT dot axis vertical line, I am plotting the mean and I am plotting the quantile. Mean is over. I am also plotting the 50 percentile in yellow color. . I'm also plotting 60 percentile. I'm also plotting 70 percentile, 80 percentile, 90 percentile, and 95 percentile, and 99 percentile, and I'll show it. Now have a look at this. I think this yellow color is not that great, but I think we can manage it out. Look at this. So if you see carefully, I think this color is not that great. Instead of yellow, let me try pink. Yes, here. Now, if you look at this, have a close look. This is 50 percentile, 60 percentile, 70 percentile, 80 percentile, 90 percentile, and 95 percentile. So if you see carefully, 5% of the people, because this is 95 percentile, 5% of the people are in the age group 65 to 80, only 5%. And this is 90 percentile. This is 90 percentile. This was 95 percentile. So if you look carefully, this is 90 percentile ka line. So no, not, sorry. This is 99 percentile and this is 95 percentile and this is 90 percentile. 95% of the passengers traveling on Titanic were in the age group 55 to 80. 95, sorry, 95% were below 55. That means only 5% of the passengers were above age group 55, which clearly indicates that old people were very few. Now I want to formulate a list. See, what is the aim of the project? We have to predict the survival of the passengers on the Titanic based on the features provided in the dataset. So now let's try to figure out which columns are useful for our analysis and which columns are not. So I am creating a list of unnecessary columns. Now let's try to figure out over here. See, the end goal is what? To predict whether a passenger survived or not. In the same way, to predict whether a passenger survived or not, do you agree that passenger ID, ID of the passenger cannot be helpful for predicting whether the passenger survived? Am I correct? So me saying that, okay, all the passengers from ID 1 to 50 will die and after 50 they will survive. No, you can't. Passenger class is important for survival. We have seen that first class passengers were given more priority. Do you think the name of the passenger can be important for survival? No, that's correct. No, right? I cannot say that, okay, all the people whose name starts from alphabet A to M will get 5% increment and N to Z will get 18% increment. I can't say that. Do you think the sex of the passenger is important for predicting survival? Sex? Yes. Who was given more preference when it came to survival? Females. So dropping sex is not a good idea. But my dear friends, do you remember that family size consists of male, female, and child, and sex consists of only male, female? So can I say that because we already have family size, which is more meaningful, I can consider dropping the sex? The same information already available here. The same information of male, female is already available over here. So the family size column is more informative as compared to sex, and therefore, since I have feature engineered the family size column, I will drop the sex column. Age I will not drop. Sibling, spouse, and parent children also I am going to drop, because using this I have already got the family size column. Yeah, gender class I'll not do. Ticket number also I'll be dropping. Fare I will not drop. Embarked I will not drop. Rest all columns I will keep. All the columns which are there in the red box, I am going to drop it. So I just prepare a list of unnecessary columns. Name, sex, sibling, spouse, parent, children, ticket. And I say drop these columns and then look at the head. Are you all clear why we drop which all columns? Are you all with me? Right? Yes, I just looked at how much it is important for survival. Okay. Now, consider we having a column like gender. This is having male, male, female, male, female. Now, what will happen to this is, first thing is, we find out the unique values in the gender column. So the unique values in the gender column are male and female. They are sorted in the, oh my bad, yes, and child also. You are correct. You are correct. Child is also there. So the unique values in this gender column are male, female, and child. So now what happens? Let us have child. So the unique values are this. Now what will be saved in this unique list are all the unique things, male, female, and child, but in the alphabetical order. So first child comes, then female comes, then male comes. So it will create 3 new columns. The first column is called as gender underscore child, gender underscore female, gender underscore male. So a data like this would be created. Now, what will happen? The first value is male, so it will put 1 over here, 0 here. Second is male, 1 over here, 0 over here. Third is female, 1 over here, 0 over here. Next is male, 1 over here, 0 over here. Next is female, 1 over here, 0 over here. Next is child, 1 over here, 0 over here. And that is how a column which is categorical in nature is converted to numerical. And this technique is what is called as dummification or one-hot encoding. Find the unique values, put in ascending order. After in ascending order, write it down like this. And after writing it down, you know how to convert. I would like you to further think. See, do you all agree that if I have to do the reverse of it, if I have to do the reverse, then I don't think so we need all the 3 columns. Like for example, I can choose any 2 columns and make it possible. Like here, 0, 1. Imagine this is not there. 0, 1, male. 0, 0, male. 1, 0, 1 is female, female. 0, 1, male. 1, 0, female. 0, 0 means neither female nor male. So I wrote child. So do you all agree do you all further agree that it is okay if I just consider any two columns instead of all the three to re-engineer it back, right? So one column is additional. Machine learning model says that, Darshan, try to reduce the number of columns. Don't give me duplicate information. So this additional column is not required. So you can actually think of dropping the column, and it can be column, it can be any column which is dropped. I am not saying that you have to compulsorily drop the child column. You can drop any column, Darshan, any column. That's completely fine over here. So then, so how to implement it? Well, I say dummification. I'll come back to you, Sutanu. Dummification, which is also called as one-hot encoding. And this is done using the Pandas method get dummies. So I say columns to dummify are what? Passenger class, I will not. It's already 1, 2, 3. Embarked, title, and gender class. Embarked, title, and gender class. I say df is equal to pd dot get dummy. So I'm saying that, hey, I want you to do dummification on the data frame, but not all the columns, only the columns which I have mentioned inside columns to dummify, which are essentially these columns. Drop first equal to true will ensure that the first column is dropped. So in our case, we drop the gender class child. So if you want to drop a specific column, don't use drop first equal to true. And the D type must be integer. Now have a look at it. So as we can see, the gender class column is now not there, but instead of gender class, there should be 3 columns: gender class female, gender class male, gender class female and male, gender class child, female and male. And because drop first equal to true is there, child column is dropped. Similarly, in embark column, embark underscore C is gone. Q and S are only available. In title column also, I think, I don't know what is gone, but something is gone and these 3 are available. Now, see, you have learned statistics. Over there in statistics, you might have discussed about qualitative variables, right? We discussed about qualitative variables. So what all are the qualitative variables? Well, qualitative variables are categorical in nature and they are of, Sutanu, I'm coming to your question. 2 types, nominal and ordinal. So if you talk about nominal, they do not have any order. Example, you can consider name or the hair color, or you can consider eye color, etc. Or ordinal, which has a specific order like low, medium, high. Now, if you talk about dummification, dummification is what is used for nominal variables. And label encoding is what is used for ordinal variables. Dummification is exactly what I showed you. But what is label encoding? Well, label encoding is like if you have a column like, not gender, let's say if you have a column like shirt size of shirt, medium, small, large, medium, large, large. over here, label encoding will be assigning unique labels. Let's say you have small, medium, and large. It will assign the label 0, 1, 2. So wherever small is there, it will be having 0. Wherever medium is there, there will be 1. Wherever large is there, it will be 2. So label encoding is the one which has to be used in case of ordinal variables. But we didn't have any of the ordinal variable. We had the nominal variable. So we use one hot encoding over there. And that is precisely the answer to your question, Sutanu. Categorical, nominal variables, dummification, ordinal variables, label encoding. So now we are clear with this and we look at the head. Now everything is good. Perfect. Now what are we going to do is what we did in machine learning, which is the train test split. So I say splitting the data set into independent and dependent variables. So independent variable is X. Everything other than survived column is independent variable for us. And Y is only and only the survived column, right? So X is all the columns except the survived column and Y is only the survived column. Now I am planning to split the data set into training and testing features. So over here, you remember we had already learned it during the NLP project. I had invested a lot of time in making you understand train test split, where we divided the data into 80-20. You remember it? Right. If there are more than 100 categories, you already know the answer to that. You will try to combine the categories into common. And if you are still not able to combine the categories into prominent common things, then you have to try using the encodings of your choice. Play around with the output till you get something which is perfect. Also, there are some other techniques as well, other than dummification and label encoding, which are available. You can think of exploring those things as well. But these two are very, very common. So I say, so 891 rows were there. They are splitted as 712 and 179. After this, you know what? It's all sorted. You don't have to worry. Everything is done. Do you recollect how we created regression algorithm notebook? I have that. So let me open it. And if I go at the bottom, I see that every time I was implementing it, these were the standard steps that we followed. Dividing data into X and Y, train test split, scaling, and how is the algorithm implemented? Create an object, fit on it, predict on X train, X test to get the Y predicted train, Y predicted test, and then calculate the accuracy on the train data set and the test data set. Do you recollect it? If you don't recollect it, go back and watch the recordings and drop off right now from the session. Else you will not understand the further part. If you recollect it, then you are eligible to understand the last 30 minutes of our session. But I am not discussing anything which is new. It's just that our algorithm is going to change. In fact, you might have noted that our session was of 3 hours. 2.5 hours, I was doing time pass in the session. But you know very well how much EDA is important. If I would not have done that time pass, which is ideally the important part of exploration, then these lines would have given me miserable results. And I would have to go back and actually do the true EDA to ensure that my model is good. Are you understanding? Yes. So if you don't spend a good amount of time on EDA, feature engineering, you may have to go back. In fact, if you look over here in this DM framework, see over here, this figure also says the same thing. Darshan, if you are not taking these steps seriously and you directly do this, and go over here, you may have to come back to the EDA phase. If you still try to push ahead and try to evaluate the model, your model will always be bad and you may have to even go back to the business understanding phase. So consider these steps very, very seriously. Yes, very seriously. Okay, so this shuffling part is done. And after the shuffling part is done, the next thing that we are going to do is, if you look at the X-train head, the numerical columns, like for example, I say columns to be scaled, right? These are the numerical columns. So what am I doing right now is the scaling of the data. So age column, fair column are the columns that needs to be scaled. In fact, family size, no, family size is categorical in nature. I'll not consider the family size column. They are limited values. These are the two columns which needs to be scaled. And which scaling technique will I use? I will use the standard scaling technique. From sklearn.preprocessing import standard scalar. Dare you say I don't remember, sir, because I had taught this to you by pushing in a lot of efforts. So you cannot say I don't remember. If you say that, I will say, please go to the previous class and watch the recordings. So import this, create an object of standard scalar, and then I say standard scalar go and fit transform on the X-trains following column, and then only transform on this. And now we get started into the implementation part, and which all are the classification algorithms available in machine learning. Well, the first one is the logistic regression, k nearest neighbor regressor, support vector machine is there, decision tree classifier is there, random forest classifier is there, gradient boosting classifier is there. Then you have AdaBoost classifier, you have CatBoost classifier, you have light gradient boost classifier, you have the extreme gradient boost classifier, right? These are the very popular algorithms available in machine learning. Naive Bayes classifier is there. Neural network classifier also exists. Then you have, other than this, I think this covers most of it. Anything else which extra trees classifier is there. That's it. That's all I remember. Okay. Now we will get started with the first one. Logistic regression. Where is it available? In the linear model only. From sklearn. If you don't remember now where it is available, I always tell you how should you go around this. Copy this. Logistic regression sklearn. Just search for this part. Everything followed by sklearn. Get into the documentation. From sklearn.linear model, import logistic regression. So I do that. Create a object of logistic regression fit on the training data, and then I say y prediction on train. is this, and Y prediction on test is this. This is the same thing, now. Create an object, fit on the training data, predict on X train and X test, and then the metric was R2 in the regression. But here the metric is not R2. Here there is a metric called as accuracy score. So I will say, let me import from sklearn.metrics, import accuracy score, and I will say accuracy train is the accuracy score between Y train and Y predicted train, and the accuracy test. Same way, if you note here, how are we doing? R2, Y train, Y predicted train. R2, Y test, Y predicted test. I'm doing the same thing over here. Instead of R2, I have written accuracy score, else the bracket contents are the same. So I will print the train accuracy is this much and the test accuracy is this much. I am getting 83% accuracy on the train data and 80 on the test data. If you remember, I had made you understand what is a good model. So I say a good model is the one which satisfies the following conditions, satisfies both of the following conditions. The first one is the test accuracy must be greater than equal to 80%. And the train accuracy minus test accuracy difference must be less than equal to 5%. Again, this is not a ironclad rule or something. No, it's not like that. It's not something which is like a very fixed rule. Not at all. You need to understand over here, we are just depending on the problem statement, this varies. For example, if you look into the banking problem, getting an accuracy of 70% on the test data set in itself is a big challenge for them. So it depends on the problem statement. So, you cannot really define these rules, but this is one of the standard baseline that you can consider. Google says that if anything is dealing with life or happiness, we expect 100% accuracy. For example, if you're having a machine learning model which is going to predict whether whether a patient has cancer or not, you should be 100% accurate and nothing wrong. So that's why I said, it depends. It depends. So here I'm getting good on the logistic regression. I am planning to copy this, and inside the logistic regression, there are some parameters. Like one parameter is max iteration. I'm just planning to play with this. Max iterations, instead of 100, I want to keep as 500. Does it improve? Max iteration is running it for more number of times. I don't think so. It has improved even by a minor amount. If I make it as 5,000, no improvement, no problem. We have the solver as well. Solver. You can choose any one of it. The solver is default LBFGS. I am planning for liblinear. Let's say. Oh, it decreased. 83 and 79. Have a look at this, so that you know how to use this. Solver is nothing but the algorithm to be used in the optimization problem. Since we don't have time, we are not getting into mathematics, but at least you should know how to interpret this. So they say that for small data sets, liblinear is a good choice. Whereas SAG and Saga are faster for large data sets. When you are going for multi-class problem, like in Titanic, you have survived, not survived. Only two classes are there. But if you think about Iris data set, Setosa, Versicolor, Virginica, three are there, right? So in such cases, they say that liblinear, all solvers except liblinear will be good. Liblinear is very good for handling binary classification problems. Then you have this one as well, right? So you can read around this documentation. Then, so this is not benefiting. I will go ahead. In fact, what will I do now is I am planning to get into a little bit of optimization mode. So I say I want to create a data frame to store accuracy, to store the train and test accuracy of all the models. So I am saying that accuracy data frame is pd dot data frame, and right now the columns of the data frame would be the model name, train accuracy, and test accuracy. Okay, it's an empty data frame which is ready. Now I already have the accuracy train and accuracy test. I want to append those values. How I do that? Well, I say, let's now think of okay, you want that column also? Okay. Let's say one more column is there. Difference. So I want to append the values of logistic regression to the accuracy data frame. So that last time we were putting in a lot of stress for maintaining the values, but now it will do it in a very nice way. So I say accuracy data frame dot append model is this, train accuracy is this, test accuracy is this, and difference is this minus this. And this is good. Ignore index is true, and it says append is not allowed. Okay, that's correct. So I am closing it. Okay, absolute difference. Okay. Open chat. I say fix the error. Right. So it will help me out what to do. So concatenate is a good idea. I'll copy this and I will just close this. This is what we have. New row is equal to this. New row is equal to this. And I say train accuracy, test accuracy, and difference accuracy, and the accuracy data frame is added. And yes, we are good with this. So I have to do that little bit of efforts, but I think we are good. Now, every time I will have to just update this code this way. So once I have these values, I say append these values. So again, I have this new, and then accuracy data frame is saved. So this is the next one, right? Second one. I can give it a different name, but I'm giving it the same name. I don't want to invest time on this. You understood the structure. Next, someone please keep a track of the algorithms, putting it in the chat box. I'm going for decision tree classifier. Okay. From sklearn.tree, import decision tree classifier, create an object of decision tree classifier, fit on X train, Y train, predict the values, predict this, then accuracy score, I need not import, that's already there. Accuracy on train, accuracy on test, and then I will directly append. I need not print it over here. Let us print it directly here in this data frame only. So new row is this, accuracy data frame is there. So decision tree is highly overfitting because you see the difference in between the two is 20%. It's highly overfitting. But I am going to create one more tree algorithm, and here, I'll just control the max depth of the tree. Let's say I'm setting it as 5. It's one of the parameter, I remember it. You can explore that. And do you see this benefited a lot? The overfitting is gone. The difference straight away came to 5%. Yes, it is little greater than 5%, but that's okay. I told you, right, that 5% is not a concrete number. Let me go ahead with the support vector machine. From sklearn.svm, import support vector classifier, create an object of this, fit, predict on both. That's why this takes only 10 to 15% of the project time. So, and you see 83 and 81. Did you see among all, support vector seems to be the best so far? Are you all with me? Among all of this, support vector looks like one of the best one. Ah, we can see that. Okay, let me try out CatBoost classifier. But for CatBoost classifier, you will have to install CatBoost. So I'm installing the CatBoost. -Q stands for quiet installation. So you see there is nothing printed below. There is nothing printed below. So if you don't write -Q, it will say, installing this, installing this, installing this, all those steps will start coming. I just suppressed all that because I want my notebook clean. And then I say import CatBoost. CatBoost is not available in sklearn, by the way. Create an object of CatBoost classifier. Then fit, predict, accuracy, append it, and print it. And see it, CatBoost is very much similar to the neural network. So the training happens over there, but that's okay. You can see the result. 89 and 81. Oh, CatBoost looks like awesome. Huh? The difference is greater than 18, greater, but overall the accuracy is very impressive. 89. So I'm just a little bit optimistic about that. So is there any parameter which I can actually change over here? And it suggested me some parameters. I'm just trying out them, right? So the parameters, iterations, 1000, learning rate, depth, and verbose. So because I made verbose equal to 0, it was not verbose like earlier. Verbose means this lot of things, verbosity seen here. It will just suppress verbose equal to 0. 98 and 81. Difference is even greater. Okay. Further, if I make the learning rate little smaller, difference reduced. Okay. If I make the learning rate even more smaller, learning rate is always a value between 0 and 1. Wow. Support vector machine 8381, XGBoost 8381, and this is 83.98. This is 83.84. 81.56, 81.56. Okay, so support vector machine is still the winner. As of now, it's the winner. Then I say pip install light gradient boost and importing it, creating an object, fitting on it, predicting on it, accuracy on train, test, and appending the values. And oops, not that great. Okay. Then I say pip install XGBoost classifier, import, create an object, fit, predict, train accuracy, test accuracy, appending the values, which is this same code. That is the beauty of machine learning. Unfortunately, XGBoost is also overfitting. Okay. Let me try changing some parameters of XGBoost. They say this is one of the most powerful algorithm. 92 and 81. Difference reduced, but still not that great. Let me try out the max depth parameter here. 91 and 81. Difference is 10%. Let me try to make the max depth as 6. Difference increased. Let me try to reduce the max depth further. Instead of 6, I think let me make it 4. Okay. As and when I'm reducing the max depth, the algorithm is becoming less prone to overfitting. Let me try use the max depth as 3. Not that helpful. Let me try making the learning rate even smaller. I thought we have got a very good model, but the model is underfitting. The training and testing accuracy both have become worst. Okay. So if you look into the XGBoost classifier, this is the official documentation for this. It has its own website and so many parameters. You'll just go crazy looking at the parameters. Here it starts. Data, label, weight, base margin, missing, silent, features. So many are there. Further, so many. Further, so many. Further, so many. Further, so many. So many. So many. So many. These all are parameters. See, data split, data mode, feature names. All of these are parameters. Such a lengthy one. That's why it is one of the best one. No data scientist remembers all of this. They just try hit and trial method. Now, I don't know what is this XGBoost task feature. I never used it. Okay, that's okay. Python features. No idea. Okay. Anyways. Then. Cool. Now, remaining algorithms you implement, I'll take your questions now, if any. I see 1 or 2 questions which are floating in the chat box. Yeah, that's used for parallel computing. That's correct. Sir, after finding the best algorithm for our model, can we give a passenger name and let the model predict? No, you cannot, because you have dropped the passenger name column. You have dropped the passenger name column because it is not important for predicting the survival. What is important? What features are the ones that you will give to the model? Well, it only you only need these features. Now, if you see carefully, the model says, I need the passenger class, I need age, I need fare, I need family size. Now, you'll be like, family size is not known. Yes. So, what will the user give? The user is going to give the following features. So, what will the user give will be T class. User will give age, user will give fare, user will give family size, user will give is alone or not. User will give this, no, he will not. Originally, user will give the original features. You will have to take all of them and convert it to these columns. And then these columns are what you have to send ahead to the model for prediction. This is exactly what you learn in deployment. This is exactly what we learn in deployment. So let's say, I'll just take another 5-10 minutes of 5 minutes of your time to see if we can do this. So if you have to save this model, then if you want to save the model, you will have to import a class called a joblib. And I'm dumping the XGBoost model, which I last created. I know it's not a great model. So let's say I'm not importing the XGBoost. Let's say I'm importing the logistic regression model. And I'm also importing the scalar. And I'll just importing the columns to do this. And unnecessary columns also. And it is imported to a pickle file. Model is saved successfully. Where is it saved? It's saved here. These are the things which I have saved. Now, once this model is saved, I have to get into the deployment part. So what I do over here is I'm doing it very fast. Next time, if I get time, I will talk about it in detail. So now I say deployment of the model. The first thing is I'm using the Streamlit for it. So Streamlit is one of the open source library and it will be imported. You remember on the very first day, I had shown you one deployed model, which is the tips data set. Do you remember this tip prediction app, which I shared the link with you? Yaad hai kya? We did see this tip prediction app. Yes or no? This is deployed. No? Okay. This is how a deployed application looks like. I'll show you. Have a look at this. This is there on the cloud. So what is happening over here is it is a regression problem. You remember while doing the Seaborn library, we worked on the tips data set. Yaad hai? We worked on the tips data set. When we had a session on Seaborn, we worked on the tips data set. Hotel tip. It was a US data set. Yes or no? Don't remember? I remember we did. You open up your Matplotlib and Seaborn notebook. No problem. No problem. Don't worry about it. No problem. Don't worry. So see here. Basically, what is this problem is, here we are asking the user what is the total bill when you went to this restaurant. So I say the total bill is $15. How many people went? I say two of us went to this restaurant. So who paid the bill, male or female? I say male. Is the male smoker or not? I say no. On which day did you go? I say Friday. And whether it was lunch or dinner? I say dinner. So the tip predicted is $2.64. If I said I go on lunch, the tip predicted is $2.73. If I say I am a smoker, the tip predicted is this. If I say we went as a total group of 4, the tip predicted is this. So basically, this is a machine learning model behind which is doing this prediction, and I have done the deployment of this, and this is exactly what we are trying to do for the Titanic dataset now, because end user will be shown this user interface and not the code. So we will discuss about this later. I'll revise this deployment part. I'm just trying to see if I'm able to help you out over here. So as far as installation of Streamlit is done, you will have to do it. Then the next is you'll have to create a new file app.py, and I will to write this over here. Import Streamlit, import joblib. We'll be doing this into a new file. Import pandas, import NumPy, import the standard scaler, import the logistic regression, import the accuracy score, import train test split, import decision tree classifier, support vector. I don't need all of this. I'm only taking logistic regression. So logistic regression, then I say import warnings, and then st.title. I'm giving the Titanic survival rate. Sidebar is sidebar title. I'm asking to choose the model. No, I'm not asking to choose the model. So I say after that, I will say accept the user input. So the user will be giving what all things. So I'll be having the initial, if I remember the very initial part, when we had read the data set. So over there, the initial part, the first thing that we read was the passenger ID, right? So user is likely to give the following things. Passenger ID, user will give. We have to ignore it, but user will give. UI will be like that. Passenger class will be given by the user. We'll explain this later. Age will be given. So uh, uh, age I want to be given, and age in the limit 0 to 80, because there cannot be any passenger above 80. So I say age is equal to slider 0 to 80. Then sibling spouse count can be given. Parent children count can be given. Fare can be given. Family size, I will have to compute it. Age alone, I will have to compute it. Embark will be given. And then I am going to give the title as well for these. Gender class would be given. So one will be child, then there will be female, and then would be male. Then I will have to load the model. I will have to load the scaler. I'll explain this later. Load the columns to be pickled, unnecessary columns to be dropped, and I'll create a data frame. So passenger ID would be there, passenger class would be there, age would be there, sibling spouse would be there, parent children would be there, fare, family size, is alone, embark, title, and then you can have after title there will be gender, right? Title, gender class. Then after gender class, yeah, that should be the end of it. Then I create a data frame. I'll drop the unnecessary columns. Then I will have to do the dummification, which is over here. Then I have to do the scaling of the unnecessary values, which will be there. And then I load the model. If it is going bouncer, no problem. What I'm showing you is what I require 3 hours for, right? You focus on the result now. Don't unnecessarily think about it. Okay. So Control A, Control C, creating a new model. And I say app.py. Control S, maybe run. Streamlit, run app.py. Oops, unterminated string. Okay, I go back. This gender, yeah, I thought so. This color. Saved it. Once again running. Now it says accept the user input. What happened over here? Here, accept the user input. I uncommented it, I guess so. Yes. Where did I do that? Dummification has to be, scaling has to be, prediction has to be, and load the model has to be commented. Age in the limit has to be commented. Accept the user input has to be commented. Don't worry about this. Drop unnecessary column has to be commented. Save. Create a data frame also has to be commented, which is and now cannot import logistic regression on sklearn.tree. Okay, that's a error. So from where is that sklearn.tree? Linear model. That's okay. This is extra code. Control S. And okay, we have got awesome thing. And it says key error. Right. But we got a UI. Name sex ticket did not come up. No problem. So we will have to column to drop. Unnecessary columns are this. Load and drop the unnecessary columns. And what is it saying? Key error, name sex ticket not found in the axis. So we say save. Okay. Super dot drop name sex ticket and here name sex ticket not found in the axis. Okay, wait a minute here. When I'm doing this, dropping of the unnecessary column. Okay. Oh, passenger I didn't take name only. So name. Then after that, after passenger ID, It has to be in the same order, right? So passenger ID, then you have survived, then you have P class, and this. No. Passenger ID, name, and this will still give an error. I'm pretty sure about it. And name, section, what was that? Ticket. So ticket comes exactly before fare. Now it says sex. Sex is coming 2 times. No. Sex is not defined. We didn't take sex only as input. Sex is equal to su dot sidebar select box, and inside the select box, you will say sex, comma. The first one would be male. The second one would be female. So sex is defined now. And after sex, now something new will come. Name sex ticket not found in the access. Because it has to be in the same order. So your passenger ID will go, this will go, age will be selected, all this will come, and here the prediction comes. But I randomly did it, right? So it says that when you are dropping name, sex, ticket, cabin, it's not found. But why? Where am I dropping it? Name, sex, ticket, and cabin is not there. Cabin. Now drop this. Oh, here. This I added, na? I don't want it. It's already out. Now it says, in the scaling part, this is good so far. In the scaling part, it says app.py columns to be scaled, and columns to be scaled is what it is not able to find out. And after dummification, after dummification, columns to be scaled, and that is loaded or not loaded. Columns to be scalar, columns to dummify, and columns to scale. I didn't note it. I will have to take it from this thing. So here, Control S. Then after that, this is sorted. Now it is saying the feature names should match those who were passed during fit. Feature names unseen, cabin feature name seen at fit, yet now missing. Cabin column, did I drop it or not? It says here, when I say predict, yes. So while prediction, what all columns it require? So when I am predicting it, here also I see that when the model says predict, it is not able to get the things. So if you open up this before prediction, what all are the columns I require? So I can see that by xtrain.columns. I should compulsorily have only these columns, then the model will be able to predict. So only these columns are allowed. So I will just insert this. How well? Now, I would say after doing this, select the columns into DF. Title, Mr. and Miss, and title Miss, Mr. Right from title till the last, everything I'll take it. Till the gender class male, I'm taking it. And now it says P class, this is this. And these are not found. Gender class male not in the index. Why is it not in the index? Let me see. Gender class underscore male. Here I have male and female. Oh, sex is there. Sex, I don't want it. Okay, sex will be coming. Male, female. And what is it saying? Is P class age this. Race key error. Not found. Embarked underscore q is not found. Why it is not found? We have already selected the columns. Scaling is done, dummification is done. If the dummification is done, I should be able to see that. Let me print df dot head to see that. Control S, Control C, streamlit. Error is for sure, but I want to see df dot head. What is it giving me? Df of P class is selection wise only. Here it is getting a problem. So it's not coming to this line. So before the selection, let me put the df dot head so that I'll come to know exactly what is wrong. Okay, I only have the following columns: P class, age, fair, family size, is alone, and cabin. All other columns are not there only. That is the problem. Okay. What I'll do is I have created the data frame. And after creating the data frame, I know I only want those columns. So the first thing that we do is dropping the unnecessary columns. Unnecessary columns are already here. So let me print the df dot head. So which all columns I want, I'll just print over here. I don't want to print anything here. Control S. Here, when I say yes, so now I have this following column: passenger class, age, fare, and this is okay. These all columns are there. After this, all columns, I want to do dummification, and after dummification, let me see what columns do I have. So after dummification, where I did this passenger class, age, fare, this, embarked. Oh, dummification is done or not? pd.get dummies, do this, and print df.head. Yeah, I think dummification is not happening as expected. Get dummies, and the columns to be dummified are already here. So why am I not able to have the columns dummified? Let me specifically take it from here only. These are the columns to be dummified. So I'm not loading it from here, but before this, I'm saying these are the columns to dummify. Save it and then show me. So yeah, dummification is done or not? Streamlit. And let me see if the dummification done. P class. These are the columns to be dummified, and get dummy, and print df.head. So it should ideally dummify. Oh, dummification is only not happening. These are the columns to dummify. So if I am accepting, so what all are the columns before dummification and after dummification also I will see. Unnecessary column dropping also, I'll specifically take it out from here only. Basically the deployment part, Control C, and unnecessary column, dropping unnecessary column, and then saving it, running it. So first of all, yes, dummification is okay. These are the columns, that's fine. And then I'm saying that drop the unnecessary columns. So passenger ID and all those things are gone. I'm left out with this column. Two times head is there. And then after high, dummified column should be printed. After high, dummification is not happening. Embark title. So before the df columns to dummify, before this high, you should have the columns ready. But I don't have the columns only. Embarked and all things are out. Why are they out? I'm seeing this. Embarked is there, embarked is there, and after high, embarked is not there, but I don't have dummification things as well. So columns to dummify are this. The first thing is, after creating a model, let's say logistic regression model, uh, we created a model, same like linear regression, fitted over it. Then we predicted on train and test data set. Uh, See, there was one alarming concern uh, where one of the learner was not satisfied with the session. Only one. This is what I found yesterday. But looks like he was little more sad because he rated the session 3 star, and I was little worried overall. So let me just give a little bit highlight on that. Everyone had a 5 star rating except one person, and the rating was not 4, it was direct 3. And he said that we are from the non-technical background, and so I'm teaching very excellent, but today I was very fast, and because of which only the technical students were benefited and the non-technical were not. So, see, I just want to make it clear by investing a minute in making you all understand that whatever you study, it is your duty that you go and practice and revise and come. I was continuously whenever because here I will like to justify myself. I am pretty sure I was at a very slow pace when I went ahead with the classification notebook. The speed increased. My speed increased only and only when I started with the modeling part. And that too, because I know that here you have already implemented linear regression. So this line was similarly taken from there, from sklearn.linear model, import linear regression. Then creating an object of linear regression. If the object name is LR, then fitting on X-train Y-train. Then that object name will be used for predicting on X-train. Save it over here. So you divide it, then you ask it to fit on X-train, Y-train, and then I'm predicting on X-train, and I save the output as Y predicted train. Then I'm predicting on X test, which is this, and I save the output as Y predicted test. And then earlier it was R2 score, which was assessing Y train and Y pred 10. Now it is accuracy score. And here also it was R2 between Y test, Y pred test. Here it is accuracy score. And then after that I printed it. This was the place where I increased the speed. But here I would like to tell that particular person and everyone that I think because we did something that we had already done in the previous class, increasing the speed a little bit while talking about these things. What had we done? We had done nothing great. We implemented CatBoost using the same code, importing part, and then the same thing. Then we implemented light gradient boost using the same code. So I think it was okay to increase the speed over here because it was the same repetitive code. I hope you agree to this. Yeah. When I get into the modeling part, I think this was repetitive code. So obviously every time I'm going to start with the modeling stuff, if I start it very, very slow, then we will never be able to take a step ahead. So see, whenever you see something which you have already seen, I have to increase the speed. That is where, that is where my request is, you have to revise the things at your end as well. Only coming to the session and purely relying on me is not going to be the solution, because you also know it very well that I am giving you a lot of additional information than what is there. Yes, if I follow everything which is there exactly like it is in the deck, then I can further lower down the speed. But I don't think so that is what you wanted. So when you want this much thing in this much time, I'm just trying to make you all understand that first time when you're learning the things, we will keep it slow. I remember NeoBias project of the NLP we did. We looked at how to do the modeling. During regression as well, we did the modeling. So this is the third time where we looked at it. So obviously speed has to be increased, no? How can you expect the things to be done at the same pace? Think about it for a moment. So it is my duty to make you understand, and it is your duty to revise it. I hope all of you agree to this, because going forward down the line, there will be many things which will come again and again. So we will learn the things slowly for the first time and then little faster from the second time onwards. Do let me know if you have any other perception around it. I can definitely look at it in the chat box in case if you have a different perception on it, friends. If you agree, you can just say agree in the chat. That is also completely fine. If not, please put in your perception. I'm happy to hear it. Yes. They say, na, you cannot shake with a single hand. You need someone else. So you cannot clap with a single hand. So my efforts and your efforts, both are required. Only coming to the session will one day make you feel overwhelmed. Right? So please, to all of you, if you are not revising the things by any chance, then do revise it. Okay? Slowly, steadily, you will feel lost. That's important point. Great. I'll go ahead. Thank you very much for your inputs. I see all of you do agree with me. I hope it's actually the same thing from everyone. Thank you very much. Yeah, so now I'm going to spend, if you recall, we did say deployment if possible. So today I'm going to show you deployment using Streamlit. But the main agenda for our today's class is deep learning. That means this part I have to cover a little faster. This entire thing takes around 3 to 4 hours. I am going to finish off this in 15 minutes. Okay. So please make a note of it. Let's get started. The first thing, what we did is after creating the logistic regression model, I said, you save the model. So when I say save the model, we have a library called a joblib. So your machine learning model is what? Your machine learning model is logistic regression, logreg. This is the object name. I say joblib says use the dump method and the intelligence is saved into the pickle file, pkl. You can give any name to this. I gave Titanic model.pkl. Similarly, if you remember, what are we saving? We are saving the intelligence after doing the fit, and fit is study. I remember we also fit and transform when we did the scaling. So we also need to save that. So our standard scalar object was called as SS. I'm also saving that. And then I say model is saved successfully. The moment you do that, you will have this Titanic.pkl, Titanic scalar.pkl here. Then after this, you open up this app.py. I imported the necessary libraries. So you can see Streamlit, Joblib, Pandas, NumPy, scaling, logistic regression I imported. Then those files which are there over here, I am loading it. So while saving it, we use the dump method. Now I'm using the load method. So these objects are available. Now, if you see, I am saying we have imported streamlit as st.title is this. What happens? Have a look. That's the title. So you can see st.title is Titanic survival prediction app that comes here. This app predicts the survival of passengers dot dot dot. That's coming because of the write function. Then if you see, we have select the ticket class and I have a drop down which allows me to select 1, 2, and 3. So I'm having select box inside ST, which gives this message and these 3 options. Similarly, let's look quickly. Age. I don't want person to enter any age. So I have restricted the age between 0 to 100. Similarly for fair. Then I have also taken input the number of sibling spouse count. So if you see, age is the slider, as you can see it over here very clearly. Then fair is also slider between 0 to 1000. Now, if you see sibling spouse count, I'm having the message enter the number of sibling and spouse count over here. And this is completely correct. But after that, you also need to note over here that I went into the data set and I actually saw what were the sibling spouse count of the passengers. So in the data set, the sibling spouse count of the passengers were 0 or 1 or 2, 3, 4, 5 or 8. No passenger ever had the sibling spouse count as 6 or 7. So I also didn't allow the user to select anything other than this highlighted portion because my model never learned about those things. So we cannot allow it as well to have it. So those values are only there. This is where you have to be very careful. Similarly for parent children, and then embarkation is CQS, title is Mr. Miss Master, and gender is male female child. So this is the parent children count, embarked, and title also. And I also said that because this is only for one record, the moment the sibling spouse and the parent children are here, I'm performing this calculation and creating variable family size. Then I'm also creating is alone where I say if the family size value is equal to 1, say 1, L0. Then I'm taking the gender class, male, female, child. Now, this is only for one record, one record. Now, all these values I am saving into a dictionary. You can see key value pair. P class, this value. Age, whatever value. So whatever values the user is entering, they are saved into these column names. The names of the column must be exactly same like the names the model has used. I save into a data frame, index equal to 0. That was just, I was just checking whether the code is working or not. So these all lines are there. That's optional. Then after that, you cannot see, can you give the embarked value as it is? No, as far as I remember, embarked value, title, and gender class, we had dummified them. And after dummified, I got this. So the model needs these columns for dummification. It doesn't need the embark column. It needs embarked underscore C, Q, and S. So I had to do that manually. So I say that if the embark value is equal to C, then C value will be 1, Q value will be 0, S value would be 0. If it is equal to Q, then C0, Q1, S0. Else by default, it is going to be S. So C0, Q0, S0. So it can be either it. So these vectors are formed either this or this or this. I'm doing the same thing for title as well. If it is Mr., then Mr. column should have, or if it is Miss, then Miss column should have 1. If it is Mr., then Mr. column should have 1. If it is Mrs., Mrs. column should have 1. Else, master column should have 1. Then do it for everyone. Then drop the original columns and get the columns exactly in the same order and same format. You cannot change this. When you did predict on X test, you had these column names. You cannot even change a single column. Even if you have this title miss with miss M small, it will give an error. While training, the name of the column was title underscore miss. So here also it has to be the same. If you change it, you will get an error. Then after that, I did scaling. Selected the columns. Scalar object is already there. I directly transformed on it. And then you print the data frame. I just checked it. I was doing that. Then I said, ask the model to predict. It is already loaded. And if my prediction is equal to 0, then st.error, passenger did not survive. Else passenger did survive. So you can see over here, st.error, passenger did not survive. And if I say this, st.success, passenger did survive. So you can see the green and the red boxes. And this 1 and 0 is also printed below. If he survived, it was 1. And if he died, it is red. So this is how we did the deployment. So first we created this file. Now, let me take the questions in the chat. We take the values directly instead of hard coding. You can take it, but that would be wrong, no? So while training, if your data set never had anything other than these values, and if you're taking it, then machine learning models work on a very simple funda, garbage in, garbage out. So obviously, if you're giving in the wrong thing as the input, you are expected to get the wrong things as the output. So one should not do that. Then can we use the get dummies to do this? Unfortunately, your get dummies cannot be used over here. I'll tell you the reason also. I also tried using it. If you see over here, Yusuf, I tried using it, and that is exactly where I was committing that mistake. So when I was doing this dummification, what was happening is what is going to be there in the embark. Let's say embarked has a value like, let's say in the embark user selected Q. Huh. In the embark user selected Q. In the title, he selected Mr. and in the gender, he selected female. So what is get dummies going to do? Get dummies will be creating the columns. And what will be the name of the column? Embarked underscore Q. Title underscore this, gender class underscore this. But we require the columns in a specific order. We need it as embarked underscore C, embarked underscore Q, embarked underscore S. So because there is only one row, you will not get 3 columns. That's the problem. That is exactly where I was going wrong. In title also, you will get only one column, but you need all. Wherever Q is there, it has to be one, and other two, you will never be able to compute. Therefore, get dummies cannot be used. So that is exactly where even I was making mistake. You can see I tried doing all of these things, and then I realized why are the things happening. So I tried checking the data types after doing the dummies, and then I realized, okay, this is the blunder which we were doing yesterday. So I had to do this logic. And once you have this in place, things are very simple. You have to create a file, requirements.txt. On the GitHub, you will be creating a repository. And creating a repository is as simple as this. Go to here and say new repository. And your files which are mandatory to be here is the app.py, requirements.txt, and the pickle files. Other you don't require, but I added it extra so that everything related to this project is in one folder, but you only need these files. And then you copy this path. This will be required sometime later. Then I went to Streamlit community sign up. I just signed up over here. And then I clicked on create an application. And I say deploy public app from GitHub. Right? You can do it from others as well, but I said deploy this. The repo name, which is this path which we copied, I'm going to paste it here. So it will automatically go to GitHub and access this folder. This you need not change it. The name of the main file path. So if you look over here, which is the main file among all this app.py? So I will write over here app.py. And then this will be the URL. And then you just have to click on deploy. And once you click on deploy, it will automatically open up the URL. And that is the URL which I actually shared with you over here. You can see over here. See this. IRA Logistic. I gave this name like that. So it came actually from here. So IRA Logistic and some key. So the same name, you will see something in the, because that's last time it gave me this name. But now having said that, it is deployed on the cloud and anyone can access it. Anyone can access it. That's why you are also able to access it. As simple as that. In the same way, the tip prediction app also worked the same way for you, which was this one. I deployed that also. I did not show you the code for it, but here also you can understand this is for st.title, st.write, then this is the slider available, not slider, this is the uh, select box with the controls available. And after that, you are having the predicted amount. And precisely. Now, what is the problem statement? We are going ahead with the deep learning project, and I will explain it as and when required. Let us first get started with the project. So the task over here is to design a feed forward neural network for image classification on the MNIST data set. Now, the library that we are going to use for this project is TensorFlow and Keras. So TensorFlow is an open source machine learning library for research and production. Keras is high level neural network API over here. Now, TensorFlow is already available in the Google Colab environment. Then after that, I say TensorFlow is a library for, for fast numerical computations. It is created by the Google Brain team. Now you need not install it in Colab as well. You just have to say import TensorFlow as TF. And I will also like to print the version, which is TF dot underscore underscore version underscore underscore. And this is the version which I am using. Whatever be the version, it does not matter. Then after that, I say, uh, we are getting started. Now, see, this time, be it machine learning or be it deep learning, EDA is definitely one of the most important stuff. But I don't want to get into the EDA part again and again. So this time I'm taking a data set which is directly having a good structure. And the data which I am taking is a built-in data set called as MNIST. Now, this is how the data is there. So this data set consists of images. So obviously you have a data set where you have X and Y, which is further divided into this. Let me tell you that there are 60,000 images in the trained data set and 10,000 images in the test data set. So image 0, image 1, right up to these many are there, and image 0, image 1, right up to 9999 images are there. So this is one of the image, which is what? It is the image of handwritten digit. Someone has written it and a photo of that is taken. The photo is a very, very low quality photo. The resolution of the photo is just 28 cross 28. If you look at any of the photo that is being taken from your mobile phone, it's going to be at least 1000 cross 1000, at least. This is a very low quality photo. So this is the image, and what is this image about? This is the image, and what is this image about? So basically you have a photo over here, and what is that photo about? You have another photo over here, and what is that photo about? As you can see, right, some of these things are not very properly written, and that is what is the problem over here. So the main aim over here is we want the machine to understand the relationship between the 60,000 images. Titanic consisted of only 891 rows, but here we have 60,000 images. I want it to understand the relationship, and then I want to see how good is the model doing on this 10,000 unseen record, which will be giving me the prediction. And then I will be comparing this, which is the actual and predicted, and I'll see how good is my model. But this time, what I will be using is a neural network for the same. So that is essentially the idea behind it. Right? So these all things are here. Now let us try to understand this thing. So what is exactly the MNIST data set? So I say MNIST data set is a data set containing handwritten digits. It has 60,000 samples in the training and 10,000 samples in the testing. Each image is 28 cross 28 and each pixel represents value 0 to 55. Like if you look at any image in real life, this is how an image is in real life. So we as humans see image like this, which we call as pixels. But machines look at it like this. According to machines, all the pixel values are values between 0 to 255, where 0 means black, 255 means white, and everything between 0 to 255 is a shade of gray. So when I have this and this superimposed over each other, you can see this is 0 and this is 255. The rest all are gray shades. So that's one thing which I wanted to show you. So this is also one thing. So the labels are from 0 to 9. Yes, there are only 10 digits. 10 digits. So labels are always from 0 to 9. And the best part is this data set is already included in the Keras library. Now, what is Keras and what is TensorFlow? First, understand this. So friends, TensorFlow is very difficult to code. I remember when I used to do it long time back. So if you are from the non-coding background, TensorFlow is not for you. Then came a good man. He invented a layer around TensorFlow 1.0, and that layer was called as Keras. So what Keras said is that it is very difficult to code with TensorFlow 1.0. It says to the user that you give me the input in a simple format. I will convert it in the format required by TensorFlow 1.0. This TensorFlow 1.0 will do the computation. It will give me back the result. And before giving the result back to you, I will again convert it in a very simple format for you. So as a user, our job is simplified because of Keras. So this TensorFlow was owned by Google, as I told you. Then when Google came to know that, okay, there is some library like this, which is existing in the market and it is very much popular, Google found out who created this library, Keras. And then Google hired this person into their company with a lot of heavy package. And what they did is they actually integrated Keras with TensorFlow 1.0. So they integrated everything and they rebatched this product as TensorFlow 2.0. And from that point of time, it is really very, very popular when it is about using this library. So going forward, whenever you see these names, don't get confused. TensorFlow and Keras are the same today. TensorFlow and Keras are the same today. So absolutely do not worry about it. TensorFlow and Keras are one and the same. That's why I said, data set is already included in Keras means it is there in TensorFlow only. So we can directly import it. Our job is to design a feed-forward neural network to classify the correct digit. Okay, then let's now go ahead and load this data set. Now, what I want to do is I want to load in the MNIST data set. I just have to say this. Now, the above is the only standard way to load the MNIST dataset in Keras. You don't need any Scikit Learn library, no read CSV, nothing. It is because it's a built-in dataset, you will have to do it like this. If you are reading images from your own system, then the process is completely different. You have to go through every folder in your image and do that. But we are not touching that because our aim is generative AI. But this will give you an idea about deep learning. Now, after that, I would like to also tell you that splitting the data into train and test. So again, this data set, when I use the load data function, this data set is automatically loaded into the train and test. Again, let me tell you, you cannot do anything other than this. It's everything, it's like a prepared dish. You go to the hotel, you order it and you get your food. You need not chop up the vegetables and create it by yourself. So this loads the data. And now print this X train shape, Y train shape, X test shape, Y test shape. And you can see over here that the shape of X train is this. You know what it means? It means that there are 60,000 images in the training data set, and each image is of 28 cross 28 pixel. Similarly, the shape of Y train is 60,000 comma, which means there are 60,000 labels. I will show you how it looks like. Similarly, X test consists of 10,000 images, again of size 28 cross 28. Again, let me tell you, you all are very, very lucky that you are having every image of the same size. In real life, not all the images will be exactly of the same dimension. So again, over there, you need to use the computer vision library to get all the images to a very standard size. Here we are skipping out all these steps. Then, similarly, the shape of Y test is this. If time permits, please explain the relation between the Keras and TensorFlow. Nothing great. See, you just understand. Vijay, in very simple words, I'll give you two-line explanation of it. TensorFlow is very, very difficult to code. So someone invented Keras, and the advantage of Keras is you can give the input to the Keras, and Keras will take care of that difficulty and communicate with the TensorFlow. So as a user, you only have to communicate with Keras now. Rest all things are handled by Keras. So you can just consider that TensorFlow is like an eclair chocolate, and Keras is the wrapper over the eclair. So that when you touch the chocolate, your hands don't get sticky because there is a wrapper around it, just for simplifying your job. So you communicate now. because all of these are integrated together, now it is called as TensorFlow 2.0. So as a user, you will communicate with this library only. I just told you this story so that it is connected for you to understand. That's the only idea. So we will today be using what? TensorFlow 2.0, right? So we don't have to worry about anything. That's why I didn't even import Keras, because Keras is already there inside TensorFlow now. Okay. Then after this, all the images are having the pixel values in the range 0 to 255. Let us check it out. So what I want to do is I am trying to print the X train 0 and Y train 0. That is the first image and the label. So I say import Matplotlib as pyplotlib because it is there over here. And I am using the IamShow function. So IamShow function displays the data as an image. And I will also be printing the Y train 0. But before that, let me just show you how X train 0 looks like. If I directly print it, this is how it looks like. Let me just when I print X train 0, this is how it looks like. I told you it is 28 cross 28. So this is the first 28 values, next row, third row. In this way, there are 28 rows. But when I show it as an image, instead of printing X train 0, if I say IamShow, image show, IamShow stands for image show. And this is how the image looks like. But I said all of these are black and white images. Color, from where color came? Well, this image is getting plotted as a heat map. So it is mandatory that you use the CMap equal to gray to see the true image. You can see the quality of this image is really very bad. Each image is 28 cross 28. And you can see now the first row, then the second row, almost the first 4-5 rows are all zeros. The first 4-5 rows are all zeros. And zeros are black, right? So see, this is the first row. This is the second row. This is the third row. This is the fourth row. And I guess from the fifth row onwards, you started seeing some colors. So that is how the image is. And what is this image about? Y train 0 when printed, it says it is about 5. Similarly, if I'm printing the 110th image, so you can see this image is about digit 9 and you see it over here. If I say I want to print the 111th image, see, this is about, this is the image, this is the label. If I say I want to print the 112th image, this is about 1. In the same way, if I say I want to print the 1110 index wala image, it is about number 4. In the same way, I also want to print unseen data, right? X test is also there. Same code. So obviously I will go a little fast over here. So this is number 7, which is the unseen 0th image. And this is the label around it. If I look at 990th image. Just randomly, I'm checking it out. Now, what is this image about? What is this number according to you? But little confusing, right? Even I think it is too, but it is not written very nicely. That is why this machine learning problem is there, or this deep learning problem is there. So some of the numbers are not written correctly. So I want a machine learning model over here to do that prediction for me. Okay. Now what I am going to do, all my values, if I look into my Xtrain, all my values of Xtrain are zeros or some values between 0 to 255. And now my machine starts to complain, hey Darshan, these numbers are having quite high range and I don't understand. I'm not comfortable working with such numbers. So I will scale the data or normalize the data. Tell me one scaling technique that you know, which is going to make these numbers smaller. Yes. Standard scalar, min-max scalar, robust scalar. I am being very, very simple over here. I am planning to not apply any of this technique because I think I can make it even more simpler by dividing overall by 255. Like for example, 0 when divided by 255 is 0. 255 when divided by 255 is 1. Any value between them when divided by 255 will be giving a value in the range 0 to 1. So can I say indirectly I was able to scale the data something like the min-max scalar style to get all the pixel values in the range 0 to 1? Do you agree? Indirectly, I have done it in the min-max scalar style to get all the values in the range 0 to 1. In deep learning, this is how it is usually used. Okay, this is how it is usually used in deep learning. So I say, how do I do it now? That's pretty simple. So first I say, we'll only scale the Xtrain. So I say, normalize the Xtrain and Xtest. So Xtrain will be Xtrain divided by 255. Xtest will be Xtest divided by 255. This is done. Then after that, if you are of the opinion that Darshan, this data is changed, let me randomly go and plot this. See, this is how this image looks like. Huh? Now it is scaled, so this image might be distorted. Let's check it out. It still looks the same. You see, exactly looks the same. Or let's me take this number. This also is scaled by 255. See, it still looks the same. You remember that genie example, genie going into the bottle? I said every part of his body is shrunk down in the range 0 to 1. So there is absolutely nothing over here which remains unturned. Is that clear to all of you? Nagdeep, to you as well? That scaling is essential and it is not changing our data. Okay. Now that we have it, it is time for us to understand some things. I can also show you how the pixels look like. So if I say Xtrain of 0, See, all those values which were 0 became 0 point, and the values which were between 0 to 255, you can see they are in the range 0 to 1 now. The highest value is 1. That is how it is. And this happens for everything. Different normalization can impact the model. I don't know. Probably you can guess it by yourself, Yusuf. You only tell us, will this impact the model? Because I think you already know the answer to this. Put a little bit stress on your brain and tell me logically, should it hamper or it should not hamper? Yes, that's correct. I told you, you already know the answer. Scaling technique will definitely hamper. Definitely hamper. Because your data is getting changed. Your data is getting changed. So that is likely to hamper. After this, the next thing is we go and create a neural network now. So now, let's say, if I think of applying, or let's say creating a logistic regression model, is it possible? Well, I can still do it. So I will say that log reg is equal to logistic regression. Then I need to flatten the images. Why? Because the images are like this. You have 28 cross 28. So, first what I want to do, this is very important for all of us to understand. If you have an image which is 3 cross 3, not even 28 cross 28, 3 cross 3, pixel 1, pixel 2, pixel 3, 4, 5, 6, 7, 8, 9. The first thing that we need to do is flatten. So what is flatten going to do essentially is pixel 1, pixel 2, pixel 3, pixel 4, 5, 6, pixel 7, 8, 9. So I need to flatten these images. So obviously in my case, if you recollect, we have every image of size 28 cross 28. So after flattening, this is not going to go from P1 to P9, but it will go from P1 to P784. So that will be so long. So I say flattening the images. So that's the code which I am going to use it for flattening the 28 cross 28 image, which is 784. And over here, reshape -1, comma 784, reshape -1, comma 784, which means that the new shape should be such that the second dimension is 784, P1 to P784. Similarly over here. So I can actually just show you this once. So once I reshape it, this is how it becomes. After reshaping, let us look at the 0th record. So this is our 0th image. Let me show you the shape of it. 784 comma, right? Just like here, the shape is 9 comma. And earlier, without reshape, this is without reshape. And this is with reshape. So see, without reshape, I say the shape of zeroth image in Xtrain is 28, 28. And with reshape, the shape of this is 784, just like here, without reshape, it is 3 cross 3. And after reshape, it is 9 comma. Without reshape, it is 3 cross 3. And after reshape, it is 9 comma. In the same way, before reshape, it is 28 cross 28, just writing down the analogy. And after reshape, it is 784 comma. So now what are we doing, right? So see here, our image is 28 cross 28. Now we flattened it. So what happens over here is my image, the first image, right? So I have 60,000 image in the Xtrain. My zeroth image, which is 28 cross 28, has now become my zeroth image, which is 28 cross 28, has now become a vector of length 784, where this is pixel 1, pixel 2, right up to Karthik. Here I'm answering your question. Pay attention. 784. And the corresponding Y is available. My first image will also be pixel 1 to pixel 784. In this way, overall, I have 60,000 images. And the corresponding value of Y, which is what this image is about, is already available with us. In the same way, when I do the same thing for the 10,000 images which are available, so this is how we have the zeroth image of this, we have the first image of this, and in this way we have the 10,000 images, and we have the corresponding 10,000 labels. Now, the advantage of doing this, why are we doing it? The advantage of doing it is, if you see, this data set is very similar in the format of the logistic regression, where this is X and this is Y. This part is your train and this part is your test. I will be asking the machine learning model to understand the relationship between X train and Y train. And then I will ask the machine learning model to go and predict on the X test part, which are the 10,000 images. So basically, I'm making a deep learning data also same like machine learning, and I'll be getting the predictions over here. This will be the actual, and then I will be comparing the actual and prediction and find out the accuracy. That is the reason, machines don't understand images. So I am just showing or doing one possible way of me to get these things. Chandra, just go and recall about your concept of tuple. or NumPy. So what they do is whenever it is single dimensional, it is not 9 cross 1. It is not 1 cross 9 also. It is represented like a tuple. So this is how it represents. It is not 784, 1 or 1, 784. It is basically saying that, hey, in this row, there are 784 values. That is how NumPy arrays work. For example, if you have a NumPy array, which is having 10, 20, 30, and I'm printing array and I'm printing array shape. And if I have another NumPy array, np.array, like this, which is 2-dimensional, I'm printing the array and printing the array.shape. Now have a look at it. This is just about basics. You need to revise things. I'm importing NumPy. Done. Creating an array 10, 20, 30, and I'm printing it. So that print statement is printing this array.shape. 3 values are there, 3 comma. But here I'm creating a NumPy array, which is 2 rows and 3 columns. You see that is printed. And when I say array.shape, 2, 3. So basically, whenever it is 1D, this is how it prints. And whenever it is 2D, this is how it prints. That is why it gave it like that. Right? Yes. So, welcome. This is just a demo cell, not a part of our project. Just for your better understanding later on, it should not act as a confusion. So ideally, I'm not expected to create a logistic regression model. I want to create a deep learning model, but I'm just trying to show you that logistic regression is also something that can be created over here. So I'm fitting on the flattened images, right? Fitting the model, same like we did earlier. Then I'll predict on the unseen data and I'm calculating the accuracy. Accuracy is whatever is the accuracy multiplied by 100%. So see, it's taking time, right? You see, deep learning versus machine learning. So data is very big and logistic regression, you can see it's taking time. Almost 9 seconds are over and it is still studying. You can see over here 14, 15 seconds are over. And I'm using a very powerful system. I'm using a Mac M3, not even M1 or M2, the most powerful system. And it says that, okay, some warning came because of which it was not able to reach its maximum potential. But it says that I'm getting an accuracy of 92.58%. Let me also try to do the prediction. So I say Y prediction on the train, Y prediction on the test, and then I say accuracy on the train and test, and train and test accuracy, both I will print. This is not deep learning, this is machine learning. Now we are going to go ahead for deep learning. I just want to tell you that I can also solve this problem using machine learning, but the result will not be that great. We got a 92% accuracy. 92 is not bad, but deep learning can give us better. Please note the results of the accuracy. Much better than Titanic? Yes, of course, much better. Then, now, deep learning can give me even better results. Let me talk about it. So I say, let's go ahead and build a feed-forward neural network using Keras. Now, ignore the code for a moment. Ignore the code for a moment and I'll explain you everything. It will take almost 30 minutes for me to explain. So right now, just look at it at a very higher level. I'm creating a model sequential, adding a first dense layer of, no, not dense layer. First of all, then I will be having the flattened layer. So I'll be flattening it. Then I'm adding a dense layer of 128 neurons. I'll explain you that. I'm adding one more dense layer of 128 neurons. Don't worry about that. I'm just creating a neural network. You don't worry about that. So softmax. Don't you guys understand English? Do you really expect me to unnecessarily come and think about, talk about it again and again? Then you will be like, Darshan sir, you're talking very rude with us. Didn't I tell to all of you that I will talk about the code later? Yes or no? Yes or no? Just answer yes or no. Then why are these questions coming? Can't you just relax for a moment? Has it ever happened that I have not explained the program? Patience, patience, patience. Thoda ruko na, thoda, little, have some patience. I told you, how much time will I take to explain this code? What did I tell you? How much time will I take to explain this code? 30 minutes. Are my 30 minutes over? No. So wait. Right now, what am I showing you is the output, and then I'll explain the code. Okay. So the next is compile the model. So model.compile. Optimizer, this is fine. And then I am going to train the model.train and doing it just for 10 epoch. See, the neural network training has started. This is what is the training part. One can just go through the results. So what is neural network training precisely? It is going to go through X-train and Y-train again and again. So like you can see over here, first time when it went through, that is the first iteration, because I asked it to do it for 10 iterations. It says that first time when I went through it, I got an accuracy on the training data as 88% and on the validation data, which is the testing data, 96%. And the loss is 0.40 and 0.10. What is the aim? If I give you a book, do you agree that every time you revise the book again and again, your brain captures more and more information from it? So it is expected to become better and better. Agreed? If you revise a book again and again, you are expected to become better and better. Your knowledge increases more and more. All right. So I did this book revision for the first time, studying for the first time. Then I studied this book for the second time. My accuracy increased to 96.85 and on the test data set 97. Loss should decrease. So 0.40 became 0.09, 0.08. On the sixth iteration, accuracy became 99 and on the test is 97. Loss is further low. If I go down and down and down, on the 10th iteration, I can go for more also, but I'm getting an accuracy of 99.5, 97.92. Loss is also 0.01. That means as good as no loss. And here also 0.08. If you compare these results, with the result of the logistic regression, logistic regression was giving you the accuracy of 93 and 92. And this is giving me 99 and 97. First of all, ignoring the code, do you all agree that the deep learning is giving me a better accuracy? Huh? Yes. That's one thing which I wanted to make it very clear. Then I will start talking about deep learning. Okay, deep learning is giving me a better accuracy over here. Well, let us plot it. I'll explain every line of code, right from this point, right from this line onwards. I will explain each and every line of the code. Right now, you don't worry about it. Just follow the flow. I want to plot the loss per iteration. So basically, what I want to do is, if you see, this is the loss, how it reduced at every iteration on the training. This is the loss, how it reduced at every iteration on the testing. So I wanted to plot it. Okay, and this is how it goes, right from iteration number 1. So I can say over here, X label is the epoch, Y label is the loss, and title is the loss per iteration. So how across every epoch from epoch 1 to epoch 10, how the loss on the training dataset decreased and how the loss on the testing dataset decreased. In the same way, I'll explain this code also to you later. You don't worry about it. I want to plot the accuracy per iteration. So obviously from epoch 1 to epoch 10, the accuracy, right? We got the latest accuracy as somewhere on 99 point this and 97 point this. So how the accuracy increased on every epoch? This is also what we understand. Okay. Then now, uh, let us try to get into this. Now I am requesting 30 minutes of your time. That is where these things are going to start. Now, ideally, listen to me very, very carefully. If I am taking deep learning classes, I repeat, I hope you remember that our aim is generative AI, and generative AI uses neural network precisely. This is how the code of Gen AI is going to look. Not because I am saying so. I remember on the second day where I did show you few things like this. Variational autoencoders. See over here. Congratulations. This is the very first notebook which we are expected to go through. And now you see this code and you will be like, oh, yes, Darshan sir, we understand this code. You remember? I had shown this notebook to you on the second day and I explained you why you will not understand it. And I asked you as well, hey, do you understand this code? How many of you remember I happened to show you this notebook and I asked you, do you understand anything of this? On the day 2, where we started going for, right? You remember? So now we have finally become capable of understanding it little. You remember it, very nice. And now you can see this. This is exactly similar to this. So once we are able to understand what I had written, then understanding this part is going to simplify as and when we go ahead, right? So this is how you go ahead with the things. So getting started. Now we say few important first and foremost thing which I want to talk about over here is When should one go for deep learning? So if you consider the amount of data on the x-axis and performance of the algorithm on the y-axis, well, with machine learning, as the amount of data increases, the performance of the algorithm increases, but after a certain point of time, even when the amount of data increases, the performance does not increase, it stagnates. But with deep learning, initially, if the data is small, the performance is not great. But after a certain point, as and when the data is increasing, the performance of the deep learning algorithm keeps on increasing. I remember I talked about it earlier where I said that deep learning loves data. So when machine learning algorithms don't give good output, then one can think of trying the deep learning algorithms. And they have similarity with the neuron. So if you look at neuron, then a neuron looks like this. Right. So as I told you, our brain consists of 100 billion neurons. So each neuron is the simplest part inside the brain. There are 100 billion such neurons, and all of them are connected with each other via 100 trillion connections. The more you study, the more the connections become stronger. If you don't study, if you don't revise what I teach you, then your connections become weaker and your brain becomes weaker and weaker. So you have to train your brain with more and more information. So here, what happens inside this is if I am pinching you on your hand, signal travels from your hand right up to the dendrites. From dendrites, they go to nucleus. Processing happens and then it signals the axons. It signals the axons whether one should go and queries over here or not. So researchers then thought of creating artificial neuron. And this artificial neuron looks something like this. So here also, we understand that I have my inputs, I have my outputs, and this is where the processing happens, right? And this is called as what? This is called as neuron. In the same way here also I have a neuron. The difference is this is biological and this is artificial. This is where processing happens. This is where you have the inputs and this is where you have the outputs. So adding it over here for reference. Now, this happens with the help of a very simple formula, but more than that formula, we are interested in understanding how it actually works. So I'll give you a very basic idea of this thing. So a neuron looks something like this, and it can have multiple inputs and it can have multiple outputs also. I'm taking only a single output. So let's say the first input is x1, x2, and x3 respectively. And what will happen over here is initially on the very first days, when the neural networks were invented, they were giving only two outputs. either 0 or 1. So the output used to be 0 if w dot x is less than equal to threshold, and the output used to be 1 if w dot x is greater than threshold. Like for example, imagine uh, imagine there is a weekend which is coming up. Imagine there is a weekend which is coming up, and there is going to be a Punjabi food festival in my city. And I am trying to decide whether I should go or not go to this festival. And my decision depends on three things. The first is, how is the weather? The second is there anyone who can come along with me, whether my wife is ready to come with me or not? And the third is it near some metro station, because I don't own a car? So if the weather is good, it will be 1, else it will be 0. If my wife is ready to come with me, it will be 1, if not 0. If it's near a metro station, this will be 1, if not 0. And based on that, I'll be getting the output 0, means I am not going, or 1 if I am going. Now, every factor is not equally important to me. For example, uh, when we take decisions in life, right? For a person like me, you know, it is okay for me if my wife says, Darshan, I don't want to come. It is also okay for me if the festival is not near the metro station. Chalega. But if the weather is bad, I am not taking a step outside my house. For example, let's say for me, if it is rainy, then be it Punjabi food festival, be they offering food free of cost, I am not going out of my house. I don't like that chick chick. I don't like that rainy season type of climate. You know, imagine this scenario. What I want to tell you is, you can correlate this with your regular life. Every factor is important, but we weight every factor. Like in my case, according to me, weather is more important as compared to the other two factors to me. So do human beings take decision on the basis of factors as well as the weightage to these factors? Do you all agree? Right? Yes. For this, there are weights over here. And these weights are nothing but numbers. And what happens over here is a very simple calculation. W1 x1 plus W2 x2 plus W3 into x3. And this is what you check with a threshold, whether it is less than equal to or it is greater than. You check it with the threshold. Like for example, consider x1, x2, x3. Weather is good, but my wife is not coming and the climate is all on, it is not near the metro station. And I'm assuming the weights, you will assume it. All of these are my assumptions. So I'm, let's say, assuming it like this. So the calculation becomes weather is good. So this is 1, this is 0, this is 0. So it is 6 into 1, 2 into 0, 2 into 0, which is 6. And the threshold, which I'm assuming, let's say, is 5. Now 6 is greater than the threshold. Because I'm crossing the threshold, I will go. Therefore, output is 1. Essentially, I will go. But imagine a scenario to be like this. Wife is coming. It is near the metro, but weather is not good. So it is 6 into 0, 2 into 1, 2 into 1, which is 4, which is less than equal to 5. Because the output is this condition, output is 0. Therefore, I say, so I am not going. So perceptron model is helping me take a decision. Now, what we have to do, researchers modified this formula. Now we are not getting into that mathematics, but they said that, what is this? Wx less than threshold. They said that Wx less than threshold. Why don't you say, take the threshold to this side, less than equal to 0. And then they said, let me introduce a new term, bias, which is minus of threshold. So the equation becomes Wx plus b less than equal to 0. So because of which my new formula for the output became either 0 or 1. It will be 0 if W into X less than equal to threshold is replaced as this. And 1 if greater than 0. And that is how the decision takes place. But now, obviously, is this really how a human brain works? No. I mean, I'll tell you why the human brain doesn't work like this. Here, if you see, technically, what are we doing? We are just assuming some values of W and B, and we are substituting in this formula. And if the formula's value is less than 0, you take 0 as the output. And if it is greater than 0, you take 1 as the output. This is not how a brain works. Our brain doesn't work on formula. This output is very, very similar to linear regression. If you recall, the equation of the linear regression was mx plus c. The equation of the line y is equal to mx plus c. And this is also very much similar to that. So if it is the equation of the line, then this is expected to be a linear output. But our brain never gives us linear output. Our brain output is non-linear. Precisely, we ourselves don't know how the brain works. So now researchers said that how to take care of this. Just understand the overall story like a fairy tale. So researchers said that what we can do is we had inputs. So now we have x1, x2, x3, w1, w2, w3. There is a bias also, which we just invented, which is minus of threshold. And the output of this was linear. But I want the output to be non-linear. So they invented something which is called as an activation function. An activation function is going to have some mathematics which will convert linear to non-linear. These mathematics are too complicated. I mean, because you are likely to ask me some questions which, are likely to come from Sutanu and Nagdeep. They are likely to unnecessary stress me out. So I would like to, the questions are valid, but it's just that, right, we are not getting into those all things. The notebook that I did show you, for me to get to that notebook also, you can see over here, it takes good amount of time. See, I'm talking about the activation functions. And then finally, I get started with this after 30 slides. But in your case, I directly started with the notebook. And then you have lot of discussions around this. In fact, let me show you this, right? So neural network, then how does this happen? So this is the Punjabi food festival example, which I discussed. Then how this activation function was added. These all theory takes around 8 hours for me to cover. And then once this is over, after talking about all of these activation functions, we get into this notebook. Today, I directly started with this notebook. So you understand, I'm jumping across. And then we understand the working of the neural networks and all other things. Right? So these are things I'm not going to explain. This is too complicated, right? You can see we have a neural network. We are having the derivatives, loss, gradient descent, all. You are not here in the deep learning course. If I start explaining this, then at least 7-8 hours will go in explaining you this mathematics only. How is this prediction actually happening? So I am going to explain you only the things which is required, right? Else our generative AI course will get subsumed to only the deep learning course, which I can't make it happen, right? So we are here to mainly learn that and not this subject. But without this subject, you will not understand that subject. That is also for sure. So this is to make you all realize why we are not getting into those things. Now, this is a simple neuron. In real life, we get started. Now, in real life, you don't have one input, you have multiple inputs. But in our case also, we had x1, x2, x3, but there can be more number of inputs. In fact, if you recall your MNIST dataset, do you remember how many inputs do we have? X1, X2, right up to X784 versus Y. This is how the inputs were. Also, if you recollect, we divided it over here like this, where 60,000 images were there in the train and 10,000 images were there in the test. So here, if you see, the input is X1, X2, right up to X784. This input go on not directly to the output like it were going earlier, but you can have the intelligence part over here. So as you can see, you have an input layer, you have an output layer, and this is hidden layer 1, and this is the hidden layer 2, which is the intelligence, where hidden layer is the one where processing happens. So every input is connected to every hidden layer, and every hidden layer is further connected to every other and further output. Now, what happens? What happens is this first image, which is this one. This first image is what is given as input here. This first image is what is given as input here. The same thing, first it is transposed, right? It is horizontal, it is made vertical, it is given as input. Processing happens, and in return it will give me 10 outputs. In return it will give me 10 outputs. So this is the 0th output, first output. In this way there will be 9 outputs. This output will be telling me the probability of the input image being 0. This will tell me the probability of the input image having number 1, and so on and so forth. This will tell me the probability of input image having the digit 9. So there will be 10 probabilities, and after this we will be choosing the max of is 10. So if here, what happens essentially, understand the overall process. We said that we trained our network for some epochs. Epochs are nothing but called as iterations. We are training it for 10 iterations, which means it will send every image, every of the 60,000 images here. It will get the probabilities. It will find the maximum. Then it is possible that first time it didn't understand that well. So it will go back. And while going back, whatever are the weights here, here, and here, it adjusts. And then it again does that. So it went on for all the 60,000 images by sending it. So all the 60,000 images are sent one by one. So you will be getting 60,000 times output. You'll be taking the max of that. Then after getting the max, you calculate the overall error in the output. And then you go back and adjust these weights, these weights, these weights. So all the weights and biases are adjusted. Then you went on from iteration 1 to iteration 2, where you again send the 60,000 images. Again, you are getting the output. Now you calculate total error and you compare this error with the error of the first iteration. And again, you do the backpropagation. This is going to happen total 10 times. And I expect after 10 iterations, it really becomes awesome. It may not also, we don't know, it may not also. So there are a few things which I want to make very clear over here. So every neuron has an activation function, just like I said. You give inputs, then you pass it to the activation function, and then you finally get the output. This diagram, I'm now going to shorten it like this. So basically, essentially, what was happening over here was W into X plus B. And what was happening over here is the activation function was applied over WX plus B, and you get the output. Now, whenever I say I'm drawing this figure, automatically you should keep this in mind that this is what is happening, activation function of WX plus B. So everywhere here also the same thing is happening. WX plus B is happening. So all the W's into all the X plus B, and activation function is applied. Whatever is the output, that output is passed everywhere. Similarly, the same thing happens, all the W's into X plus B, whatever is the output after activation function, they are passed ahead, and so on. This happens for these 60,000 images, total 10 times. Is 10 a good value? I don't know, but we are trying around it. There is no perfect answer to anything in deep learning. It still remains same like machine learning. It's a process of hit and trial. So what I want to say, over here is few important things around it. In this neural network, in my case, there are 784 inputs. In this hidden layer, you can see there are how many neurons? 1, 2, 3, 4, 5. The number of neurons here and the number of neurons here, we can choose. In fact, here we have hidden layer 1 and we have hidden layer 2. They have considered only 2 hidden layers, but how many number of hidden layers you want, that also you can choose. So there can be 1 hidden layer only. This is not there. Or there can be 3 hidden layers, etc. And then you have the output as well. Output in our case is 10. Now, with respect to output, I want to tell you that every time I was discussing about something which is called as an activation function. Which activation function will you use? Well, first, if I'm talking about a classification problem, then the output layer will use sigmoid. Remember these rules. And sigmoid, sorry, if I'm talking about a classification problem, and if it is a binary classification problem, like our MNIST dataset is not a binary classification problem, but if I'm considering the Titanic dataset, then it is either passenger survived or not. So if it is a binary classification problem, then the output layer will use the sigmoid activation function. And if it is like MNIST, which is a multi-class classification problem, then the output layer will use the softmax activation function. If it is a regression problem, memorize it. These are very standard things which you will require throughout the 14 lectures. Other than this, you will not require anything. That is also one thing which is for sure. Then regression problem, linear. And for all the hidden layers, you can try out activation function like ReLU, leaky ReLU, ELU, GELU, SELU, SELU, etc. So what I exactly mean by that, as and when I go ahead, I'm going to demystify this. Don't worry a lot about it. I'm just taking out the important things first. We have it over here. Now let us start over here to understand this architecture. I think take a break. We'll take a break. I'll do one thing. I think Sutano's question is answered, right? Sutano, your question is answered, if I'm not wrong. I'm just exporting this. In case if you want to just go through everything, you can do it in your break time. Missed it. Okay. Will there be mn to n different weights, m neurons and n neuron there? Yes, that's correct. That's correct. That's 100% correct. Welcome. Okay. So I have shared with you the things. If you want, you can just revise it, because once we come back, we will try to connect everything with this network. Everything. Overall, I am pretty sure you might be like, Darshan sir, this is little overwhelming. Yes or no? I know that. Of course, it has to be. And if you're finding it overwhelming, let me tell you, it is not something which is surprising me. It is overwhelming for any person, even a person who is from the coding background does find it overwhelming. When I learned deep learning for the first time, I found it so confusing. At least you are learning it from me. So I'm there to clarify your questions. I learned this technology by myself. I had to do a lot of surveys, so many blogs I read, so many research papers I read, so many YouTube videos I watched. I myself know what all I did for understanding this working mathematics, right? So it's really not an easy job, but But the coding is super simple. If you're finding this code which is there on the screen difficult, that's wrong. Trust me, the code is very simple. You will see this type of coding right from today till the end of the course again and again. And it is simple, simplest. Without even knowing the M of mathematics, you still can become a pro in deep learning. That is the best part over here. Let's understand this concept. Right. Now, what is the neural network which I am creating over here? So friends, every time you create a neural network, you will have to write down this line. So basically, like for example, you have a laptop. Every time you want to use this laptop, you will have to turn on the power button. Just like turning on the power button is mandatory on the keyboard of the laptop. In the same way, every time you create a neural network, calling the sequential layer is mandatory, because all of these, get saved into the model. And you can see I am writing every time model dot add, model dot add, model dot add, model dot add, model dot add. And what is model? Model is nothing but the sequential layer. So you can consider this like a wrapper. And where is it available? TensorFlow dot Keras dot models dot sequential. So create a object of the sequential class. Create an object of the sequential class, and after creating an object, the first thing is I have to tell that, hey, my input tf.keras.layers. Earlier it was tf.keras.models, now it is tf.keras.layers. And which layer? Input layer. The shape of the input is 28 cross 28 because every image is of this size. So I am saying that, hey, sequential layer, which is called as model, I want to add an input, right? So what I'm basically telling that whatever input you will be receiving will be of the shape 28 cross 28. Then I say, the moment you get that input, first thing into this model, you flatten that input. Model.keras.layers.flatten. All of this happen exactly the way I explained you earlier. Flatten, right? It is going to flatten it out. So first I'm creating sequential layer by the name model. Then I'm telling to the model what will be the shape of the input. Then I'm flattening the input. And after flattening the input, I'm creating a dense layer. What is this? Let's try to understand. So how many inputs I have? X1, X2 up to X784. These many inputs are here. This is given to what is the thing I'm saying, that tf.keras.layers.dense. Dense is like I want to add a layer. Every time you want to add a layer, the layer is called as dense of 128 neurons. So 1, 2, in this way, I want 128 neurons to be considered. Okay. And the activation over here, I'm saying as ReLU. You can change this. Right now, I'm going with ReLU. Again, I'm saying to this further ahead, I want to add one more dense layer of 128 neurons. 1, 2. Now, this can be little more or less also, but in this, at least I'm saying 128 neurons. And then after that, I'm saying I want to add one more dense layer of 10 neurons. 1, 2, up to 10. This is 10 neurons. Now you remember there is nothing called as hidden layer or output layer inside the neural network. Yes, there is nothing called as hidden layer or output layer. This is all upon us. It is all upon us. I said that if it is the output layer, the activation function has to be softmax. I said, softmax, because it is a multi-class classification problem. There are 10 digits which we want to classify. So this notes I have already given it to you. And if it is hidden layer, then it is ReLU. But essentially, there is nothing. These are human given terminologies. Neural networks calls a layer as dense only. But humans say that if ReLU is the activation function, then that is hidden layer. So that's my hidden layer 1, hidden layer 2. And if softmax is the activation function, then that is the output layer. And no doubt this is the input layer. So all of these are connected. This input is connected to every 128 neuron. This input is connected to every 128 neuron. This input is also connected to every 128 neuron. This is also connected to every 128 neuron. This is also connected to every 128 neuron. This is also connected to each of the 128 neuron. And this is connected to each of the 10 neurons. This is also connected to each of the 10 neurons. And this is also connected to each of the 10 neurons. Right. So this is the neural network which I have defined in this scenario. And because, I told you every layer is called as dense. Internal layer should be given activation as ReLU, and the last layer, if it is multi-class, softmax, and if it is binary, you will give the activation as ReLU. So I just happen to add in this explanation over here. So this is the neural network which I defined line by line, right? First sequential, which is placeholder. Input layer is for telling the shape of the input. Then we have to chapta, which is flatten. Then 3 layers, dense, dense, dense. 128 neurons, 128 neurons, 10 neurons, 128, 128, and 10. Because I want to make this as hidden, I'll use activation as a ReLU. You can change this, that I'll show later. Not today, but I'll show that later. And this is softmax. If you use sigmoid over here, then the output will not be great. So remember the rules. So I did this. Now let me ask you, overall, did you understand how is this going to create this figure? How are these lines going to create this figure very quickly? It is going to repeat 100 times. Every time it will create a figure like this only. So even if you don't understand the mathematics, you don't even give it a shit. Just forget the mathematics because it is all taken care of automatically. I'm not saying mathematics is not important, but it is not required as well. Without that also, I can guarantee you that we will try to create some other type of neural networks also after some time. But first, let us look at the output of this neural network. So for now, this is the final figure for us. For now, this is the final figure for us. Just let it be there in the chat box. Okay. Now that we have this neural network, if you look at Maruti Suzuki car, what is their slogan? Kitna deti hai? In that sense, they are talking as the mileage. If you look at Skoda or the Volkswagen car, they focus on driving. They focus on performance. Do you agree? Suzuki cars are all about mileage. Maybe the power is less. Skoda, Volkswagen are superb cars to drive. You press the accelerator and you can actually enjoy what is called as fun driving. Correct or not? Right? Yes. So, in the same way, if you go for Tata cars, they focus on the 5-star safety. Skoda also does it, but I'm just taking different examples. If you look at the Tata cars, they focus on the 5-star safety. So basically, everyone optimizes their product for something. And so here in the neural network as well, we have to pass in an optimizer. So now that this model is created where you added so many things, you can imagine now that into your car, I like to call this, this phase which we just said that we created. What did we create this? I prefer to call this, I prefer to call this as this is what we did. When I say you created a neural network, according to me, I'm just comparing it for your better understanding. According to me, when I said you created this, I call it like our car body frame is ready. Now into this car, I want to fit the engine. Into this car, I want to fit the engine. So engine has to be optimized either for performance or for mileage or for something else. And that is what my optimizer is. There are various types of optimizers. This is the most famous. Right now, I'm going ahead with this. Later on, I will show you what all are the other available that you ignore for now. This is one of the thing which is available of Adam Super. And every time our neural network is studying this, because I'm going to make it study the same thing. I'm going to make it study the same thing 10 times. So going front and back is 1 time. Again, going front and back, we said 2 times study is over. In this way, this study is going to happen 10 times. Every time, what are we trying to do? Every time it is going to predict, while prediction, there will be a loss. And first time, if the loss is 500, next time I expect the loss to be little lesser. So on and so forth. As and when I go ahead, I expect the loss to be very, very less. So after every iteration, I also want the loss to become smaller and smaller. So for making the loss decrease, loss is the error in the model. So that lesser the error, more perfect the model. So to make the loss less and less, there are various loss functions. Here I am using the sparse categorical cross entropy. Why sparse categorical cross entropy? We will understand it in the next class. What other variations you can give it, we will understand in the next class. This is one of the thing. And metric I am going to consider as accuracy. Every neural network is going to demand this followed by this. And then I say R equal to model dot fit. This is like the logistic regression dot fit on X train Y train. So this is the same thing, fit on X train Y train. And while fitting only, I'm saying that, hey, this is the unseen data. In deep learning, we don't call it as test data set, we call it as the validation data set. That's okay. These are just the conventions. I say that this is the training data. This is the testing data. Please go and study over this for 10 times. Please go and study over this for 10 times. So it does that. It says that on the very first iteration, this is the training accuracy, this is the training loss, this is the testing accuracy, this is the testing loss. On the second iteration, these are the results. So on and so forth. On the 10th iteration, this is the training accuracy. You can see it was 88 initially, it became 99.5. Validation accuracy was 96.76. Now it became 97. It improved basically. Loss, which was 0.40, became 0.01, quite reduction. And test dataset loss 0.10 became 0.08. It may not always reduce also. That is why I said you will be looking at various types of things. So then, yes, what you asked, Prabhu, exactly the answer to that is yes only. Now, what I did below is we will be plotting the iterations. Iteration 1, 2, 3, right up to 10 on the x-axis. So x-axis will be having this values going from 1 to 10. And on the y-axis, I am going to plot these values. And another thing I'm going to plot on the y-axis is this values. So this yellow one is going to be the training loss, how it is decreasing across every epoch. And this pink one will be the testing loss, how it is decreasing or increasing across each epoch. That is what I did below, where I said import matplotlib plt.plot r.history. Why r? Because our model is saved into the variable r. So I say R has a history variable. You'll see this code repeating every time. First time you will find it little odd, but you'll see this code repeated for every neural network, not even for few. I'm saying for every deep learning or generative AI notebook, you will see this code coming. R has loss. R has a history variable which keeps track of loss and validation loss. You will not change anything in this code. And because I said plt.legend, loss and validation loss are printed here and they are plotted. Now, training loss decreased across the 10 epochs. Validation loss also decreased across the 10 epochs. So it looks like a good network. In the same way, this time I plotted the accuracy. R.history accuracy, R.history validation accuracy. And accuracy increase across every epoch. That's good. Loss and accuracy are exactly opposites to each other. So just answering your question in short, Sudhanu, optimizer is for optimizing the neural network. So this loss function is responsible for reducing the overall loss. So what will be the approach for reducing this loss? That will be decided by the optimizer. So it runs different set of mathematics depending on the optimizer given, and it tries to minimize this loss function. It is all related to how to optimize the loss function to make the loss function as close to zero as possible. Then, after this, we have this. Now I can use my model, which is ready for prediction. How can I use it? Well, I am saying that my model is ready. I'm saying model, go and predict on the X test. And let me show you the prediction. Oh my God. 10,000 values are there in X test. 10,000. So I have got 10,000 predictions. You can see it, this is the first prediction. 10 values are there because you remember this figure, right? You'll be getting 10 outputs. So for the first unseen image, there are 10,000 unseen images. For the first unseen image, there will be 10 outputs. For the second unseen image, there will be 10 outputs. So we have 10,000 images. So if you see here, for the first unseen image, that's the output. For the second unseen image, that's the output. For the third unseen image, that's the output. In the same way, for the 10,000 unseen image, this is the output. You think I'm joking? I can show you the shape. See, 10,000 comma 10. 10,000 comma 10. But when I am looking at this, do you all agree that this is the output for the first image? I want to find out the highest value among the highlighted portion. I want to find out the highest value among the highlighted portion. So I will go to NumPy, which we studied. And NumPy says, I remember I taught you argmax function. It will say that among this, which is the index, which is having the maximum value. And see, so it is saying the index location 7 had the maximum value. So it is saying that the first image is digit 7, second image is digit 2, third is digit 1, the 10,000 is digit 6. So now I have 10,000 values. You can confirm it out by checking the shape of it. 10,000 predictions, and what are these digits about is here. So what will I do now? Ultimately is I say the prediction is I'm saving inside the p-test. And then I'm going to create if you want, I can show you the p-test. I got this. Now, how to make sense of this data? So I'm going to make it in the form of a confusion matrix. I'll tell you what it is. Nothing new. Confusion matrix. From sklearn.metrics import confusion matrix. Just like we had accuracy. This is one more metric. Very, very powerful. Very powerful. So I say confusion matrix. I am giving exactly the same parameters which I used to give to the accuracy score function. So what is this? I'll tell you what it is. So you can consider here you have the true label, and here understand this very carefully. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We know that on our X test, we have total of 10,000 images. Now, you know what is this matrix saying? It is saying that the images of 0 were predicted as 0 976 times. So something which was actually 0 was predicted as 0 976 times. Something which was actually 1 was predicted as 1 1125 times. Something which was actually 9 was predicted as 9 982 times. I am more interested in the values other than diagonal, because diagonal is all about correct predictions. But interesting part is over here. Number 0 was predicted as 2 by the neural network 2 times. Number 0 was predicted as 7 by the neural network 1 time. 0 was predicted as 8 for 1 time. In fact, now if I say, let's find out the highest value from this matrix except the diagonal. Can you tell me what is the highest value from the metric except the diagonal? The highest value? 24? Okay. Let me look at 24. I'm just searching for it. Oh my God, where is this 24 gone? 49, okay. Oh yes. So number 4 was predicted as number 9 because some idiots write 4 like this as well. Yes or no? That is why I think this confusion is there maximum for the neural networks. In hurry-burry, we write it like this. Yes, that's very true. What is the next highest value after 24? 10. Okay. And where is that 11? Where is 11? 5360. Yeah, this. So number 5 is predicted as 3, okay? So probably people write 5 like this and people write 3 like this. So maybe someone has written it like this, and because of that, it was considered as 3. It thought that it is 3. Possible. I think that is the reason for this next confusion. But overall, it is a very good network. Why I say overall it's a very good network? Because we have 10,000 predictions and the diagonals are the correct predictions. So, I have Googled for a code which plots this in a much nicer way. I would like to share that with you. So you need not get into the understanding of this code. I am writing clearly. Kindly don't focus on the implementation of the code. I'm just copying it. And I'm pasting it here. So I have created a function called as plot confusion matrix. Implementation is not important. What it will essentially do is it will predict same like I showed you. It will create a confusion matrix, but I am printing this confusion matrix in a little stylish way. Values are the same. See 24, 11, 10. But now you have a nice title, darker the color, higher the value, and you have proper true label, predicted label written. So I think this looks better as compared to this dry one, right? And this code will never change, so you need not worry about it. Are you clear with this? How I just enhanced it for your better understanding? Yes. So code is not important. I have very clearly mentioned over here. Kindly do not focus on the implementation of the code below. So if you don't understand, I think this is also equally good to understand. Now, what am I going to do is I want to show some misclassified examples. So I am using the NumPy's where function. So what am I doing? Let me show you. I'll show it above. np.where. So I am saying that, hey, in my output, tell me the indexes where prediction is not equal to the actual, where prediction is not equal to the actual. So these are the indexes where, or these are the images which got misclassified. Now this is a NumPy array which is stored inside a tuple. You can see over here, outer bracket and ending with comma. So I only want the content inside this round bracket. So I said square bracket 0. So if I do that thing over here, observe what will happen. Now you have this round bracket array and this. I only want this content. I don't want that additional round bracket. So I say fetch the values at index 0. Got it. This was just for your understanding. So now these all are the indexes which are misclassified. How many are they? 208 indexes which are misclassified. So 208 out of 10,000. So the model went wrong how many times? Only 2.08% times. So the model is right how many times? The model is right 97.92% of the times. You know, this value is exactly what you have seen earlier. 97.92. You understood how this value came? Yes, so this is all mathematics. This is all mathematics. So our model is only wrong by 2%. Yes. Now I have got all the misclassified indexes. I'll just see why are they wrong. So I am planning to pick up randomly any one image from this and plot it. So I say, let's randomly choose one of the misclassified images and display it. So I am using the NumPy's random function. See, the real-time application of the NumPy library is what you start seeing now. When I taught you NumPy for the very first time, it was like, why are we studying it? But now you see everything in machine learning, deep learning is taken from NumPy. That's another important thing that you should note. So I am saying that, hey, out of these all 208 indexes, randomly choose any one index. Randomly choose any one index using the random dot choice function. And then I want to plot it. So plt.imshow. Then I will say plt.figure, and I'm going to say the figure size, I'm going to make it small. Maybe 1,1 would be good. So it becomes small because the quality is very bad. And I say plt dot I'm show. Okay, this has to be before now. My bad. Control X. So I'll give the title this. Oh my God. Look at this. Look at this. What is this image? What is this image? It's very difficult for a human as well to figure out what is this image. So neural network went wrong over here. Neural network went wrong over here. So this image is actually 6. It predicted it as 2. In fact, I think we also, euro symbol, we also would go wrong in this prediction. So, okay, I don't think so. We should blame neural network for this. Once again, randomly pick up indexes. And now, what is this image as per you? 6. Let us see what the neural network did. It predicted it as 5. Okay. What is this image as per you? Lambda. But lambda is not there in the training data. So the network predicted it as 2. So see, our model is 98% accurate. It is one of the best models. It's not bad. Logistic regression was 92. This is 98. And wherever it is going wrong, the images are actually very bad, because of which the prediction is not happening as expected. What is this number as per you? What is this number as per you? Model predicted it as 9. But you can understand why the model might have done that, because the image is not great. This number is again 3, predicted as 9. This is 8, predicted as 3. Now we have to tweak this neural network. The story does not end here. It has actually started, but this is just the beginning of it. Now we have to understand what all other types of networks can be created in this notebook and other things. We will see that in the next class. So Tanu's question, so an output of DL is always a probability distribution as I understand. How is the position of the class determined in the output vector? The same way as we did, no, Sudhanu? What is new over here? We are getting, as per the neural network, 10 outputs. As we saw here, 10 outputs. And using the argmax, we got the highest probability. That itself is the position. Okay. How to identify weights and also the threshold? Do we need to have the domain knowledge to determine? Well, no, Vijay, absolutely not. When I say the weights and all these things are there, so weights are something which are obtained by the neural network by continuously doing the forward and backward propagation. So when we say the neural network is trained, that means it started with some random weights and slowly and steadily it improved itself to get the best weights. So after 10 iterations, it has got the best weights. So if you want to see the weights, ideally one never sees it, but if you want to print the weights of the model, one can simply say model.getWeights and you get the weights of every layer. But what will we do by understanding this? This is just adding to confusion. But yes, you can print the weights if you want. But you will not manually once again go and multiply like we did in that Punjabi food festival example. But this is good for understanding. But I don't want to get into that mathematical part. Is there any way to select the number of dense layer? Any thumb rule? Next session, we will discuss that. So based on this insight, can we replace the not best of the images in the training? So the model accuracy? No, of course not. You can't do that, Prabhu. You cannot replace it. See, basically, you understand over here, Prabhu, in real life, the data will be shared to you with the client. So you will have to go to client and ask for more data. And if the client says that, no, this is the only thing that we have, then how will you replace? Right? Maybe here somehow you can create your own, but in real life, imagine you have 1 crore images like that. Are you going to do that replacement of 50,000 images? No, that is not your job. That is why. Please have a close attention at what I am doing now. So the project that we did last time, it was focusing on designing a feed-forward neural network for image classification on the MNIST dataset. So the first thing that we did is we imported TensorFlow. And after importing TensorFlow, this was our dataset. We had images and labels, 60,000 images in the training data, 10,000 images in the testing data. So we have to fit between this and predict on this. So then we directly loaded the data and we get 4 parts: Xtrain, Ytrain, Xtest, Ytest. MNIST dataset consists of 60,000 images, each of size 28 cross 28 in the train, and in the test 10,000 images, each of size 28 cross 28. Then after that, I showed you few of the images, like I plotted using the IM show the image of 5. Randomly, I'm plotting image number 110. Then after that is done, I happen to normalize the data. So every pixel was divided by 255. So overall, it becomes in the range 0 to 1. But after doing that also, our original image still remains the same. It is just pixel values are made normalize in the range 0 to 1. After that, I showed you that originally, if you look at extend 0 shape, so every image is of shape 28 cross 28. But if I say reshape -1 comma 28 cross 28, it becomes flattened. And this was the perfect image, right? 3 cross 3 when flattened looks like this. But in our case, it is in our case, it is 28 cross 28. So after flattening, it will look at 784 comma. This was okay. That was just a temporary part. Then I created a logistic regression model where I got my X after flattening, X train, Y train, X train, X test done. Then I asked logistic regression to fit on the data, logistic regression to predict on the X train, and then predict on the X test. So that is also done over here. And Once I'm done, I'm looking at the accuracy score and I'm getting 93.5 on the train and 92.5 on the test. But then I talked of creating a neural network. I created a neural network, something like this. So images are flattened. That we that. Then I said, important rules. So the rules were activation function of hidden layer will be always relu, selu, gilu, silu, etc. If the output is classification, then the output layer will have sigmoid if it is binary and softmax if it is multi-class. And for regression problem for which usually deep learning is not preferred, over there we use the linear activation function. So this is something, you can consider to be something that should be on the tip of your tongue. Then now I created a neural network like this. So if you see, every time you create a neural network, every time you are going to create a neural network, this is the way that you are expected to follow. You create a sequential tf.keras.models.sequential. So everything comes inside the sequential. Then I say that I want to add an input layer where I specify the shape is 28 cross 28. Then I say I want to flatten it. So model dot add, flatten it. Model dot add. Add a hidden layer of 128 neurons. Activation is ReLU. Model dot add a hidden layer of 128 neurons. Activation is ReLU. So every layer is called as dense only. When you give ReLU, we human beings call it as hidden layer. When we give softmax, we consider it to be the output layer. If you give here sigmoid or ReLU, I'm not saying output will not come, but that would not give you great results. So follow the image which I just shared in the chat. Kind of memorize it. So that's what we did here. Then I said optimizer. There are various types of optimizers available. We use the Adam optimizer by default. Loss function also we use the sparse categorical cross entropy, and the metrics also we used as accuracy. And then we said R equal to model.fit. So I'm asking the model to fit on X train, Y train and test on X test, Y test. Do it for 10 epochs. And this is how it overall ran. Then I looked at the results, and this is how you see, right? Now, if you see carefully, this is not really a very great network. I'll tell you why also. If you see this blue line, this is coming down and down and down. So I'm happy with this. I am happy with this. But if you look at this yellow line, looks like slowly and steadily, this is going to go up. So effectively, if you note, this difference, which was small, is becoming bigger and bigger. So what I want to say is the loss on the training data is low and stabilized, but the loss on the testing data, if I train it further, will keep on increasing, which means that my model is overfitting. It is learning the training data, but it is not able to predict well on the testing data. So here it's becoming awesome. Here it's becoming worst. So that is not ideally a good model. That is ideally not a good model. Your generative AI models also needs to be trained the same way. Obviously, these are Gen AI models only. Deep learning is, Gen AI is part of deep learning, right? So we have already entered into that part now. Are you all understanding why I said this is not a great model? Just answer with yes or no, Y or N, quickly. Yes, because if you train it further, you will not get things as expected. Yes. So now, now on the accuracy side, I think that's good. This is stabilized. This is also more or less stabilized. So accuracy is good, but the loss, that's not good. This is okay. Both of this should be good. Yeah, this is not good, so we don't agree to this. But still, I went ahead and here I asked the model to predict on the unseen data, save the predictions over here, and I plotted the confusion matrix, which you see over here. After that, whatever you see on the diagonals are the correct predictions. And whatever you see here and here are the incorrect predictions. Now, I said, let's find out where all the predicted values are not equal to the actual values. Y0, we already learned last time. Let me not get into that. So these all are the misclassified indexes. And how many misclassifications out of 10,000? 226. So 226 out of this. So last time the results were different. This time the results are different. That is a problem. We'll talk about that. That's why I'm discussing this case study. There are many things. This case study is going to take another 1 hour. Then I randomly looked at one of the image and plotted. This 8 was predicted as 5. This is how I got. Look at this. 8 predicted as 2. 8 predicted as 9. 9 predicted as 1. 5 predicted as 3. 2 predicted as 1. Then I showed you how to get the weights of the model and all. Now, I go up and I want to show you all the variations now. See, this was one way you created the model. I will comment it out. Let me say, this is the first way to build the model, and I call this way as the sequential API. Now I am going to build the same model, same architecture, but a different style. How do I write that? So way two is not using the functional API, but I'm gonna be using the basic model. Only and only using the sequential class. I'll tell you what I mean by that. So here I say TF is equal to, see earlier what I used to write. This is what I used to write earlier. If you see this, model is equal to tf.keras.models.sequential. tf.keras.models.sequential. But now what am I doing is, in between this, I'm putting square brackets and I'm putting enter. And here, what will we do is all these lines, like first line is over, but we have to add this input layer. Then we have to add this flatten. Then we have to add this dense layer. Then we have to add another dense layer and output layer. These all things right from here till here, I want to do it. Output will be the same. I'm just showing you another way to do it, because when you Google for it, you will get n number of implementations, n number of ways of doing it. So you should know that. So here I say now tf dot keras dot layers dot flatten. In fact, first of all, the first thing that we do is input. I give the shape. That's exactly what we did. Earlier, I was doing model.add, but this time I'm not doing that. Everything in the sequential. Sequential is the placeholder. Then I flatten. Same, right? Function is same, dot flatten. But it's just that I'm doing it inside this same code in a different style. Then I want to add a dense layer of 128 neurons activation as ReLU. That's how you add it. tf.keras.layer.dense. Again, one more dense layer, activation ReLU. Added. Again, one more dense layer, 10 neurons, activation softmax. That. Rest all things remain the same. Rest all things remain the same. Your results will also remain the same. This is another way of building a neural network. If I click on run all, it will run everything. What is it doing? I don't know. Or doing something in the backend. You see, same thing. It's just that a different way of writing it. So code, output, everything is going to remain the same. What I want is you to observe the way I did it. So tomorrow, if you see this style of coding, maybe when you visit any other internet sources, do not get confused. Darshan has taught you all the possible ways of creating a sequential layer. You can see the outputs will also remain the same, right? More or less the same, right? I want to show you one more way of creating it. So commenting out this. And the third one is using the functional API. This is considered to be the most uh, popular way of doing it. Recommended and popular as well. So most of the deep learning engineers prefer this approach. This is also very easy. Same thing I want to do it. So first is our input layer. So I say inputs is equal to this. So look at this. Huh? So I have first have to add an input layer. So that's what I did. Now after this, I'll be taking this input. I'll be taking this input and I'll be passing it below. See how. So I say, look at this. These inputs from here are passed here. And then I say that, okay, now these are the inputs 28 cross 28. Please flatten it. So it gets flattened and gets saved inside X. After flattening, what is the next task to be done? Dense layer. So now this X, listen to this, this X is passed here. I add a dense layer of 128 neurons, activation ReLU, and we save it back to X. Now you will be like, Darshan sir, why are you not saving it into Y, Z or something else? Because here you give inputs, then you pass inputs and then you saved into X. Now to pass X, so you save it into something else now. I'm not doing it. You will also not do it. I'll talk about it in some time, but please don't do it. Okay. Then another dense layer of 128 neurons, this line. So this X, which was ready, I passed here. And after applying another dense layer, X is saved. Then I have to add a softmax final output layer. Now this X is passed over here. Then you apply the dense of 10 neurons, which is the output layer. And the output is what you save inside outputs. Okay. So you see, the first is inputs, the last is outputs, and in between everything I'm calling as X, 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 X. Remember, this is the style of functional API. This is the style of functional API. This doesn't end here. It main thing is this line. So now we are getting into building the model where I say tf.keras.model.model. So you will have to import the model class as well. I don't remember we imported the model class or not. So I need to do that from TensorFlow or TF, I can say .keras.models, import model. And I say dot models. It has two parameters, inputs and outputs. So inputs has to be supplied with this. You can give any name over here. I usually give I. Today it recommended inputs, so I took inputs. And this is the last one that will be the outputs. I usually prefer giving the name over here as I. and prefer giving the name over here as O. So this is what I usually prefer. It says module TF not found because I think I didn't execute that or what, God knows. Inputs is, where is inputs again? Yeah, inputs is I. All good. So now if I run all, same thing is going to happen. This is the third way of doing it. So input is I, output is O, and it will do the same thing. We can see it very easily, right? Right. And you can see now over here, similar output. Okay. So I showed you three ways of doing it. Fine. Now we can go ahead with any way. That's not a problem because you can add any number of layers. The first thing what I want to do is I know that this is overfitting a little bit. So I am planning to add, okay, first, we will comment out this because these are the perfect ways of doing it. Let us create a new neural network. So I say I is equal to input taken, flattening it, then I'm adding a dense layer of 128 neurons. Let me not write the comments now because this is anyways known to all of us. So let us keep the lines clean. So 128 neuron added. This time, one more I am adding, but this time I am increasing the number of neurons, double of 128. And once again, I am increasing the number of neurons, double of 256. And then I say, let me end it now. So I can say activation. This will remain 10 only because there are 10 outputs and rest everything remains the same. So I will run it. Now running this is going to take more longer time because earlier there were 128 neurons in the second and third layer, but now they are much more. So when I say run all, it will run everything and this is going to take longer time. I'm still using a very state-of-the-art system. I'm using the Mac M3. So I'm expected to get the results faster, but still it's gonna take longer time. This is very important, whatever we are doing right now. You try executing the same code on your system and let me know how much time it takes for you. This is happening way faster. Wow. I've got a fantastic model. Wow. Did you see? Looks like in the loss function, now if I think of taking it ahead, this is more or less likely to go flattened and this is also more or less likely to go flattened. So do you all agree that adding more number of layers in the power of 2, because 128, 256, 512. Do you all agree that adding more number of layers in the power of 2 helped me here? Yes, because the loss function earlier was overfitting, but now it is well contained. Are you all able to agree on this? Yes or no? Yes. Okay. Look at the accuracy. That is also awesome. I can actually say model dot evaluate. That gives me the accuracy. Yes, so you can see I'm having the accuracy as 98% on the test data set and loss as 0.08. Similarly, I can also say explain wide range. So you can see over here on the training dataset, I got 99% accuracy. On the testing dataset, I got 98.12% accuracy. I'm very happy with the result. But will you always get some such satisfactory result? Maybe no also. Maybe no also. So there are some tips and tricks which I want to let you all know. So I say, first I'll let you know from myself and then we will talk about it. So tips and tricks for creating a neural network model. Number one, the number of neurons in each layer should be equal to the number of features in the data set. That is how many number of columns are there. In fact, this is not very important. I would say the number of neurons in the input layer. Yeah, that is fine. That is obvious. The second is the number of neurons in the output layer must be equal to the number of classes, because in MNIST we have 10 digits. So last value was 10. Then number of hidden layers, how many number of neurons you choose and how many hidden layers you choose, this is a hyper parameter that you can tune. Activation function is also what you can tune. Then for the softmax, for the classification, which is multi-class, it should be softmax. And the loss must be this. But you know what? I don't want to talk about this. This is what we'll talk about later. I will talk about the next is always start with a simple neural network with small number of layers. I did the same thing. I started with around 2 layers, right? Small number of layers and small number of neurons. I did the same thing. 128 is what I did. Then I say after that, observe the training and validation, accuracy and loss. And if the model is underfitting, increase the number of layers. If the model is overfitting, add a dropout. What is dropout? We will talk about it. Then the next is the number of neurons in hidden layers should be ideally increased with each layer in the power of 2. That's exactly what I did. These are helpful tips. There are no golden rules around it. This is what I'm telling you from my experience. No one ever says that doing this will always give you the output. There is no guarantee. If there was a guarantee, then someone would have created a predefined function for doing this. But it's not there because it is all hit and trial. Then I say over here, the activation function in the hidden layer should be ReLU over here. If ReLU activation function does not work well, then you try the others. Then the activation function for the output layer should be softmax for multi-class classification problem and sigmoid for binary classification problem. The loss function must be sparse categorical cross entropy. We have to play around with that also. And binary cross entropy for binary classification problem. Optimizer should be Adam. I started with the same thing, right? And it works well in most cases. In case if we, or let's say in case if Adam doesn't work well, you can try RMS prop. Then The number of epochs ideally should be between 10 to 100. Do not increase too much. Batch size also I'll be talking about it. Should be between 32 and 128. I'll talk about it. So now that we have understood how to configure the neural network, I want to talk about the optimizer. So I say, yeah, where will you find all of this? So optimizer is Adam, right? So I'm searching optimizer. I go to Google. I say optimizer followed by TensorFlow. Remember this search, optimizer followed by TensorFlow. And when I click on this, you see this, all the available optimizers. Add a delta, add a factor, add a grad, Adam W, Adam Max, these all keep on updating. Something or else keeps on getting added. But the most popular is Adam, and after Adam, you can try out is RMS prop or SGD. And the same thing you can also get by searching optimizer Keras, because TensorFlow and Keras are one and the same thing as I told you. You see the same thing. So let's look at, I'm planning to use another optimizer, let's say this time the stochastic gradient descent. So what will I come and do over here? Commenting this line out. And I just come and ensure that I'm spelling it correctly. SGD. Rest everything is all sorted. You can see this is how the functions were looking earlier. Let us see whether SGD was able to help us better. I'm just keeping it open separately so that we have the older results for comparison. Now it is training. After training, let us look at the loss function, whether SGD helped me. Now the next thing which I want to do, this is good. I am happy. Everything is fine. But you know what? If you look over here, if I click on class SGD, this also exists as a class. So now if you see over here, this is awesome because SGD says that by default, I was using these all parameters, but my dear boss, you can change this. So it's asking me to do this. So what will I do is I'll copy this. And I come over here. Where was this? Yeah, here it was. So I'm saying I don't want to work with all the parameters. Let's say I'm just working with one or two of it. So let's say the learning rate is 0.01. I can make it a little slower and the momentum I'll make it as 0.1. And I will save it as some object name SGD. And then I guess it heard SGD as Hey Siri. No worries. Made it on silent and let me just see whether it works or error is there. I tried running it and it's working fine. So if you see over here, what I did differently is I said that SGD, don't keep your default learning rate. I want you to play around with the learning rate and see if this gives me little better results. So I am going to get this. So this first one, fourth one. So this first one is useless. I think we can actually get rid of it. How, I don't know. Maybe this one. Yeah, okay, that's good. So it will run the entire notebook again. Ideally, I can only run from model.fit, but I'm not taking the pain of going here and there, just keeping it very simple. So these are the older results. right? So the older results are this. Now the new results. So older results where I see, if I see, I put it in the chat box. I had the training accuracy as 97.77. And here it is 97.57. It reduced. And testing was 96.89. And this is 96.78. It reduced. So if you look at this curves look the same, but the earlier one was a better one. But I am here to just show you the various ways of doing it. Okay. Then other than this, if you also look into loss functions, searching for loss functions TensorFlow, click on this. So many loss functions are there. So whenever you are solving a binary classification problem, you should use binary cross entropy. When you are solving multiple classes problem, categorical cross entropy. I am using a sparse categorical cross entropy because there is a difference. We have something which is called as a sparse matrix versus a dense matrix. So the sparse matrix is the one where most of the values in the matrix are zeros. Imagine these dots to be zeros. And the dense matrix is the one where it's completely filled, right? There are hardly any zero values. So if you look into our MNIST data set, consider any image. Black portion is zero. So there are more. This is more like a sparse matrix because most of the values are zeros. Whites are less. Black is more prominent. So for that reason, I use the loss function as the sparse categorical cross entropy. But there are also multiple loss functions that you can use over here. So here, let's see if I'm using the sparse categorical cross entropy. I clicked on this. Here also you have some parameters that you can play around with. In fact, all the layers that we added, right? So if you remember, we added the input layer. I'm just Googling for input layer, TensorFlow, and everything followed by TensorFlow. And you will see the documentation for adding an input layer. You see over here, input layer. You see the shape, batch size. Now I'd like to talk about the batch size. Now, if you see here, we had 60,000 images in the training data, 60,000. 60,000 divided by, I'm just curious why 1875 came. 1875 came because it divided the data into 30, it divided the data into 1,875 batches. That is, it divided 60,000 images into 1,875 groups, and each group consisted of 32 images. So at a time for training, 32 images were sent. Then next 32, then next 32. In this way, it went on in the batches of 32 till 1875 is reached. But if I want, I can adjust it. So I'm gonna change this. I come over here and we have the batch size, right? This can also be given over here. Batch size, which is by default 32. Let's say I'm making it a 64. Now at a time, it will send more number of images at the same time. Let's see what happens to this number. You see, it has become 938. Why 938? Well, let me try doing the similar thing. 60,000 divided by 938. 64. Right? 63.96. That is, now there are 938 batches, 64. So if you are sending 64 images at once, your RAM should accommodate that. Usually it doesn't, because I'm using an advanced system, it is allowed. But going forward, a time will come where even my system will fail. You need the cloud computing power. Moral of the story is, 32 and 64 are good sizes. Anything more than that, you really need a very powerful PC. And these images are anyways very small, right? 28 cross 28. In real life, images are going to be much bigger than this also. That's one thing. The next thing I want to talk about is, I remember I did discuss about this, where these weights and biases, what we are doing, right? So what is neural network? Neural network is always about doing the forward propagation and backward propagation again and again, every time adjusting the weights and the biases. And a time will come where I say the network is trained. That means it has found out the perfect values of weight and biases. So how are weights and biases initialized? When you're training the network, here, while taking that example, I said that it was 6, 2, and 2. But in real life, how are they initialized? Randomly. But some researchers invented weight initialization techniques also. I like to talk about that also. I say weight initialization TensorFlow. See, everything is so easy to Google. Weight initialization TensorFlow. And I come over here. So Mr. Glorot invented his own technique. One which supports normal distribution, one which supports uniform distribution. Mr. Hay also. Then LeCun also invented his own technique, and so on. So let me go ahead with LeCun normal, randomly taking it. By the way, Glorot normal is the by default one. You'll see it in this documentation only. So I am planning to initialize the weights by LeCun normal. So I think this is the code for it. So copying it. And where to write it? Well, if you look over here, it says you create an object, and when you are initializing a dense layer, inside this dense layer, you can say kernel initializer is equal to this. Okay, kernel initializer. So I can go back here. Inside this dense layer, they say you have a parameter which is called as kernel initializer, and you can write the value of your choice. So if I don't give anything, it will be considering the LeCun normal, but this will give an error. It ran. Ideally, you need to import it. So you will have to say, okay, I have given the complete path. Since I have given the complete path and I have imported TensorFlow as TF, if you recall the very first row of this, import TensorFlow as TF. That is done now as TF. So after that, using TF, I can access the remaining path. So this is one way of doing it. If you don't want to do it, another way is I can say, look over here. This is again interesting. From TensorFlow.Keras.initializer, import LeCun normal. So now I have imported LeCun normal, and because it is imported, now I need not write this complete path, shortcut. Similarly, here also, you have written this, right? So I say, let's say I don't want to write this complete path of input. So I can say from TensorFlow.Keras.models, import the input layer, import the model, and we also import the from tf.keras.models, sorry, from tf.keras.layers. I'm getting all of this. So now, because input, flatten, and dense are taken right up to the complete path, so I can now actually not write this. I can reduce this code. So see, these are different ways of doing it. These are different ways of doing it. Yeah, this looks good. Here also model is also taken. No, I didn't do that. I'll take that also from TensorFlow dot Keras dot models, import model. So I need not write this complete path. And this also runs successfully. It's just showing you, all the possible ways of executing it, right? So now Likun is there. In the same way, if you want to add Likun everywhere, then one can do that. Let's say here also, I want it to have the kernel initializer as Likun. And what is the another way of initializing? So Likun is there, and let's say we also have random normal. So that's also is very simple. So this is the way you import the random normal. So I say from Keras, TensorFlow.Keras or initializer, import random normal. Let me do that. I'll write it here only, why to comma random normal. And here I say, copying this. Let's say here, I say kernel initializer is equal to random normal. So I say that, hey, I want the overall mean to be 0 and standard deviation to be 0.05. If you want, you can increase the standard deviation a little bit. So let's say instead of 0.05, you are keeping it as 0.06. Not advisable, but you can play around with it. That is what I'm trying to say. So the first layer weight are initialized using the Likun normal technique. The second weights are initialized using the same. The third are initialized using this. So these guys propose that if you use our technique, your results will come faster, or not faster, your results will come relatively quicker. So, I mean, these all propose. So rather than initializing randomly by something, they say that use our technique. It's not advisable that you use any technique at any layer. Try to keep it the same. Here I'm just showing you all the variations of it. So with this, I am executing the complete project now. Let's see how it works in the process of training. See, okay. This is also okay. 96.4, it actually dropped at 95.27. And if I look at the count of the misclassifications, well, the length of misclassification is 430. It was somewhere in the range of 200, 226. It increased. So basically, initializing it randomly by any weight is not a good idea, but I just wanted to show you this. One last thing which I want to show you, and then I'll take your any kind of odd questions. So the last thing which I want to show you is something that we all must be proud of. Look at this research paper. Your large language models use this very popularly. Tell me one thing. Even if Newton was not there, would you still have been in a position to say that if I'm throwing something up in the sky, it is going to come down again? If I throw something up, it is going to come down again. Even if Newton did not propose the gravitational force, at least this basic logic is what you would have known. कुछ भी ऊपर फेंके तो नीचे तो आएगा. Whatever you throw up, it will come down. Newton was a great person who identified this, documented this, and became great. Because till that point of time, no one documented it. So it was a very, very simple concept. It was a very, very simple concept. So what I want to tell you is this dropout is also a very simple concept. Very, very simple concept. What is that? Let's try to understand. Now, the reason I said you should be proud about it is because it is invented by an Indian. In fact, very soon when we are going to start with the transformer architecture, there also you will see the attention mechanism paper is by Mr. Vaswani, Indian. We all are doing our best in the world, but not for our country, going to US and working for them and doing the best over there. That's the harsh reality. And I don't blame the people. It's also, you should also blame the government for the same, right? The people find good opportunities and just play around with it. Given an opportunity, you may also consider shifting abroad. Now, what is this paper about? Very small concept. It says, imagine this to be a neural network that you are working on. Right? So this is the neural network on which you are working on, where it moves from this layer to this layer, this layer to this layer, and this to output. Just like I was taking the example of the LED lights in my room, where I said that I have 6 LED lights, but I turn on only 2, and that's more than sufficient. You can even see me very clearly. So dropout says that, it says that, hey, you think of, because your network is having too many lines, which means too many connections, which means too much complexity, which means too much learning. And that too much is going to be bombarding enough for the model to learn. Imagine you have an exam after 3 days. You are studying today full day, 24 hours. Tomorrow also you are studying full day, 24 hours. A day before exam also you studied almost full day and just slept for 2 hours. So you hardly slept anything, but you are very nicely prepared and you go to the exam for appearing for the paper and you are not able to control your sleep and you go to sleep there. What is the use of studying then? Moral of the story is overstudying can also be detrimental. With the similar analogy, it says that if the network is too much complicated, this is still 5 neurons, but when there are 128, 256, 1024 neurons, it says that when there are 5 neurons, you can think of adding a dropout. So this is dropout layer 1, this is dropout layer 2, and this is dropout layer 3. So here the dropout is 40%. Here the dropout is 60%. Here again the dropout is 40%. How do I say? So basically 5 neurons are there. Out of five, basically imagine this to be 5 tube lights to be there. Out of that, only 2 tube lights, out of this, only 3 tube lights are allowed and 2 tube lights are not allowed. So basically 3 upon 5 into 100, 300 upon 5, 60% is allowed, right? 3 neurons are allowed to communicate ahead, 2 are not allowed. So that means 60% of the neurons are allowed to communicate. 2 are not allowed. So this is as good as saying 2 upon 5 into 100, which comes out to be 40%. That's exactly what I said. So out of the 100% output, which is going from this layer to this layer, please block 40% of it. Please block 40% of it. This is how you give it. This is called as the dropout layer. Similarly, over here, out of this 5 neurons, please drop 60% of it. Out of these 5 neurons, please drop 40% of it. Now, there are no ground rules on what value I'm considering over here. This is just, I'm randomly considering the research paper. But you know what? These 2 are off, these 3 are off, these 2 are off. Neural network will do the forward propagation, find out the total loss, come back and adjust all the weights only which are connected. The ones which are off, they are not connected. So there is no question of adjusting those weights. After an epoch is over, one epoch is over, then you know what will happen? It will again go for the second epoch, but this time it won't deactivate the same two. It will randomly deactivate any of these two. Could be the same two again, could be this and this, could be this and this, could be anything. So out of this 5, randomly keep 40% deactivated. So at every epoch, at the start of every epoch, the which neurons are to be deactivated, that will be randomly decided at every layer. So basically what is happening is, here we are not reducing the configuration of neural network, but I'm not allowing every neuron to learn a lot. I'm asking some of the neurons that, okay, boss, you need sleep. You cannot handle that stress. So everyone is given a break. Just like in a cricket team, if there are 14 players, 11 of them or 12 of them are on a field and we have extras. In the same way here also, we are having this concept of dropout. And the way to implement that is really very, very simple. So how do I add a dropout? Well, if you want to add a dropout, that's pretty simple. Wherever you want to add, you can add it. So I say x is equal to dropout. So I didn't import the dropout. I have to get that. So dropout. So dropout 20%. So this x, sorry, this x is passed here. Then 20% dropout. So out of 128 neurons, 20% of the neurons are deactivated, and whatever is output sent ahead. Then this is sent here, sent to 256 neurons. These are there. But after this, again, let's say I'm adding a dropout. So usually what is the value of dropout that you will add? 10, 20, worst case for 50, worst case 50. 10, 20, 30 are very common. So here I'm considering just 20% dropout. And it's not mandatory that you add it after every layer. So again, this is a hit and run. No, so trial and error. So I'm executing it this time with a dropout. Let me see if I'm getting something better. The earlier results which I got, I'm just putting it in the chat box. These were not the best one, but just comparing if the dropout is helping. And you see, 96.19 earlier was 96.4. Here 95.85. Earlier was 95.87. So essentially, the one before dropout was better. I am not saying dropout is not useful. Dropout is really very helpful, but in this case, it is not. In this case, it is not, but overall, dropout is a very helpful concept. And what is it? Just turning off some neurons. And this has become so popular. And this came also quite late, around in 2015 it came. If we look at this, this got published somewhere in the year 2014. See? So now, first of all, just answer my question. Are all the configurations related to the deep learning for any project, how we do it, are they clear to all of you? How to create a neural network, how to choose optimizer, how to play with the values, how to import it, how to shorten the code, etc., etc., etc. things. This is one of the very, very important things which will be required going further. Right. What is it, the tip cell? Common values for dropout are this. Right? Okay, I updated that. Yes. Now, okay. So this is done. Now, the next thing which I want to show you is, I want to start with one more problem statement. And this time, I'm looking for convolutional neural network, but this is the fashion MNIST data set. Okay, let me talk about the fashion MNIST data set. So what is basically the fashion MNIST data set? Well, fashion MNIST data set is, or rather was, designed to be a drop-in replacement for the classic MNIST data set. So MNIST is nowadays is to be considered too easy. It is considered to be a solved problem. So fashion MNIST is again 28 cross 28 grayscale images only, but there are 10 categories of clothing. Here as well, you have 60,000 images and 10,000 images in train and test. But here the labels are clothings. So the labels are as below, right? So you have, if it's 0, it is t-shirt, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag, and ankle boot. So all of these images are 28 cross 28 NumPy arrays with the pixel values ranging between 0 to 255, and the labels are ranging between this. So let me show you. Fashion MNIST data set. Yes. You can consider this. This is how the fashion MNIST data set looks like. So you can see we have t-shirt top in all of these classes. You can see it over here. I'll share this link in the chat as well for you. Yeah, this is what it is. So now let us get started with this. So the first thing, the process of loading the data is very similar. So I say I want to load the fashion MNIST data. Oh, it's again very hot. Just a moment. Yeah. So here I say fashion MNIST data is loaded just like MNIST, and then I have to split the data. So I have the X train, X test, not Y train, Y train, X train, X test. Oh, sorry, X train, Y train, no? X test, Y test, loaded. Once it is loaded, quickly I am planning to now normalize the data. So I'll divide each of this by 255, and I can just print the shape of the training and testing data. As you can see, 60,000 images, just like MNIST, but the images are different. So to show you that, I am just going to quickly say that let's plot some images from the data set. Input Matplotlib some images randomly from the data set. So next, import random. I'm going to create a 3x3 grid, plt.figure, and I'm using the range function. So 3x3 grid, and it will be randomly picking up an integer between 0 to 59,599. And I'm saying plt.show. And I also want to print the images are as follows. So no, not here. After this plt.imshow, I also want to print what is that image. So train also of the same. So you can see these are the images. The first image is of class 0, the second is of class 5, the third is also of class 5, and so on. So I think let me plot only one image at a time. Let's plot X train 0 and Y train 0. So importing Matplotlib plt.figure X train 0, and here don't forget CMAP will be equal to gray and color bar is not required. Then I say plt.show and I want to print Y train 0. So this is the image. I'll make it little small. So this is the image belonging to class 9. What is class 9? Well, have a look over here. Class 9 is ankle boots. So this is ankle boots. Similarly, randomly I'm looking at the 110th image. And this is of class 8. What is this? Bag. So in this way, we have this data set. Now, first and foremost thing, this time we are not going to build just a neural network. No, we are not going to build just a neural network. I'm going to build an advanced neural network. In the sense, what used to happen earlier, if you recollect, we had this 3x3 image, and this was flattened. In this way, all the images were flattened. So you had one more 3x3 image that was flattened. Similarly, you had n number of images, all of them were flattened, and that's how you got this data set after flattening so many things. And then similarly, you had the Y train as well. And then you understood the things. So because of that, because your image was 28 cross 28, you had pixels going from pixel 1 to 784. And because of that, that pixel 1 to pixel 784 went into the neural network. And this is too high. And that's still okay. High is not the problem. The problem is you're trying to make a machine memorize the relationship between the pixel versus the label. Pixel versus the label. Deep learning is known for its feature extraction, or it is known for its automatic feature extraction. But I don't see that over here. I'll tell you what I exactly mean by that. So now, I'm not getting into the architecture. I'm just focusing on the important things. Let's consider this example. So now if you look into this lady, right? On every image, you extract the features. Like this is one feature, which is her right eye. Where is this feature found out? This feature is found out here. As you can see in this image, it is found out here. This is her nose. Where is this found out? Here. So in this way, from every image, you are going to look at features. And features is not necessarily the features like only eyes or nose. It can even be a feature like a face. It can even be a feature like a neck. It can even be a feature like a small pimple on her face, or could be a mole on her face, or it could be, let's say, closely looking and finding the wrinkles texture on her face, or the skin tone that she has, let's say oily. It could also be the brightness on the face. It could also be the freshness on her face and any. So there can be millions of features that you can extract from this. This is just two of them which have been shown. So what CNN does is it takes an image. It takes an image and let's say this is the image, right? So let's say you consider this as the image, right? Now, if you look at this image very, very closely, very, very closely, I mean, you go very near to this photograph, so close that you are now able to see only and only this much portion of the image because your eyes have gone so near to it. This is as good as imagine you are standing just below the hoarding. You don't understand what is written in the hoarding. You just see the things as color patches. So when you're so near to anyone's face or anything, what you extract are the features like this. And sorry, when you go little bit back, then probably you extract features like this. And when you go further back, you start looking at the high level features. So you are going literally from low level features to little mid level features to little high level features. And this is not about extracting just one. Let's say you have extracted 200 low level features. You have extracted 1,000 high level features. You have extracted 5,000 up very high level features. And this can go on, right? It's not necessary that this goes in just 3 layers. So this is exactly what my convolutional neural network does. It uses convolution and pool to get a set of features. Again, it uses convolution and pool to get another set of features. Again, it uses convolution and pool to get another set of features, and it can keep on doing it by extracting low level features to high level features. Very, very high level understanding of this. So I'll tell you what is the idea. Now, what is happening is your eyes are called as filter. So when you are very close to this image, imagine this to be a big hoarding and you are very close to it. So your eyes are able to see only this much portion of the image, right? So for you to extract features, your eyes have to move left to right, top to bottom till they reach here. And then they extract one feature. So this is what you are extracting, right? Then I call this man. So he also sees it left to right. He extracts one feature. Then I call some other participant. He also sees left to right. He extracts one feature. In this way, let's say I extract a total of 512 features. Next, done. After that, what am I going to do is this image, I'm going to shrink it. That is done by pooling. So I am downsampling the image. It's 32 cross 32. Now I made it 16 cross 16. Now, because the image got smaller, but your eyes are still the same, these 512 people, they are still the same. So now I can either call the same 512 or I can call any other people, but they will be able to see the same content. But here it was relatively less, but because the image has become small, the effective area covered by their eyes are large. So let's say you call around 1024 people and you extract 1024 features. Then you again make it small. Again, you call 2056 different people and get features. But this time you see a person at a time is able to see 1/4 of the image at the same time. And then, let's say 5056 features, or whatever it is. Now you are able to see almost the entire image. This exactly happens with hoarding. When you're just below the hoarding, you don't see anything. Go little back, you see little better. Go little back, you further see better. Go further back, you are able to see the entire hoarding. So every level, you are extracting features. And who is doing that? Convolutional neural network is doing that. That's a very high level overview of the convolutional neural network architecture. Explaining this theory will take me 3 hours, but we are not going to get into that, right? We are quickly now going to navigate into our GenAI stuff. So the problem is, if I look into the shape of X-train, the shape of X-train is 60,000 images, each of 20,000 cross 20,000. So each of 28 cross 28. Then, once you have all of these features, the next thing, convolution says, this shape is not acceptable to me. I am mainly designed for working with color images, but I can help you out. Your black and white images, I can help you out. You modify the shape to 4-dimension. So I am going to do that. So I say, convolution, expect the shape to be like this. So I say, the first is the one for grayscale and color is equal to 3 for RGB. So I say xtrain is xtrain dot reshape, or that can be one thing, or I can directly use the NumPy's expand dim function. Similarly on xtest also, and I'll show you how it looks like. Where it went wrong? Where is this mistake? XNP. Where is XNP written? Here. Import NumPy. See, basically, it was 60,000 images, each of size 28 cross 28. Now also there are 60,000 images and they are still of size 28 cross 28 and 2021. But the images still look the same. See, this was the ankle boot. Let me show you. That's not changed. I just added a superfluous dimension. I'm also going to find out the number of classes. So same like earlier. So there are 10 classes. We all know what are the classes as well. Now I'm going to get ahead into the building of the network. So I say, I'm looking at the shape of any image. Every image is of shape 28 cross 28 cross 1. So now I am planning to build the model using the functional API. I is equal to tf.keras.layers.input and I am giving the shape. Now, after this, I'm going to create a convolution layer, which is going to extract 32 features. How? Like this. So here, 32 is the filter size. That is, I can say, I have 32 filters of size 3 cross 3 cross 1. 32 filters of size this. So, we extract 32 features from the image using filter, which I also said these are nothing but our eyes of size 3 cross 3. So I passed and X as output. Now I say let's extract few more. Acha, strides. Strides is, see, I showed you in the PPT as well that you move left to right over the image. So you looked at this block, then this block. Like for example, you had this block. So you looked at this, then you looked at this, then you looked at this, then you looked at this. Or another approach could be you may say that, hey, Darshan, I look at this, then I look at this, then I look at this, then I look at this. So basically, how many steps at a time you want to move ahead? That is strides. So I say that move the filter 2 pixels at the time. Strides equal to 2 is a very common value. Then I'm extracting 64 features. Then I am extracting 128 features. After that, I'll flatten this. After extracting all the features, I flatten it. So now what am I doing initially is I'm extracting the features. And these features will be given to the neural network. So first, let's say I'm adding a dropout of 20%. And that is where I start building my normal neural network like we did earlier, adding a dense layer of 512 neuron, maybe adding one more dropout, and finally the activation of softmax because it is a multi-class classification problem. And I am creating this. So essentially, if you note, first is where you take the input. Then here you have this entire thing of convolution. Then you flatten it, and this is our regular artificial neural network. So I added these things which are responsible for feature extraction. So this is the CNN layers which are mainly responsible for extracting features from the image. This is the flattened layer which is responsible for converting 3D to 1D. And this is the artificial neural network layers which are responsible for classifying the image. And then we run it. Then after this, once we have this, I can quickly ask the model to compile. So I say model.compile optimizer. Again, I like Adam, so I went ahead with that. Loss, sparse, categorical, cross entropy, and the metric is accuracy. Then I say, let me train the model. So I say R is equal to model.fit, extend, y train, validation data. Same thing, you should be more comfortable now. Started 1875, 32 is the batch size, 15 epochs is what I started. It's taking time because I have given convolution as well, right? So that is extracting the features also. See the accuracy, initial accuracy is not that great as MNIST because this is a relatively difficult problem. By the time this is happening, let us plot the loss per iteration. Importing Matplotlib, history, loss, plt.legend, and I can say plt.show. Then I will also plot the accuracy per iteration, r.history, same code, absolutely no change. So accuracy is also being plotted. And then after that, we will be taking the same code that we have been taking earlier. And let us look at the thing as well. loss function. Oops, the loss function looks a little bit disturbing to us because it looks like it is likely to overfit. So to handle this, I am once again going and checking out the confusion matrix. So for confusion matrix, I say, let me go and quickly get this code. Same code, plot confusion matrix. If you see carefully, what am I saying? I'm asking the model to predict. Same code, a same code. So it is actually the same code. You can't say that, sir, go slow. This is the same code. Everything that we did is same. The case study change, images change, rest everything is same. Model predicting on this, and then I'm asking it to plot the confusion matrix. And yes, if you see now, if I say find out the highest value that you see on the non-diagonal, what is it? What is the highest value on the non-diagonal over here? What is the highest value on the non-diagonal? 110? 110. So 6 got predicted as 0. What is 6? What is 6? What is 6? What is 6? Well, oh, shirt and t-shirt. Oh, there is a big confusion between t-shirt and shirt. This is what we understand. Okay. Next highest value, 84, 84. That's again between 0 and 6. So that was 6 getting predicted as 0. This is 0 getting predicted as 6. Next, 76. 80. 80 is there. Where is it? 80. 4 and 2. So a code getting predicted as a pullover. Oh, okay. So as we always do, I will once again try to find out these mapping. So I will do one thing before I proceed. I want to do the label mapping. So I say I have the following labels. T-shirt is there, trouser is there, pullover is there, dress is there, coat is there, sandal is there, shirt is there, sneaker, bag, ankle boot. I can actually print the labels. So these all are the labels saved into the list. So now I want to show some misclassified example. So I say misclassified samples are the ones where the p-test is not equal to y-test. Same like we did earlier. Same code, If anyone says now that you are going fast in the feedback, I'm gonna come and scold you. Same code, same code. This was also the same code. You cannot say that this is fast. This is the same code. Randomly selecting one of this. In fact, for that, I would like to print how many misclassifications are there. See, 996. Earlier, the number was somewhere between 200, 221. Now it is 1000, which means that this is a little difficult problem. Randomly choosing an index, and I'm asking it to plot, and I'm giving it a proper title. So look at this. That's really bad. So this is the shirt predicted as a code. So I'm printing the true label and I'm printing the predicted label. So true label and predicted label. True label is labels of y test of I, and this is labels of p test of I. Let us try to execute the same code. See over here. This is a dress predicted as a trouser by the model. If I try to do the same thing over here, see, this is a shirt predicted as a pullover. This is a coat predicted as a pullover. So these are the drawbacks with this problem. But we still got how much accuracy? Well, one can easily print model dot evaluate explain y test and x test y test. Look at the accuracy. I'm able to get 97 and 90. This is overfitting. If I go for a regular network without using CNN, I'll not even get this accuracy. So if you are going for a regular network without going for CNN, you will not even get this accuracy. That is exactly what your homework is. Now, this network is a little bit different. And how is it different? Let's try to quickly analyze these things now. Have a look at the diagram which you see on the left side of the screen and the right side of the screen. Today, we are actually getting started with the text processing, right? So see and listen and understand some important things. Listen to this. This story is very important for all of you. Today, we are learning RNN, LSTM, GRU. They are very much famous for processing text data. Then advancement to this is going to come later on, which is called as attention mechanism. Then advancement to this is going to come, which is called as transformer architecture. So this is the first step into entering into the text processing world. In fact, here also we did see RNN LSTM, then attention mechanism, then transformer architecture, and then you see text generation using attention mechanism, then GAN and VAE. Yes. So here you will understand the architecture of ChatGPT. And once that is over, then you get into GAN, which is for image generation, variational autoencoder, which is for image generation as well as anomaly detection. And then you get into the large language models. So you have built a perfect story now. And we are now eligible to understand RNN. Earlier, you were not. In fact, when I start with this topic, you will realize what is the practical significance of why I covered everything in the past. Each and everything will be realized by you. Most of you already realized it, but there are one or two of you, I got it as a separate request. So, these all things are really very important. So, let's get ahead. So here, I'm not going to share this PPT and all with you because I'm not going to go through the entire PPT, right? If you wish to, you can take some screenshots, but what if I say that whatever you see on the left-hand side is same as what you see on the right-hand side? Yes. This is called as a recurrent neural network. This is the input layer. This is the output layer. I have just drawn the figure which was horizontal. I made it vertical. And this is the hidden layer. But you know what is the difference? This is a simple perceptron model. One input, one output. And what happens over here is activation function applied over Wx plus B. Same one now. So now what happens over here is, see the difference. Ideally, this is same as this because you see there is a loop over here. Yes, there is a loop over here. So consider this, that's my input, that's my output, and that's my hidden layer. So the input is x1, x2, x3, x4, and x5. What happens and how it happens? See, initially x1 goes inside. Consider this, x1 goes inside. So obviously there will be a weight. Now input layer, I'm going to denote by x. Hidden layer I'm going to denote by H, and output layer I'm going to denote by Y. So this weight is WXH, just giving conventions. So X1, WXH, and there will be bias also, which will be this. So here also the same. So W into X plus B happens. That result is computed over here. And let's assume that the output that you get is O1. Now, friends, this O1 goes back. Nothing goes out. This output is O1. This O1 is here. O1 goes back. And here also there is a weight. Because it is going from hidden layer back to the hidden layer, I call this weight as WHH. And the bias over here, I call it as BHH. So what happens now is the next input X2 comes. And what happens? Listen to this. WXH into X2 plus BXH. WXH into X2 plus BXH. That's one thing which gets calculated. Plus this also is coming now, O1. So W into X plus B. So this time it is WHH into O1 plus BHH. This is where on which you will apply the activation function. So this plus this, right? This plus this, you apply an activation function, and this time you get the output as O2. So obviously here you have XH, no output comes out this time, but here you have WHH, and this is X2. So this is again XH, which gives us O2, and nothing comes over here. And then now this O2 goes back. So, and by the time this O2 goes back, X3 comes. So what will happen? WXH into X3 plus BXH plus WHH into O2 plus BHH. Activation function applied over this again, right? So what will happen? This will give the output as O3. That O3 is this. And we don't have this. So again, the same thing happens. This gives the output as O4. Nothing happens over here. Then X5 comes, right? This will give the output as O5. This O5 will be now getting multiplied by what? WHY, not HH. Because it is going from hidden layer to the output layer. For the first time, I'm actually fetching out the output, and that is my Y dash predicted. So this is the recurrent neural network. So ideally, it is this only. So if you have 5 words, it will get unrolled 5 times. If you have a sentence of 10 words, it will get unrolled 10 times. Like, have a look at this figure. If I ask a sentence like, what time is it? So that network will unwind 5 times. If the sentence is longer, it will unwind more number of times. Now, over here, because they are able to take the same information again back, we say RNNs, they have loops. See, and think about it. Humans don't start thinking from scratch every second. Like for example, if you are reading an article in the newspaper, so every word that you understand is based on your understanding of the previous word. If you're reading an English paragraph, let's say an article, which is this much long, will you understand the article if you start randomly reading from somewhere in the middle, or if I shuffle the sentences and give it? Or will you understand the movie if you directly go into watching the movie from after the intermission? So you go enter the theater, and after the intermission, you try to understand the movie. Will you understand it? And I'll give you a practical real life example. I am the one. I went to watch the movie Jawan, entered the wrong, uh, what do you call, screen. There were three shows of Jawan which was going on. The break times also coincided. I had to enter a show which was about to start. I entered the show which started after an intermission, and I was like, I heard the movies of 3 hours and how it got over in just 1.5 hours. And I literally paid through the nose for that movie. And this is what happened with me because I went into the wrong screen. So you don't understand anything. That is the drawback. What I want to say is, if you look at the traditional neural network, I had an input layer, which was going to hidden layer, which was going to another hidden layer, which was going to another hidden layer, which was going to another hidden layer, which was going to the output layer. And they were always moving left to right. But here for the first time, you see that there is a loop. So the advantage of this loop is that you are able to save the information. That is exactly what is the idea behind the recurrent neural network. Now, if you look at convolutional neural network, they will not perform well when the input data is interdependent in sequential form. CNNs assume that there is no correlation between the previous input and the next input. That's why we used it for image classification. So the first image, if it is of a t-shirt in CNN and the second is of a bag, it does not matter. But in text data, it matters. In text data, it really matters a lot. And that is what is the practical significance of the convolutional neural network for this. So now I say RNNs. Save as in cache. Where is the cache? These neurons are saving the information now. What I explained you just some time back, Harshit. This O1 is fed again back into the network. That is the memory. Yes. That is the memory. Now, again, as I told you, I'm not getting into too much in depth of it, right? So how much ever is required for you to understand, I am only talking about that. Then, so the center one is a hidden layer only. It is just that it is looping through the things. One can understand it. So here, it's not backpropagation. It is same thing going again and again. So inputs are also going and the recurrent outputs are also going. Or you can also refer this figure. So this is feed forward neural network. Everything is going from left to right. And here, the same information is going back to the same neuron. So they are able to remember the things. Right? You can see over here. So there is a loop over here. Essentially, there is a loop. And everyone, right? And everyone, of course. Yes. So now I also want to talk about the drawback of RNN. Which there are various types of RNN, but it's not used anymore. So I say the drawback of RNN is they can remember. Definitely they can remember, but only previous 7 to 10 words. For example, I'll give you an example. If you ask a recurrent neural network, a recurrent neural networks that the color of the sky is dash. Now, This is what you're asking the RNN. So RNN would be very effective in answering this question. This is because the problem has nothing to do with the context. RNNs do not remember what was said before or what was the meaning of it. They just know that, okay, the color of the sky is blue. Or if I say that I live in Gujarat and I can answer me this question. I live in Gujarat and I can speak dash. What do you think should come over here? Gujarati. Yes. RNNs can do this well. RNNs can do this well. But if I consider an example that I spent 20 long years working for the underprivileged kids in Spain, I then moved to Africa, dot, 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 and I say I can speak fluent dash. Now, if you go to RNN and say that, hey, can you predict it? Popat. They can't do it. They can't do it. They can only remember previous 7 to 10 words. They can only remember previous 7 to 10 words. So, this is the problem. Yes. Therefore, they came up with the architecture of long short-term memory. Now, this is again something which is very interesting if you talk about the long short-term memory architecture. Now, what is the special thing over here? See, so LSTM, long short-term memory. Now, this architecture has total 4 gates. We are not concerned with the working of this, but I would like to tell you that they remember around 70 to 75 previous words. Similar to this, we have the gated recurrent unit. So this LSTM came in the year 1997. This gated recurrent unit somewhat came in the year 2014. This has total of 3 gates. Like here, this is first gate. This is the second gate. This is the third one. And this is the fourth one. 4 gates are there. But GRU, this is LSTM market. GRU has these gates and they are 70 to 80 previous words. So I'm not saying that LSTM is bad than GRU or GRU is bad than LSTM. For almost more than 15 years, people were using LSTM only to remember the past. Then someone invented GRU. Yes, because GRU doesn't have 4 gates, it has only 3 gates. Processing power required is little lesser, not significantly. Performance-wise, both of them are the same. Sometimes LSTM gives better performance depending on the data. Sometimes GRU gives better performance. So till today, if you ask me which is better, well, no one knows. So people actually try out both and choose among the two. People try out both and choose among the two. So this is how the LSTM architecture looks like. We will focus on using the architecture. We will focus on using the architecture. After all, that is what is more important for us, right? These are the gates. Gates are the ones through which processing is happening, right? So here, some processing happens just like recurrent neural networks. We have the LSTM. Processing happens at each and every gate. So that processing can be of the older information, how much information to remember, of the older information, what information to forget, of the older information, what new information to be added to remember. All these things are taken care of by the gates. And that is what happens in very short and simple words, so that we are not getting into the technicalities part of it. Because when you come to using it, you just have a single class of LSTM and your job is done. That is why we'll be focusing on using it rather than unnecessary getting into too much of complexities. Today, we'll be doing only one case study. So depends on the time. And the next class, so there are two case studies on LSTM that we are going to do. The first one is going to be the classification problem. And the next one is going to be, first one will be classification, and the next one would be the text generation. The next one would be the text generation, generating the text. TensorFlow. So the thing, what am I searching for? TensorFlow. You see over here, you get the documentation link. I'll open it. In the same way, I will say GRU TensorFlow. I'll open that link as well. See over here, LSTM is just a function with so many parameters. As simple as that. It's written long short-term memory invented by the Hochreiter in 1997. And GRU invented by Cho et al. In 2014. And see, now your order is going to be more or less the same. Here, you will be having LSTM or GRU. Yes, you will be having LSTM or GRU over here. So the things are not going to change a lot. This is what I want you all to be aware of. So the things will not change a lot. This is the best part of it. Right? Here, flattening is required or not, that's a different part of the story. But overall, this is how the order is going to be. Now, let's get started with the case study. So this is a SMS going until Jurong Point. Crazy. Available only in the buggies and great love of a Cine got their amour what. It's a ham message. Ham means something which is not a spam. Okay, Lar, joking Wi-Fi, you wife, you only. It's a ham message. Now see, this is a spam message. Which one? Free entry tickets in 2 weekly comp, 2 FIFA Cup, etc., etc., etc. This is a spam message. So in this way, this is our task, classifying anything as a spam or a ham. Let's get started. Now I get started to let's start by importing the required libraries. So first is I am importing NumPy. I'm importing Pandas. I'll just get rid of this unnecessary thing, else it will be confusing. Then I'm importing Matplotlib. I'll also import Cbon. Then after that, I'm gonna use machine learning as well over here. So I will say train test split is required. From sklearn.model selection, import train test plate. I'll also be converting the categorical data to numerical. So just like one hot encoding, then I say from Keras import sequential because I'll be using the sequential layer. So I'm not importing TensorFlow. I'm directly saying that, okay, do this. Then I say, I will also import LSTM dense embedding. Yeah, that is again required. I'll be tokenizing the thing. So I require the tokenizer. I'll be padding. So I'll be requiring pad sequences. When we use it, you will understand everything. Then I will also say from Keras import the two categorical, but I think this is deprecated. So I say from Keras dot callbacks import early stopping. That's one thing. And then I say from Keras dot models import model. From Keras dot preprocessing dot text import tokenizer. Now you see I'm getting an error and I really don't know what is the error. I mean, this was working fine, but now it is not working fine. What will I do? Control C. I can go to ChatGPT, but I want to show you without ChatGPT as well what or how I approach the problem. So I pasted it and it gave me the TensorFlow link. I'll try to open it. Maybe documentation has changed a little bit. From Keras dot preprocessing dot text import tokenizer. So it says from Keras dot preprocessing dot text. So it says that, okay, this looks good, but this is still not working. So I think I need to also get TensorFlow, import TensorFlow, and then this is TF dot. Why TF dot? Because they said the same thing, right? TF dot. So, and oh, this is also saying it's deprecated. Oh my God. So I think that will also not work. Let's see. It says no module name TF. So let me say TensorFlow dot, and it worked. So this is not required. But if it is not working, like here, I also say that I also get this suggestion. Keras is not appearing in the import or no module name Keras dot this. So I see over here some suggestions. You have to use the older version, or I'm trying to do that and then from Keras dot layer use this. If you want to use Keras import tokenizer, then you can downgrade to Keras 2. I faced the same issue. Later on, it was integrated with TensorFlow. Okay, no problem. So I did all the imports. I was able to solve it. Now I have to read this file. So I say EF is equal to pd dot read CSV, and the name of the file is spam.csv, and encoding is equal to Latin 1. So the funda of encoding equal to Latin 1 is to handle the error, Unicode decode error. So basically, what happens over here is by default, it is UTF-8, but there are some files inside this which UTF-8 cannot handle it. Therefore, after Googling, I figured out that encoding has to be Latin 1. And that is what is being written down over here. So then I say df.head. So this is the data. There are unnecessary columns over here which are just not required. So I say, let me drop the columns that are not required. Unnamed 2, unnamed 3, unnamed 4. And I will give it proper names if I wish to, or you can keep it as it is as well. So I'm renaming the column V1 as label, V2 as text. All awesome. In fact, I say pd dot set option. I want to display the max column width, and still not showing me. Yes. Max column width 100 and pd dot set display dot max rows also 100. Fine. So this is how the messages are. I cannot see the complete thing. After this, yeah, I'll just try to see. Now I'm saying that df dot label dot value counts. So we can see that we have 4,800 spam messages, sorry, genuine messages and 744 spam messages. Or I can also say, let's visualize the count of spam and ham. So I'm saying SNS dot count plot of the label palette I'm using as Inferno and giving it just a proper to understand. So you can see the spam versus the ham count. Okay, so imbalanced. I can also say normal is equal to the percentage. I also see 80% genuine message and 13% spam messages. Now it is the time for me to create the input and output vector precisely. Here, I know that this is my independent variable X and this is my dependent variable Y. So I say that my X is df dot text and I can show you this. So X and Y separated. Let me look at head of X. That's correct. And let me look at the head of Y. So Y is, capital Y. Okay. So, just like every other machine learning problem, I did that. Now the machine comes to us and complains. What is this, Darshan? I don't understand this English. What is this, Darshan? I don't understand this English also. In this scenario, you need to actually think about it. What can be done in this scenario to handle this issue? So, what can be the best course of action? So basically, converting to numbers. So now let us take this task. I'm taking this converting to number because this is simple. So how can I convert it to numbers? One way is if I am applying a technique like one hot encoding, it will create two columns, right? Let's say between spam and ham will be assigned a 0. Spam would be assigned 1. So first is ham. So let's say, so this is for, what is the name of the column? Label. Label underscore ham would be one column. Label underscore spam would be another column. So if it is a ham, so this is not required. So if it is a ham, this will be 1 0. If it's a ham, it would be 1 0. Spam would be 0 1. Ham would be 1 0 and ham would be 1 0. This is exactly how your one hot encoding that we studied during logistic regression on the Titanic data set works. Am I correct? Now here, in this case, in the same way here also, this is my target variable, one single column. If I apply one hot encoding, then it becomes two columns. So machine learning model will say that I can predict only one value. So this is not advisable. Going for one hot encoding is not an advisable technique over here. Are you all convinced why? What will we do? I'll be going for a technique which is called as label encoding. What it does, there are two values, ham and spam. It will assign ham as 0, spam as 1. So this column would be transformed. Ham is 0, 0, 0. Spam is 1, ham is 0. That's it. This column transformed to this column. Very easy. Understood what is it going to do? What will be made as what? Clear to everyone? What is label encoding going to do? Every value will be given a number and that is what will be assigned. Simple. That's nice. So I say why. So we can use label encoder to convert the labels into this. So what is label encoder? Let's look at an example. So this is what will happen. This is just for your quick understanding. So now the first thing is let's import the label encoder from Scikit-Learn. So I say from Scikit-Learn.preprocessing import label encoder. I have already imported that at the start, but I want all the codes to be at one. Say over here that once it is done, just like every machine learning modeling technique, I am now going to create an object of the label encoder. You can give any name to it. I give the name Ellie. Then I am going to fit and transform over it. Fit means study and transform means apply the study. That is, convert the labels into integers. So I say y is equal to Ellie dot fit transform. And then you can actually see y. So this will be printing it in this way. If you want to see what all are the unique classes, so I can also use the le.classes underscore and this will give the labels of the classes. So it says that, hey, 0 is ham and 1 is spam. Whatever the order comes, if there are 5 unique values, it will print all the 5. This will be 0, this will be 1 and so on up to 4. So this exactly tells us that ham is at index 0 and spam is at index 1. See, I just want to tell you that how many rows are there in our data set. Remember this, 5,572. And this y also will have the same shape. This y will also have the same shape. Of course, it has to because it is the same thing. Now, if you look at y, I'll show you y. So if you look at y, this is how it looks like. But y is like this. But machine learning models want it as a column, na? For ML model, this format is not acceptable. This format is acceptable. Correct or not? It has to be like a column, not a row. It has to be like a column. Yes or no? That's how it is at X and Y. And then we ask to fit. Yes. So we need Y to be in the shape 5572, 1. It is of this shape, but we want it in the shape 5572, 1. Currently, this is the shape, but we want this. So I say reshape -1, 1. So over here, -1 means unknown dimension and 1 means one column. So if I say y is equal to reshape -1, 1, and then I print y, First, you look how y looks like. It became vertical. How it was, what was the shape, and how it became, and what is the shape. So you can see it was like this. Now it became like this. The shape was 5572, comma. Now it became 5572, comma 1. You have to do it. You cannot skip that. After dividing the data into x and y, the next step is, of course, my x also is now in a textual form. But now the next step over here is to have train test split. So splitting the data into training and test data. So let me import the train test split from sklearn. We already did that, but I'm doing it again. Import the train test split. After doing that, I say we get the following parts: xtrain, xtest, ytrain, ytest, x and y given, test size also given. What is the important thing that is left out after this? It suggested incomplete thing. What is one important parameter that we need to initialize to ensure we are having the same reproducibility? Yes. Now, I am going to take a little different approach because I don't want to give you the same thing every day. So, what am I planning to do is now my y is sorted. My y is sorted. Be it y train or be it my y test, both of these are sorted. That's how my y train looks like. That's how my y test looks like. But the problem is the x train. That's the problem, because x train is still in the textual form. And can you apply one hot encoding or label encoding on x train? Can we apply one hot encoding or label encoding on x train? No. Right. Number of columns will be far more, or rather, a more simpler way to tell it would be this column is textual in nature. This column is textual in nature, and one hot encoding or label encoding is to be used on which type of column? Categorical column. That's a perfect word, Akash. As Kumar said, categorical column. So here, this is not a categorical column. This is a text column. So it will not work well. No problem. So I say, since x is in text format, we will now have to convert it to numerical format. So let us process the data. So the first thing which I am going to do is I am planning to tokenize the data and convert the text to sequences. Then after that, I will be adding padding to ensure that everything is of the same shape. I am planning to consider the top 1,000 words or the top 1,000 frequently occurring words. So I'm taking a variable called as max words is equal to 1,000. We'll see that later. I'm creating an object of the tokenizer. But before that, import the tokenizer. Okay, from TensorFlow.Keras.text, we import the tokenizer class. Then we create an object of the tokenizer by this name. Now, while I'm tokenizing it, what am I saying? There may be n number of words which come. I say only consider the top 1,000 words. Only consider top 1,000 words. So I'm saying that consider the top 1,000 words. So now I will say, let's fit on the tokenizer. So the method which I use over here is the fit on text. So fit on text is going to update the internal vocabulary based on the list of words. Like for example, if you have a sentence, the cat sat on the mat, it will convert it to this, and further it will convert it to this. So what is happening is a sentence, the cat sat on the mat, is first tokenized, and after tokenizing, it will be giving one unique number. This is given 1, cat is given 2, sat is given 3, on is given 4. Because the came again, it is again repeating the same number 1, and then fine. So this is how fit on text works. And once that is done, I will have to convert that text to sequences. This is exactly what is happening, right? So first this is fitting on text, and then after that is done, we convert the text to sequences. So I say sequences is equal to text to sequences, and text to sequences converts it where I can say example, the cat sat on the mat got converted like this. I can show you the sequences, but let me first run it. See over here, this is how the sequences looks like. So the first sentence inside xtrain, what was the first train sentence? Let me show you. Xtrain dot head. So the first sentence, fine, do you remember me? This is converted like this. The second sentence, good morning, at the repair shop, the only reason I am up at this hour. This is the one. The next, we have pizza if you want. That's the next. Finish love you, and that's the one. I'm at home, and what time will you connect? So this time I'm not doing any stemming, lemmatizing, nothing. We are simply converting it. Did you notice? See, this is 33 and this is 33. So this is the fifth sentence. First word is 33, which is I am. And here also there is I am. That's why you see this also is 33. That's a proof basically that this is how the numbering is happening. Notice it. This is encoded as 33. So is this I am 33 here. This is right in this next sentence, second sentence, and here 33 is here. So just a way of tallying the things. But now you know what is the problem? See this first sentence, fine, do you remember me? This first sentence, fine, do you remember me, is encoded here. The second sentence, good morning at the repair shop, is encoded here. Then the third sentence, we want pizza if you want, is encoded here. Then the fourth sentence, finish Leo you, is encoded here, and so on. Now problem kya hai? What is the problem? This is of length 1, 2, 3, 4, 5. This is of length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is of length 1, 2, 3, 4, 5. This is of length 3. So basically, every sentence, or I would say, every tokenized sentence is of different length. If you recall machine learning, how did we have any problem solved? How did we solve any problem? We had independent variable 1, independent variable 2, independent variable n versus y. Then row 0, row 1, row 2, right up to row n, or let's say row m. So essentially, here then we did the train test split, etc., etc. But what is interesting to see is, if you look at this, this zeroth sentence is of length n, then the first sentence is also of length n, second sentence is also of length n. Similarly, this is also of length n, this is also of length n, and this is also of length n. But here we are not having that. So how will the machine fit the relationship between X train, Y train? Although it is converted to numbers, it will not be in a position to fit the relationship between X train and Y train. And this is the problem over here. Right. So that's a problem. And now the thing is, how can we solve the problem? Well, how can we solve this problem? Well, I am thinking of solving this problem by doing padding, by adding null values. Okay, that's good. So what am I going to do is understand this very, very carefully. So what am I going to do is, imagine you have sentences like this. This is 1, 1. This is 0, 0, 1. This is 1, 0, 0, 1. This is 1, 0. I have decided to pad them all. So while padding, it will first ask that you want to make it of what length. So if I don't want to lose any information, and if I'm planning to pad zeros before, what is the ideal length I should cover? Now consider a real life problem. In real life problem, is it possible that the vector is not of length 4, but let's say the vector is much, much longer than length 4? For example, will it be possible to have a vector of length maybe around 200? Possible? The maximum length, can it be 200? Easily possible. That means if you go to this older diagram, there will be 200 independent variables, which is too much. 200 independent variables is too much. And because that is too much, I am saying that I will consider few of them. So if I consider few of them, then there will be loss of information. Like for example, here, don't write anything in the chat. Here, let's say I am considering the maximum length to be 3. So if I'm considering the maximum length to be 3, then 1, 2, and 3. I am considering maximum length to be 3. So what is going to happen is, this 1, 1 would be written here, 0 added, 0 added. Then 0, 0, 1 is as it is, no padding. 1, 0 is written here, and you pad a 0. 1, 0, 0, 1. This 1 is dropped. This 1 is dropped. So there is a loss of information. I completely agree. There is a loss of information. Is that a good thing or a bad thing? I don't know. Can anyone help you out? The best of the best person in the field of data science, machine learning, Gen AI? No, no one can help out. Everyone will see the same answer which I said. Whether considering the length less than the maximum length is a good idea or not, no one knows that. Whether you should go for maximum length, or whether you should go for length equal to 3 or length is equal to 2, no one knows that. But listen to this. the most important thing is should be our aim? What should be our aim? While creating a machine learning model, we don't want too many independent variables. So the aim must be, can we try to select minimum number of independent variables and still get a model with a high accuracy so that my prediction is faster, my training time is slower. So that is what one should ideally think for. And hence, I am thinking about this strategy. So what am I thinking about it is, I'll show you what I mean. Let's go for padding. But before going for padding, I will like to print for you how many sequences are we having? 4736. So what am I doing? I want to go through each and every sequence. That is how the sequences looked, right? Let's say, for example, if I'm printing the length of 0th sentence, it is of length 5. Length of first sentence, second sentence, third sentence, fourth sentence, and fifth also. See, in fact, I'm printing the length of 500 sentence. I'm printing the length of 245th sentence. Randomly, I'm printing the length of this sentence because there are 4,000 sentences. I know that. Printing the length of this sentence. I'm printing the length of 650%. I'm printing the length of 15 sentence. Now what am I planning? In this figure, you quickly said that, sir, you choose the maximum length, which was 4. In our sentences where you have 4,736, I want to do the same thing. I want to find out the maximum sequence length. So what am I doing is, I am going to create an empty list and I will go through all the sentences one by one. So length of sequences is going to give me what? So precisely, this is length of 4736. So this is going to be going from 0, 1, 2, 3, 4, 5 to 4735. That means this is going to go from this one by one. And every time, what am I saying? That, okay, when I is 0, find the length of the sequence of 0. When I takes the value 1, find the length of sequence of 1. Similarly, it will go on till this. So all the length of each and every sequence are appended inside L. So I am printing the length of the, I'll write it properly. Length of the longest sequence is this. And then the length of the shortest sequence is this. So the smallest sentence is of length 0. Okay, there is something. I don't know how, but there is something. And the largest one is of length 171. That means if I am doing the padding, keeping the maximum length as 171, then there will be 171 independent variables. Just like here, you said there will be 4. There will be 171 in our case. See, let's visualize the length of sequence. Okay, I was not planning to do that, but let me see it. I'm getting that, so why will I lose that opportunity? See, longest and the short. So most of the sequences are of this. And I'll reduce. I will not keep the bench randomly. Right. This looks better. So we can see the longest sequence and the shortest sequence, and we also understand most of the sentences are in the length of this to this. Okay. So I am planning to keep the maximum length as 150. Now you'll be like, why, sir? Why are you keeping the maximum length as 150? I don't know. I don't know. You can further reduce it also. You can increase it also. You can keep it more than 175 also. More additional zeros would be added. You can even keep it at 75. You can even keep it as 50. What is the right value? I don't know. But before coming for the lecture, I had already tried, and 150 is, keeping the length as 150 gave me 97% accuracy on this problem, which I'm solving in front of you. This is the reason why am I choosing the maximum length as 150. Choosing the maximum, choosing the maximum length of the sequence as 50. I know 50 is again good, but I am right now going with 150 because I tried it earlier. You can play around with this. 150. So max length is equal to 150. So there will be truncation which is happening. So how to do that? So first, I will say, let's import the pad sequences from this. Now, this is where I want to take you through the documentation. That's good. Pay attention. This documentation is interesting for everyone. This is where you'll understand documentation, the importance of documentation. You will understand it now. Like, if you see here, they have given nice examples. They say, if you have 1, 2, 1, 2, 1, 2, 3, and 4, 5, 6, if you directly say pad sequences, then because the maximum length is 3, this is how it becomes. Similarly, if you say that, hey, wait, value is equal to -1, code is same. But if you say value equal to -1, it will not pad 0, it will pad -1. If you say padding is equal to post, that's another thing. It will pad zeros at the right-hand side rather than the left-hand side. So people can try out various things, right? Let us look at one last way, which is the one which we are going to take. Max length is equal to 2. So because max length is equal to 2, that means this 1 has come, this 2, 3 has come, and among this 4, 5, 6, only 5, 6 has come. So there was truncation. And this is exactly what is going to happen in our case, because I have kept the maximum length. I have decided the maximum length as what? 150. But yeah, very nice. You are getting the concept. I am more happy than you. I say, let's consider padding the sequences. So I'm calling it as sequences matrix is equal to pad sequence, and maximum length will be equal to this max length, which I'm setting over here. Now, by default, it will truncate because I have given the max length. And then I can print the sequence matrix. I can actually show you the shape of sequence matrix. You see, there are 4,736 rows, each of length 150. If I do the same code, now if I do the same code, not over sequence, but over the sequence matrix, you see, The longest and shortest sequence, everything is of length 150. Obviously, na, we converted it. And if I do the same code over this L, everything is of length 150. It's just that it is showing that bar like that, but everything is of length 150. Right? We are good to go ahead in building our model, but after we come back from the break. So far, have you found this case study interesting? After this, directly LSTM is going to start. Okay. Let's understand this. I say, let's build a model. So first I'll do all the necessary imports, but for that I have to import the required libraries. So the first thing, I am from Keras dot layers import input. That's the first thing which I have to import. Then after this, I also need embedding. Why, that we'll see later. LSTM also, dense also. These are things that is what we need. Then I will also say activations import. I want to import the to import activation. Let me just see. From Keras import activation. From layers dot activation. Okay. So I say from Keras dot, I can have activation also imported. And anything other than this I required? No, I think this is all done. Then I also need to import the model. And then I'm defining the RNN method. This is altogether new way of creating a model. Older, the way is the same, but we are doing it in a user-defined function. Like if you see, the first thing which I'm saying over here is I'm considering the input, and the input layer, I can also give a name to every layer. So I'm giving it the name as inputs. The name is just a pet name to the layer, right? So that input layer will be called as inputs. And the shape over here is the max length. Then I go ahead and add a LSTM. See, I am saying that create a LSTM to extract 64 features. Then I am adding a dense layer of 256 neurons, and I'm giving it a name as FC1, which means fully connected layer 1. It's my name. You can give any name of your choice. I didn't supply the activation function. I am supplying activation function as a class. This is also one way of doing it. Then I also want to have a dropout added. So I say I'm adding a dropout of 50%. Then finally the output. So dense layer of only one neuron, because this one neuron will be predicting either 0 or 1, which means spam or ham. Activation should be sigmoid. That's what I did. Then I say model is equal to this. Return the model. So we get this. So over here, we understand everything. So like in this case, we know this is the input layer. and the shape is 150. This is just like CNN. I have added LSTM. Then here I have added a hidden layer of 256 neurons. How is it hidden? Because activation is very low. Dropout. Then final output layer of 1 neuron, activation is sigmoid. And then I'm giving this. So now just understand, if I would have directly started with the text generation using the LLMs, and I would have put this code in front of you, you would have never understood what it is. Therefore, deep learning is very important before you get started with this. Now that I have this function, I will say, let me call the RNN function now. So I say model equal to RNN. Okay. So input length is decrement deprecated. That's okay. It says that just remove it and some other warning, but I think I can go ahead with it right now. And now I say, let's look at the model summary. Look at this now. The name of the model is model, which is written. So now see, this is the summary of the model. What it says, the input layer will be fed with 150 inputs. Then we have the embedding, which we just skipped. Then LSTM is 64 features. Then you have the fully connected layer 1. We named it as FC1, hidden layer, 256 features. Activation, same, dropout of 50% for this layer, dropout of 50%. Output layer of 1 neuron, activation 1. So total number of the weights and biases that will be trained are 96,337. Yet the training has not started, but these are the total number of trainable parameters. So now I say, let's compile the model now. Model.compile. Losses, binary cross entropy. Optimizer, I am planning to go ahead with RMS prop and metric is accuracy. So RMS prop is not defined. So I want to import this. So I say from Keras.optimizers import RMS prop, and then I do that. So once I have this, I will fit. So now I say fit on the training data. R is equal to model.fit. Our X is sequences matrix. If you have forgotten that, let me go up and show you. This is our X. We call it now not as X train, but as sequences matrix. So that is there. So this is X train and Y train respectively. Batch size I'm keeping as 128. Number of epochs I'm keeping as 10. Validation split I'm keeping as 0.2. And what is this callbacks? Let us try to understand. This is one of the very interesting thing over here. Right? By the time this is fitting, I'd like to explain what is early stopping. Now here, let's say this is epoch number 1 and this is epoch number 100. So when you start training a neural network, you see that accuracy of the model is on the training data set is becoming better and better. Right? You see that the accuracy of the model on the training data set is becoming better and better. And on the testing data set also it's becoming better and better. You're very happy. Wow. Continuing, right? It's becoming better and better. You're very happy, very happy, very happy. And you have almost reached around 60th epoch and you were very happy. And then all of a sudden, this accuracy kept on increasing, but this kept on decreasing. So let me also tell you that it took for it to go from here to here, it took around 20 minutes. So it is quite obvious that for completing this, it is likely to take another 10 minutes. Now you see that training accuracy is improving, but the validation accuracy or the testing accuracy is decreasing. But you will not be able to stop this training, because if it is stopped, you will not be able to use that model. So you will have to compulsorily wait for this execution to complete. And only when the execution is complete, you can go ahead to some other neural network. But early stopping says that, hey, I can help you out in such situation. If I see that this is increasing, but this is decreasing, I can stop that process for you right on the 60th epoch. I can stop that process for you right on the 60th epoch. Now let me explain you how it can help us. Here, if you observe in this, I asked it to train for 10 epochs. Did it go for 10 epochs? It has a tick. That means execution is done, and it stopped at 5 epochs only. Because I was using the callbacks parameter to have a early stopping class. And what are we asking the early stopping to monitor? Validation loss. So I am saying that, hey, every time, listen to me very carefully, every time you keep on having a close look on this, and and here, every time you have a close look on this, and it says that keep on comparing the immediate two values. The difference between this should be minimum this much. That means minimum delta, that is the change in between these values should be minimum this much. If it is, awesome, go ahead. Now you get these values. Now the difference in between these two should be minimum this much. If that is good, go ahead. Between these two, is the difference between these two minimum this much? Yes, go ahead. Next one. Is the difference between this and this 0.01? If not, stop. Therefore, it stopped on the 50 epoch. Basically, I can play around with these values where I say that minimum I want this much change. Then only I will continue the training. Again, you can play around with these values. This is considered to be one of the best starting points. Some people also give at 0.001, but I would recommend you to start by this. So I can just put in some notes for you. Best values of minimum delta are this. And there is a patience parameter as well. So patience parameter basically says that, hey, if you are not getting a minimum difference of this, then okay, I will tolerate it one time. I'll tolerate it 2 times. If this happens for 3 consecutive times, I will stop the training. So that's the patience. It's like I slap you once. You are like, okay, fine. He is our professor, no problem. I slap you once again. You don't know this much? You're like, okay, fine, sir. I slap you one more. And now you are like, now it's enough. Now, whosoever he is, I am also going to slap him back. That is your patience. In the same way, we are discussing about patience in epoch. If for 3 consecutive times, the difference is not minimum this much, stop the training. Patience. So these are the good values of patience that you can try around. And that is the concept of early stopping. You can also see this over here. They have written it down also. What is minimum delta? Minimum change in the monitor quantity, which is our validation loss, to be qualified as an improvement. Patience is the number of epochs with no improvement after which the training would be stopped. So I have these all things in place. So let me also keep some patience value. So murder quantity is this, and I'm keeping the patience over here as yesterday I tried 4. So I'll try to keep the patience as 4. And let me retrain it. Or it stopped here only. Okay. After that, after that, you know the code. What is the usual step that we do after fitting? Does anyone recollect? What is the usual step that we do after fitting? The next step is plotting the loss per iteration. I am very hurt today. This is what is the loss per iteration that we have got. It went up, down, and this is what is the status. Also look at the accuracy. So this is the accuracy. And I can also say print model dot evaluate this and print on this. And we are getting a 99% accuracy on the train data. So model is performing very good on the train data. I will now like to go ahead with the X test as well. My X test is still in the text form. So can I directly use X test for printing? So can I directly use X test for prediction? No, it has to be converted to first sequences and then padding the same way. So I say I'll process the test set data. So I call it as the test sequences. So I'm converting using test to sequences. And then I will say I will pad it to the max length as 150. Then I can print the test sequence matrix. But everything is now of the same format. And the shape is 836, 150. Now I can evaluate the model on the test data set. So accuracy on the training is model.evaluate on this. And this is what I say. And I can just say print testing set loss and accuracy. So you can see on the training data, I was having how much? I'll just print it again. On the training data, I was getting accuracy of 99%. On the test data, 99.7, and this is 99.45. So it is not overfitting. And the loss is 0.01, and here the loss is 0.02. Sorry. On the training data, I'm getting 99.45 on the train, and on the test, it is 98.6. The loss on training is 0.02. Here it is 0.05. So overall, I see it's a good model. Overall, I see it's a good model. Now, if I say, for some reason, if I say that, let me try to keep the maximum length, which was 150. If I just keep it as 50, let's see what happens. So initially, what was it? These are the results, right? I'll just copy it, share it in the chat, and then I'm saying run all. Let's see what results we came after running it. Now it will start training after this. All 10 epochs ran. See, these functions are good. And here also it's good. And the last one, see, accuracy came 99.7, 99.51 and 98. Little improved. So on the earlier one, we had 99.45. Now here I have 99.51. And on the test data set, in the chat, I see it is 98.6. This is 98. So test data set accuracy reduced a little bit. So I think the earlier one was better considering more features.
Thanks for joining this complete 10-hour journey into machine learning and deep learning. If you have followed along, you now understand essential ML algorithms, neural network fundamentals, and advanced deep learning architectures, along with hands-on Python implementations that you can apply to the real-world projects. If this masterclass helped you, then support this channel by subscribing and liking the video, and share it with anyone who wants to learn AI. And also guys, do not forget to leave a comment. Till then, keep practicing, keep building, and I'll see you in the next one.